Germany or China or wherever we are going. So water regulations. So this is something which is very common. And as you remember, 2 years ago, I gave a presentation related to quality of water for galvanoplating. So this is something where everything have a big influence from water quality, molding conditions, type of plastics, and regulations and specifications and needs of the customer in the industry. But let's move forward. So one of the most popular changes at the moment, where everybody talking about, is not, surprise, surprise, hexavalent chrome, but PFAS. So a lot of industries, a lot of regions asking for PFAS-free products. So what this means? A lot of product processes have to be rework, modified, or develop new one to be sure we are totally PFAS-free. So in many regions, you have different regulations. In North America, for example, in the area of Michigan, this is a big pressure to be totally PFAS free. In Asia, as you know, they started slowly, and Taiwan already have a list where PFAS is already on the discussion, and few other countries in Asia are doing the same. In Europe, in reality, is no clear regulation, but you have some countries where PFAS-free processes are very important. However, if we look to the product and processes here, just examples where we as a chemistry supplier are looking after to deliver to the customer, to the industry, what is requested. So this means we rework, for example, we're developing new trivalent chromes, which are totally PFAS free. We are talking about wetting agents for chrome edge or chrome free edge. So the chrome free edge in our case is totally PFAS free, but we also was working on wetter which for chrome edge, which have to be PFAS free. So this means the movement is very, very, I say, driving the industry and the development in the companies. Additionally, of course, as you know, I talking always about the 5 Rs. The 5 Rs mean reuse, rework, remanufacture, repair, and reduce. So this means we are talking about sustainable and recycling management. So this is something which we're really looking for. And for example, for plating on plastic, we are not talking only about metal reduction, waste reduction. We're talking about reduction and usage of rework plastics, which is, to be honest, now very popular too. So we're talking about CO2. We're talking about microplastics, so which is touching not only plating on plastic, but also painting industry and others. If we talk about the industries, what we are looking for, what are the trends, what is the technology, the needs and requirements? If we look to decorative coatings and plating on plastic, we're talking about the environment. The chrome-free edges, trivalent chromes, we're talking about industry requirements, as every industry have different requirement and needs. We're talking about metal plating. And metal plating, we're talking about stainless steel, thin die cast. So many, many different stories. We're talking about selective plating, which is very common. We're talking about 2K, 3K stop-off lacquers. We're talking about combination of different type of materials. We're talking about lightning in combination with plating on plastic, for example, for automotive, for sanitary industry. But what we forgot a little bit in decorative coatings and plating on plastics, that decorative is not always decorative. We also have functional application. What does mean? Functional application, they are not looking to the beautifulness. They're looking more to the technical performance. I will talk about this a little bit later. So, of course, production proven chrome free edge technologies are on the market for more than 6 years. And we also know that the processes are giving you very often much higher adhesion than, for example, hexavalent chrome edge. However, what is very important if we go to the industries, trivalent chromes, the styling, the trends. We are talking about white to dark trivalent chromes. We're talking about chloride and sulfate-based trivalent chromes. We're talking about mix of bright and matte finishes. If you look to the portfolios, you see maybe only few products But in reality, with these products, combined with the satin finishes, you can create more than 60 different finishes and colors which are requested by the industry. If we look to the trivalent chromes, a lot of people are worried last year, 2 years ago, if, and the question was, do we can match the color of hexavalent chrome with trivalent chrome? Yes, we can. And what is so important if we are talking about trivalent chromes, then more and more darker the trivalent chrome is, then less and less include the chrome in this layer. So this means the darker chromes are showing up, like I call them alloys, because it's a mix of many ingredients. To answer the question, do we are really close to hexavalent chrome? Yes, we are. If you look to the study, what we did with one OEM, you see here the stability of the white trivalent chrome versus hexavalent chrome. And surprise, surprise, most of us, we never probably was checking the stability of hexavalent chrome. But if you look to the LAB value, so the red dots are the hexavalent chrome. This means the hexavalent chrome, if you will really control the hexavalent chrome, have wide working window related to the color scale. But if you look to the blue color, this is the trivalent chrome. This means if you're using white trivalent chrome, you will be always in the middle. You are always will be close to the hexavalent chrome. So based on this, the new, the modern, the novel trivalent chromes are so close to the hexavalent chrome that if you will mix and match hex chrome with trivalent chrome, you will not see the difference between the colors or the technologies. Additionally, a lot of people asking why do we using or recommending in the industry some passive post-tip or passivation for trivalent chrome. Of course, we have a lot of discussion. Yeah, you need this for more darker one, but you probably don't need this for white colors, but I will always recommend to use a post-it. As the post-it give you higher cast performance, increasing NSS, as well, especially for dark finishes, the post-it avoiding the discoloration or the creation of the black spots on the dark finishes. So this means you're also avoiding the influence of the humidity on the dark plated parts, which is a big, big advantage. Very important. I talked about this last year, so this is why I only mentioned this today. Trivalent chrome for barrel applications. Everybody talking about rack application for different industry segments, but rack is a big portion of the industry. But don't forget, barrel application are many of them on the market, and the request came to have trivalent chrome for barrel. So this is where we developed, as I mentioned before, 3 years ago, trivalent chrome for barrel applications, which is in the production. Of course, we also will recommend the post-tip related to the process, but it is possible to have barrel in trivalent chrome applications for all the type of industries which are plating small and middle-sized components. What is so important? If we look to the trivalent chrome with barrel application, you have few things which you have to follow up. First one is, of course, the barrel design. You have the type of the barrel, the performation, the barrel load, rotation, process parameters, equipment, and anodes. So I will not talk about this today as I spent time last time about this. But yeah, this is very important topic where we are really have to look after if we're talking about barrel for trivalent chrome. Let's go back to plating on plastic. As I mentioned before, most of us forgot that plating on plastic could be used for decorative application and for functional application. What does mean in reality? We're talking for functional application here about mostly engineering plastics. One of them is, for example, PEEK. PEEK is polyethyl ethyl ketone, or we have different others like POM, PPS, and others. The standard type of plastics for decorative is ABS, ABS-PC, polypropylene, polyamide, and others. They are the most one which are used for decorative finish. If we talk about chrome-free edge, you can use the chrome-free edge for both systems. We can use this for direct metallization, you can use this for conventional system, but also for engineering plastics, which I will talk in a few seconds, and for standard decorative finishes. As I mentioned before, the chrome-free edge processes very often giving you much higher adhesion than, for example, existing chrome edge systems. In reality, when we are looking also to selective plating, what I mentioned before, I'm talking about 2K, 3K, stop of lacquers, which are used, for example, for in fashion and cosmetic industry. This is something which is very useful. Also, automotive industry using more and more selective plating, especially for the interior or for the emblems. So this we're seeing that the market and the styling is changing. So I just showing here some examples only. There are reports from customers to show you that, yeah, selective plating is a big portion now from our industry segment. If we look to functional applications, functional applications, engineering plastics, we are talking here from USB to medical components where this could be used. So the requirements and the needs are huge, and also the type of plastics. If we look to the applications for plating on plastic, one is correctors, another is interconnectors components, and of course, we cannot forget the shielding applications for different industry segments. I'm not talking here only about EV applications, but also for different industries. What is important if we look to the application? Important is choose the right material, base material. Use the right process sequence, as the engineering plastic are different. Some of them have glass fiber, some of them not. Some of them are more harder, some of them need very high temperature. So thermo management I'm talking here about. And of course, we have to look to the application, the final product, and last but not least, the specification which we have to fulfill. Here, one example of the plastics which are used mostly for functional application like PEEK, PPS, LCP, PI, and others. So for you have different categories. You have the head profile, you have the resin type, and the application. I put here just one simple example of the process sequence. But as I mentioned before, don't forget, you have to make the choice, the right process sequence, and the right type of plastics and the requirements to be fulfilled. So this means plating on plastic is not only decorative, but also functional, which, as I mentioned before, is big portion of the business. And last but not least, we have to remember, in reality, we're talking about sustainability, we're talking about environment. You know me in the industry for many years. I will never use environmentally friendly. We are not friendly to the environment. We are responsible for the environment. We have to look and looking to develop the right product and processes. We're listening to the industry needs, to the customer needs, to give you not just only the chemistry, but we as a supplier of chemistry and products, we're giving you the solution. We're talking about additionally about cost saving and environmental benefits. Thank you so much.
Nice presentation. Any question is there, please? Do you have any question? Thank you. Nice presentation, Maria. Good, you have enlightened. This is the plating and plastic, the emerging technology, not only decorative but functional also. Good, nice presentation. Thank you, ma'am.
Thank you so much. Thank you.
Thank you. Our next presentation, Mr. Praveen. Now I call upon Mr. Praveen. The topic will be right aluminum and lethal metal coatings. I am pleasured in giving the biodata of Mr. Praveen. He is the Vice President in Ronak Group for the past 25 years of metal finishing and electroplating, industry experience in technical skills, worked in multiple companies, Enthon, Satek, Grover and Will. Over to Mr. Praveen.
Thank you, sir. Good morning, ladies and gentlemen. Today we'll be talking about the various types of coatings possible along with the, especially focusing on the pre-treatment part. We wanted to cover all the light metals, but due to the time constraint, we'll be only focusing on aluminum. So most common types of coatings we see in the industry are passivation, anodizing, electroplating, and painting, powder coating. So I'll be covering these types of coatings today. So in the passivation segment, the most commonly used products are like conventionally the hexavalent chromium products, which are more or less getting extinct right now, and the trivalent. The and also there are some new technologies which are totally chrome free as well, but due to the performance improvement with trivalent chromium, it is still accepted as a environment friendly process for pre-treatment and also as a final finish. This can be applied on various aluminum alloys. So typical process sequence includes, depending on the alloy and the pre-treatment, like if you have a short blasting, then the third step can be eliminated. This common sequence in like most of the metals, alkaline degrees, then rinsing and alkaline etch. And in some cases, if you are looking at some special finishes like brighter finish or like we do have something called a pearl tone finish. In that case, the steps will further increase. Then the acidic deoxidation or desmutting, which is used uh, especially to remove any left out smut from etch or from the alkaline degreasing part, and also to etch the substrate a little bit. And post rinsing, then we go to the passivation step. Hexavalent is pretty simple, and trivalent needs good quality of water and proper pre-treatment. After that, top coat would be optional based on the performance requirement. You can have an additional organic or inorganic top coat based on the, if it is not getting painted, then top coat is needed for getting, more than 96 hours of corrosion resistance on specific alloys. But if we are going for a painting, then top coat should be avoided because it might result in failure of adhesion to the paint film. So hexavalent chromium, as we all know, it's called chromating, and it's very old and proven technology, very simple, easy process controls. You can have a lot of pre-treatment steps, and the performance is, of course, hexavalent, being hexavalent, it gives the best performance. But of course, it's hazardous. So most of the industry, like chemical suppliers, we are now slowly moving away from hexavalent chromium based process. So straight away jump to the trivalent chromium process, which is of interest to the current industry. We have a product for passivation, which means there is no further coating. In this can be applied for various alloys and pure aluminum series, as well as copper and silicon rich alloys, which is REACH compliant and with improved EHS conditions, of course. This is a liquid chromium, trivalent chromium based solution, which gives excellent bare corrosion resistance, going as good as 240 hours without top coat on certain alloys. But the standard is between 96 and 160 hours without any top. This can be done on, like I was talking about, all types of alloys, including cast aluminum like ADC12, A356. And this can be used as a one-step solution in the same line for all types of pre-treatment, like either it is just a passivation or it's going for powder coating, or it's going for as a sealing for anodizing as well. So the line can be designed in such a way that this single process can be used for the same, for the multiple applications, final finishes. And this can be applied in various ways like immersion, spray, wiping. In some cases, it can be used as a touch-up pen to cover the uncovered, unanodized areas or uncovered paint areas to do a repaint, retouch-up kind of. This is quite popular in European and American countries. In India, it's slowly getting momentum. I think still the four-wheeler industry has moved very aggressively to this technology, but two-wheelers have about, I think, if I'm not wrong, around 3 to 4 years back, Hero Motors has already started switching to this technology, and we are expecting more two-wheeler industries also to be going into the trivalent chrome-based or chrome-free pretreatment processes. The advantages, like basically, even though it's not better than hexavalent, but it gives as good as hexavalent chromium level of corrosion protection. The color is slightly lighter. It's very pale yellow to light bluish color. Even though we have developed something where if customer is looking for some differentiation of the coating, if there is no further coating and they want to have a idea of whether the coating has come or not, we do have a process which is colored, but again it is the coating doesn't have a color. We add a dye to get the color kind of. So this we have developed in partnership with some of our European counterparts, and we are now planning to probably, once the scale up happens, we are planning to manufacture the product in India to make it more commercial viable. So this another special advantage with this coating is this is conductive before and after NSS testing. This is required by some of the aerospace components where they would like to have a conductivity even after the part has corroded. So in that case, they do the coating, salt spray, and again check the conductivity. So this can pass that test as well. And in addition to the corrosion resistance, this, like we already discussed, this is compatible with the standard painting, lacquering, powder coating processes, as well as a sealing. We'll see in the anodizing part where the same product can be used as a sealing compound as well. So this meets all the environmental compliances along with MIL DTL 81706 on 2000, 6000 and 7000 series as well. And the paint standard what is needed mostly is, this is one of the stringent standard where there is no peel off allowed at all. The grade 5B is like absolutely no peel off of the paint as per ASTM D3359 after 14 days of immersion in water at room temperature. And this is also approved by major global aerospace OEMs and some of the automotive OEMs as well. So in India, we are in the process of launching this product to the automotive sector. So we hope like maybe by next session we should have all the automotive approvals as well. So the next part type of coating is aluminum anodizing. I think a lot of lectures going on this, so I'll not be going very deep into this. It's, as you all know, this is uh, cathodic oxide layer for durability as well as decorative application. It's widely used in the aluminum industry, and if I'm not wrong, maybe more than 90% of the coating, like if it is non-painted, it's mostly anodized, and it can majority is, I think, more than 90% is aluminum, but even magnesium and titanium are also being anodized, especially in the aerospace sector. So it covers most of the industries. Now, slowly, it is gaining more momentum into the even the construction industry, like windows in India as well. Simple diagram, photograph of how the process happens. It's exactly the reverse of the electroplating process, which we are all aware of. The typical process sequence, nothing much different from the passivation, except that post desmut and rinsing, then after the anodizing, we have to do sealing, and in between you can do coloring. Various colors are possible, both in immersion as well as in electrolytic way of coloring. So architectural industry is one of the major industry where the coloring happens, and in case of functional requirement, mostly there is no coloring, it just goes as it is. But in special cases like where you need cosmetic appeal, like very bright finish, we need to add some more steps in after the deox stage to make it more brighter, and also like we can have a bright plus pearl tone finish. What we call is like more like a satin nickel kind of a finish, where it is whitish satin finish, and then we can go for uh, different colors, either in electro coloring from cream color to black, or like non-regular colors, which will be shown. The sealing has multiple ways of operation. One, the most popular is hot water sealing, but due to the economics and electricity consumption, there are a lot of products which are applicable, which can be used at room temperatures. And the one what I spoke just a few slides before, the trivalent chrome based product, this can be used as a sealant, but the temperature is room temperature. When we can say for Indian conditions, yes, but not for European countries and American countries where the temperatures are low. This operates between 30 to 40 degrees centigrade. So the sealing is environmentally compliant. There is no nickel. It's only trivalent chromium based product. So what Ronak offers is the Eliprep series of cleaning and conditioning, and a little picture of how the structure is modified. You can see the initial stages. First phase is the conditioning, where we have the removal of all the oils, greases, and then there is a micro etch. And then desmut, where the oxides formed from the alkaline etch are also removed, smuts formed are removed, and also little penetration into the substrate. Then we go for the anodizing step, where based on the final requirement, we go for the brighter, the regular functional one, brighter finishes, or for functional finishes where we do go for a harder deposit. The typical thickness ranges are between 10 to 20 microns, and the pore sizes roughly about 20 to 40 nanometers. Stage 2 of the process is the Go series dies. I'll have a photograph in the next slide where we'll show the different colors possible. And the Select series is a high temperature series where the operational temperatures are around 70 degree centigrade. And if we are looking at an environmentally compliant sealing, then we can avoid nickel and go with the trivalent chrome based product what we use. It's just a process overview where you various stages. The Aliprep series, like we said, like we can go with bright, semi-bright, satin, pearl tone finishes, and the Go series of dyes which give different colors, and the sealing Aliprep Select series, which gives the ceiling for whatever finish we have given in the initial stages. And if we are looking at a nickel free and environmental friendly process, then yes, it's Eliprep TC series. So I'll speed up a little. These are the different colors. There are multiple more colors possible, but these are most common colors being used in the industry. So now jumping to the electroplating and electroless nickel plating, because mostly in electroless processes only the nickel is popular in on aluminum. So for electroplating, it's actually a subject of its own, because there is a special segment of alloy wheel plating, which is a pretty lengthy sequence, but I'm just covering our general plating process, where the pretreatment is pretty similar up to the deox, and then later on we go for a double zincate for improved adhesion, and then go for alkaline copper stride. Predominantly in the past we used to use a cyanide base, but now we have come out of the cyanide base and now we are going with the alkaline technology. And post which we can go with the electroplating of choice, like acid copper or tin, acid copper tin, and then vice versa, whatever you want to plate for. In case of electroless nickel also, the pretreatments remain same up to zincate. Then we go for an alkaline electroless nickel plating strike, and post which we go for like various different types like mid P, low P, high P electroless nickel processes. So we Ronak provides the Aliprep series of cleaning and conditioning, and electroless nickel is NIFOS Shield and NIFOS Ultra. In electroplating processes, we have alkaline and acid copper, multi-layer nickel, hexavalent chromium, of course, but we are not promoting that much. And trivalent chromium plating, we have a lecture tomorrow in details about the trivalent different types of trivalent chromium processes, as well as bright, as well as the functional parts of it. So in case of painting, again the same, hexavalent and hexavalent free. Pretreatment remains predominantly the same, except that we have to post the deox part. We go for the hexavalent chromium or chromium hexavalent chromium free pretreatment, and then we have to dry. And this drying, if we are going with trivalent chrome based process, Aliprep TC, the drying temperature should not exceed 80 degrees, preferably 65 degrees, because this creates a problem called filiform corrosion. The film breaks. So once it is cured, then it is fine to preheat or pre-bake. But this is commonly asked question by most of the painting companies, where they would like to directly go from pretreatment to the paint shop. But in this case, we can go, but there has to be a little break that let the film be cured. Ideally, it should be a day. We should leave a day for the film to be cured properly, and then we can go for the pre-bake, which is about 150 to 200 degrees, and then powder coat paint and then curing. So that's it from my side. So any questions, I'd be more than happy to answer. Thank you very much.
Thank you, Praveen. Nice presentation. You have covered almost pre-treatment to finishing, not only aluminum anodizing, but in electros nickel also. Very good. Thank you. Now the next presentation by Pinar. Welcome, Pinar. The topic beyond finishing line, functional and decorative coatings on aluminum. It is, it is my pleasure to have a biodata of Pinar. Received her BSc and MSc in Metallurgical and Materials Engineering program in 2012, 14 and 2010. She is also a PhD program in the same university. She has 9 years of experience in the aluminum surface treatment industry. Currently, she is working as a global technology leader for LMS Group and McDermott Enthon Industrial Solutions. She has hands-on laboratory experience in XRD, Raman spectrography, SEM and EDS spectrometer, glow discharge optional emission spectrography, XRF, and angular election spectrometer. Welcome to Swan. Hand over to Pioneer.
So, hello everyone. I'm Pnar, and thank you for a nice introduction to Chairman. So today I try to give some insight about McDermott Anton approach on aluminum surface treatment, and probably many of you are already aware of who is McDermott Anton, but we are a global company and we are a really technical team. Actually, maybe 50% of our employees are technical, and we have seven, I believe it's now 9 R&D in the globe, and one of them is in India, Bangalore, actually. And in McDermott and Son, we have a global team called Light Metal Solution. This group only working on light metals, which means aluminum, magnesium, and titanium. So as previous speaker mentioned, we have to protect aluminum against environment because it's amphoteric. It will react with the alkaline medium, acidic medium, as well as atmospheric conditions. So we have two main way to protect the surface. It can be passivization, conversion coating, or anodization. We need to select the right surface treatment according to final user and the requirements, obviously, but we need to aware of the cons and pros. For example, if we would like to have a hard surface, then the anodizing will be the right choice because by using the right electrolyte, by tweaking the parameters, we can obtain hard surfaces. On the other hand, if we need to conduct the surface for post-treatment, like welding, structural bonding, then we need to go with the conversion coating. Both of them will provide a certain level of corrosion protection, obviously. And another benefit of anodizing, we can color it by using different methods like electrocoloring or immersion coloring. And the two main industry for aluminum usage are automotive industry and architectural. Obviously, we have packaging, consumer goods, uh, aerospace, and you name it. You can find aluminum almost every industry. And according to the industry, we have a really diverse portfolio. because every industry needs their own performance criteria. And according to that, we have different brands. One of the biggest topic with aluminum is the base metal itself, because for passivization or ionization, we are creating the conversion coating or the anodic oxide layer itself by using aluminum. So according to base metal, our quality, the parameters, and the selecting protection methods should be adjusted. So one of the biggest topic right now in India and in globe is recycled aluminum or secondary aluminum, because we are trying to be a more environmentally friendly. We would like to get some benefit from the alloys. Obviously, we need alloys like copper, zinc, iron to get certain level of ductility, mechanical strength, and so on. But also, all of the alloying elements come with some obstacles. And if you look at this chart, generally the secondary aluminum is more eco-sustainable, and we are getting 95% greenhouse gas less when we use recycled aluminum. Maybe the aerospace is one of the most diverse industry about the aluminum alloy. So actually start around beginning of 20th century. First, they only used 2000. It is copper-rich alloy. And because it's more ductile, the fatigue resistance will be better. And during the time, they developed new alloys. So currently, maybe we have hundreds of thousands different alloys in industry. And not only the aluminum alloy itself, also we need to be careful about the heat treatment. It should be T4, T6, work hardened. Is there any overaging? So these kind of stuff are really important to get the right surface quality after surface treatment. So as McDermott and Tom, we have a total we can able to do that chemically without needing any other mechanical treatments. So from this structure, this is a microstructure of the caustic edge part, we can go to the left-hand side one for you. And thanks to that pinholes, of aluminum is in automotive industry. You can find aluminum in the brakes, wheels, or some other decorative application like trims and roof rails. And the requirements are different for each segment. Sometimes they are looking for only corrosion. Sometimes we need really, really glossy black finish. And I would like to continue with the first, the Chrome 3 application for in automotive industry. It can be for paint or it can be for bare corrosion. Again, as McDermott and Ton, we have a total approach. We need to know the base metal. According to the base metal, we are selecting the right pre-treatment. So we are not able to, or we are not suggesting the same pre-treatment for the 6000 series and the cast aluminum. In the cast aluminum, you have minimum 6% silicon, which is non-anodizable, and also is inhibiting the conversion coating sometimes. So the selecting the right pre-treatment is really critical. Then cleaning, activation, and the passivization will follow. So one of the alternative to Chrome 6, obviously Chrome 3. This is the greener alternative, which has really, really similar corrosion protection on the surface. In this situation, we are using the bimetal technology to get the benefit of the complex oxide structure on the surface. This is really thin structure, which is not really changing the surface conductivity, which is beneficial for the post-treatment like welding and the structural bonding. So these are some of the corrosion results that we are able to get the right pre-treatment combination with TCP-AL. This is single pack product. We also have 2 component products to adjust the surface properly, because some of the application we need a high corrosion protection, not adhesion. And sometimes we need really high adhesion properties and the corrosion can be on the second priority. So we can adjust with our chemistry. So the key thing I would like to show here, especially the corrosion protection on the 2000, 7000, and the cast aluminum. These are really, really promising results. For automotive industry, especially battery cases and for structural components, we are looking for the adhesive application. After passivization, we need to apply generally epoxy-based glue to connect two other parts to each other. And these are some of the results from the pull-off test. Basically, we have a special device to measure the force you need to separate the glue to the base metal. We are not really, as R&D or the technical people, we are not really fan of the pass and fail. So that's why we always would like to work with the numerical values. Another application in automotive is decorative application. In this situation, I'm talking about the roof rails, trims, and some interior parts. And one of the biggest challenge of the OEMs, actually the alkaline resistancy or the weatherability problems. Because currently we are not really able to control which kind of detergent that they are using in the car wash system. And to be quick, generally they are selecting really alkaline solutions. And it's really damaging the oxide layer, because on the oxide layer normally only stable between 48 pH. And if we are cleaning our components pH 12.5, 13, then it will damage the surface. There will be color differences, there will be attack, and so on. And also the sun, dust, the sea atmosphere, everything is super effective on this decorative components. So normally in industry, how they overcome this problem is after anodizing, sol gel and different type of paints are applicable, especially if you would like to have the black finish. The applicator needs to go with paint. So they literally needs two different lines, anodizing, then paint. And you need to control all of the parameters accordingly to reduce the scrape ratio. And in such a line, the scrape ratio will be approximately 25% to 35%. You need to be super clean in between the procedure, which is really tricky to manage. As McDermott and Ton, we come up with an idea. We said, if we go with only anodizing and electrocoloring, which is highly UV stable, so approximately in 50 years, there will be no color bleeding. And if we can have such a sealing, can protect the surface not only from the classical corrosion, but also from the alkaline solution. So that's why we create Alkalat 130 system, which can be applicable for both clear finish and black electrocolored finish. So the idea is, what is the most resistance thing against alkalinity? So it can be plastic, which is slightly tricky on aluminum actually, or it can be glass-like structure. The aluminum oxide itself already super durable system, but if we can bring some complexity to this oxide, we can get benefits of the alkaline resistancy. So for that purpose, we modified the classical nickel-based cold seal, and it's followed by a modified nickel-free hot seal, let me say. Generally, we are able to operate between 80 centigrade Celsius to 100 centigrade Celsius, and creating a really composite structure with the different oxide morphologies. And all of the OEMs has their own specification. Some of them is only asking for 12.5, some of them asking for some copper accelerated salsa spray. But this is an summary what we can accomplish by using only right sealing and ionization procedure. Obviously, we need to be careful about the oxide layer structure itself. So the magic start with anodizing. It start with the pre-treatment, selecting the right pre-treatment, creating the right oxide structure on the surface, and by applying this specific and special sealing, we are able to accomplish almost all of the OEM's requirements. I need to put a disclaimer here for pH 13.5. Generally, pH 13.5 is not requested from anodic oxide layer. This is OEM specification for duplex coating, which means first anodizing, then they need to go with the clear coating. But probably we can say, even with a single stage of procedure, anodizing and right sealing, we accomplish almost all of the requirements from the duplex coating. So currently the sustainability, different alloy, recycled aluminum, fast and wrong extrusion quality. These are the challenge, but from this challenge, we are able to create the new solutions, and always the sustainability and productivity for our customers, our main focus. So thank you for listening.
Thank you for excellent presentation. Our next speaker, Mr. Ranjit Singh. The topic will be acid zinc nickel alloy coating has emerged as highly important surface finishing process in the past involving automotive industries. It is my pleasure to introduce Mr. Ranjit Singh, the General Manager, Technical and International Businessman from Artec in Artec Surface Finishing. He has done handling marketing, product development, and coordination between market requirements and R&D. Actual in understanding customers' need, supporting new product development, and managing the China market for 15 years with regular technical and commercial interaction. Over to Ranjit. No, no, go back. No, no.
Good morning, ladies and gentlemen. Today I will be presenting about acid zinc nickel plating. Acid zinc nickel is actually zinc nickel is not a new thing. Everybody is aware about it. But mostly people are using alkaline zinc nickel. But today we will discuss about acid zinc nickel. Nowadays, acid zinc nickel is getting more and more popular because of the customers' need, and some metallurgical changes have been happen, so the requirement of acid zinc nickel is being more and more popular. So actually acid zinc nickel is also not a new thing. It was originally developed in mid 90s. At that time we faces some technical challenges at production level, so it was not that much popular. And after that, nowadays, because of the basically in automobile sector and especially brake calipers, that is required, we have to have acid zinc nickel plating. So there are a lot of research and studies have been done. So nowadays it is getting more popular. Why we need acid zinc nickel? As I discussed just now, because of the high corrosion resistance and environment friendly process, it is very much popular now. Acid zinc nickel significantly higher corrosion resistance versus standard zinc. We can get higher corrosion resistance even in cadmium, but cadmium is not a environment friendly process. So we have to use acid zinc nickel process. What is acid zinc nickel? Basically, as you can understand from the name zinc nickel, it is a alloy of zinc and nickel metal, in which zinc and alloy is about zinc is about 85 to 90% and nickel is about 10 to 15%, which gives a sacrificial layer for the component to get higher corrosion resistance. And it is a alternative of cadmium plating. We can avoid cadmium plating, so we use acid zinc nickel. Here you can see market applications and segments where it is being used. Automotive sectors, fasteners, brake parts, fuel system components, clamps, brackets. In electronics, it is being used in connectors, housings, hardware, aerospace and defense, structural fasteners, brackets, hardware, and in construction industry, bolts, nuts, screws, structural fittings. But basically, it is used more popular in automotive part, in brake caliper and hardened fasteners. Here you can see some advantages and features of acid zinc nickel. Acid zinc nickel, we can get two types of finishes, matte as well as bright finish. And it is possible in barrel plating as well as in rack plating. Compared to alkaline zinc nickel, the finish of acid zinc nickel is more bright. You can get brighter, and even you can get more matte finish if you compare with alkaline zinc nickel plating. And due to its high efficiency, it can be used for higher productivity. Here is the bath composition. Bath composition, basically it is containing zinc, nickel and additional chloride ion for the conductivity. And this process is available in boric as well as boric free process. And of course, there are some organic additives that are very important to keep the bath stable and get the appropriate percentage of the alloy, where the organic complexing agents, carriers, LCD extenders and buffers are required, and also brightener and levelers are required. Complexing agent plays a very important role in this to keep the metal ratio and deposition uniform. Operating parameters are, as I informed, that it was not very popular because we faces many challenges during earlier time. So a lot of studies happens to make it more stable. And we found that for acid zinc nickel, if we compare with other platings, acid zinc nickel is more, critical. For operating parameters, it is very sensitive. So we have to keep a particular parameter in range. Like you see, pH, temperature, current density, agitation, anode type, filtration. We will discuss in detail in further slides, but these are the range what we need to keep. And why it is very important, we will discuss in further slides. See here, critical operating and control guidelines. Acid zinc nickel is totally different with other plating. Like other plating, it is required only one anode. But in acid zinc nickel, it is mandatory to use dual anode, two types of anode in a single bath. One is zinc and another one is nickel, where the ratio of anode should be 4:1, 4 part zinc anode and 1 part nickel anode. To keep the dissolved metal in ratio, that is why we need two types of anodes for consistent plating. Being a acidic bath, filtration is also very important, and it has a nature of crystallization at lower temperature. So filtration is very important, and the filter size should be between 5 to 10 micron, and this frequency should be about 4 to 5 times of the bath capacity. As I discussed that, and there are two types of anodes required for one bath. So two rectifiers also very important to connect with each anode separately. But you see, if you are having only one bath, then you need to have two types of anode and two rectifiers in single bath. But if you have 5 baths in transporter type line, out of 5 baths or 4 baths, one bath you can keep nickel anode, another 3 or 4 baths you can keep zinc anode to maintain the required metal in the bath. See, why we use acid zinc nickel to get a higher corrosion resistance. To get higher corrosion resistance, nickel percentage is very important. And to keep that XRF machine is very important. Every plater or service provider, he should have to have XRF machine to make the productivity and consistent production to get better corrosion resistance. Here you can see with the graph, lower the nickel percentage, lower the corrosion resistance, higher nickel percentage higher, but at a particular level, even if you go more higher than 16%, then again corrosion resistance start dropping. See, temperature sensitivity, this acid zinc nickel is very sensitive to temperature control. As per our practical experience, if we compare with other baths, suppose nickel plating, zinc plating, or alkaline zinc plating, if temperature goes beyond the range, not much problem happens. Basically, consumption of brighteners or little bit finish will damage. But in this process, if you are not controlling the temperature in the particular range, then it will cause total failure, total finish problem, like high current density to low current density, finish will be different. So that is why thermostat also very important to make the consistent production and good and get the consistent result. Nickel content also plays a very important role in the corrosion resistance as well as in the finish. You can see with the graph, with the help of graph, nickel percentage, how it increases with the increase of temperature. Lower the temperature, lower nickel percentage in the deposit. Here we are discussing the nickel percentage in the deposit, not in the plating bath. If you increase the temperature, nickel percentage will increase accordingly. And with the decrease of the temperature, nickel percentage will decrease accordingly. Agitation, being a acidic bath, agitation is also very important for proper anode dissolution and proper nickel deposition in the layer. Salt crystallization, as I discussed earlier, this bath has a tendency of salt formation at lower temperature. So it is always recommended, Artec always recommend to keep the bath above the 20 degrees centigrade, even it is not operating condition. We are keeping it, we are holding it, but we should keep the temperature maintained at more than 20 degrees centigrade. So now we are moving to most important things, pre-treatment. Pre-treatment control, and pre-treatment is very critical and very important in this process. Okay. First, we will show you some, typical process sequence. This is a general process sequence for the acid zinc nickel, but we recommend some additional for the as per demand of the component. This is a general one like soak cleaning, anodic cleaning, ultrasonic, water rinse, acid pickling, water rinse, anodic cleaning 2, water rinse, and activation, water rinse, acid zinc nickel plating, and water rinse, activation, passivation, and also top coat. Here you can see the actual photograph from the plant, and I'm happy to share that Artec is the company, one of the biggest company as per my knowledge, from India, who is supplying the large amount of electroplating additives to China market. So this is the plant from the China. Yeah, pre-treatment for cast iron and hardened steel. Pre-treatment is not important for acid zinc nickel, but here it becomes important because we are selecting the component which are difficult for plating, like hardened steel and cast iron. These two kinds of component, it is always very difficult to plate in alkaline zinc or other alkaline zinc nickel. So pre-treatment is very important. For cast iron and hardened steel, pre-treatment quality determines coating performance more than bath chemistry. Cast iron and hardened steel surface contains graphite oxides, heat treat scales, and embedded contaminants that strongly interface the coating adhesion. You see, basically what happens that hardened steel during hardening and heat treatment process, graphite and carbon will form in the metallurgy and in the surface of the component that restrict the coating, that reduces the efficiency of the coating, and also that has the tendency to get the hydrogen ions penetrate in the surface. So we recommend special pre-treatment for acid zinc nickel plating. Proper pretreatment ensures uniform zinc nickel alloy formation and stable nickel incorporation across the surface. Conventional zinc treatment cycle are not sufficient for acid zinc nickel plating on these substrates. As I mentioned, it is not because of the acid zinc nickel plating, it is because of the component selection. And you can see here it is mentioned. Effective pretreatment significantly improves corrosion resistance, adhesion, and coating durability, mandatory for meeting automotive fastener and safety critical components specifications. These are troubleshooting, some, troubleshooting we face during the plating, and their causes and their solution is written here, what action we should take. In this slide, we will compare acid zinc nickel and alkaline zinc nickel. The main difference is efficiency. Acid zinc nickel bath is more than 95% current efficiency, while that alkaline zinc nickel is 65% only. Because of the efficiency, it has faster plating speed, so get better productivity, higher productivity. And acid zinc nickel is suitable for cast iron and hardened steel, while this one alkaline zinc nickel is not suitable. Basically, what happened in plating, for hardened steel and for cast iron, alkaline zinc nickel is containing a high amount of caustic and it is highly alkaline. Because of the carbon and graphite inbuilt in the component of hardened steel and cast iron, it reduces the deposition rate. So in alkaline zinc nickel, it is always consider deposition rate as well as dissolution rate. When plating speed is very slow, at the same time, in the recess area and low current density, where current efficiency is very low, it gets dissolving in the alkaline zinc process. That is why cast iron and hardened steel is not recommended for alkaline zinc nickel plating, and it is not easy for alkaline zinc nickel plating. So we use acid zinc nickel for these kinds of components. In this one, acid zinc nickel, it contains higher metal in the bath, while this alkaline zinc nickel lower metal. Higher metal, it means it is about 20 to 30 gram of nickel we maintain in the acid zinc nickel bath, while in alkaline zinc nickel, it is about 6 to 12, basically. Acid zinc nickel always has lower hydrogen embrittlement risk. Alkaline zinc, higher hydrogen embrittlement risk. We will discuss about this one, hydrogen embrittlement, in further slides. Acid zinc nickel, as I informed, you can get both finish, matte and very bright, while in alkaline zinc, it is semi-bright to bright. Here you can see the comparison of hydrogen embrittlement between alkaline zinc nickel and acid zinc nickel. Acid zinc nickel has lower tendency of hydrogen embrittlement problem. Acid zinc nickel process can be optimized to minimize hydrogen absorption into high strength steel. Proper pre-cleaning and baking treatments further reduce risk. It is designed for critical fastener and high strength components. So as we discussed, acid zinc nickel, it is a replacement and alternative of cadmium plating, and it is more environment friendly and easy for water treatment. This is the summary. Acid zinc nickel delivers high performance, corrosion resistance zinc nickel coating, ideal for automotive engineering and high demand application, combines brightness, uniformity and robust bath performance. So thank you all. If you have any question, you can ask or can come to our booth. Thank you.
Excellent presentation, Mr. Ranjit. This is an emerging technology, but Boeing also looking at this. around 85% zinc and 15% nickel. Okay, good presentation. Nice. Our next presentation, I'll call upon Mr. Madhav Singh, the Managing Trustee and past President, MFI, Head Marketing Committee, IFS 2026. Madhav Singh is the Managing Trustee and past President of MFI. He has done his master degree in science in Bombay University, and then he worked in Grorenville. In the year 1960, he started his own business as an exclusive distributor for Autotech India. In the year 2001, he was elected as a governing council member in MFA. Within 2 years, he rose to become an honorary secretary for the period of 2003 to 2006. His vision to make MFA to global level with the support of his senior colleagues. He got elected in the year 2018 as Secretary General Instruments, Union of Surface. He got re-elected as Secretary General in IUSU SF Surface for the year 2022-26. He is a member of Rio College Alumni Association and connected with various other social organizations. Over to Mr. Madhav Singh.
Thank you for my introduction, gentlemen. Very good morning to you all. But I see that people were busy for attending the technical session. When the marketing session came, most of them have disappeared. I think they don't like the marketing. Anyway, I respectfully acknowledge uh, the gentlemen present on the dais and the August gathering, which is in the auditorium. It is always pleasure to talk to you, but I enjoy talking when I have the large gathering. Anyway, friends, the presentation that I'm giving you is the global perspective of the surface finishing industry that we are in. We know the technical, you have been hearing the nickel, chrome, tin, blah, blah. So this is purely the global perspective of the surface finishing to know what is the trend of this industry worldwide, where are we, what is going to the future, and what has been the global shift in the surface finishing industry worldwide. That is my presentation. Yeah, surface finishing industry, global perspective. If you see the total global marketing snapshots, total market size is around 14.96 billion USD. Roughly in terms of the rupees, it is 1,25,000 crores. There is a market potential this industry has worldwide. The forecast is in the year 2032, this industry is going to grow roughly 6%, and it will reach 23.64 billion USD. And in terms of the rupees, 2,14,000 crores, that is going to be the size of the industry worldwide by 2032. But I feel that my own analysis is this. This is the conservative figure. The way the economy is growing, I think this will touch nearly 7% growth from 2024 to 2032. Yeah, some of you may be aware, some of the overseas the attendees are here. Friends, as you may be knowing, who have been watching the global market, there has been a dynamic or global definite shift from the west to east. The market has shifted 65% to the east, the Asia, South Pacific, and now Asia, South Pacific, they enjoy the 65% market share. Excellent opportunity for India and other Asian countries. And in terms of the growth rate, you see, North America is likely to have 3 to 4% growth rate. Europe 2.3%, 2 to 3%. Either Asia, which is dominating the market, the growth rate is going to be 7 to 9% for future. And is a golden opportunity for the European and the Western countries to, as far as possible, shift to Asia. Middle East 2 to 3%, and South America is 2 to 3%. This is the growth expected of this industry in future. If you see this orange, this is Asia Pacific. The growth is here. The orange. In terms of the Asia Pacific, the business, when I say that it is 65% of the global market size, it is going to be $10.3 billion. And China has the highest market share, 2.5 billion USD. That is roughly 22,500 crore. That is the business in China. Asia is topping, and China is topping, followed by the India. India, we are number 2 in Asia in terms of the business of surface finishing, which is $1.3 billion. 11,700 crore is the market size of chemical industry in India. Here, now in surface finishing, which are the segments that likely dominate? The blue electroplating, this is the segment electroplating is going to dominate in future. Rest, others are more or less going to be marginal growth. And the electroplating is the industry that is, the plating industry that we are in is going to dominate the market in future. This is very interesting for the businessman or any industry. It's quite interesting. Trends and disruption influencing your customer means how, suppose today is your market share is, your revenue is 20% mix, is a revenue mix is 20%. How it is likely to go to 80%? How will you take it? These are some of the tips the market researchers they have analyzed. This can be achieved by new use of new technologies, new ecosystems, new products, offering the new clients and the partners. These are the areas where you can help your business to grow to the future higher revenue mix. Now, let us take example one by one. Let us take the automobile sector, Toyota. Toyota, the automobile sector, Toyota, I am taking one of the example. The uh, the the lightweight material, metallic, the lightweight material, and the specialized coatings, the good corrosion resistance products, and the chromium free technology, and low VOC, volatile organic content. Low VOC content products, they are going to help this industry and grow, increase your market share in this. Similarly, there are the aviation industry, Boeing. Smart coatings are going to contribute to your business, and the high performance anti corrosion. This coating is going to help the grow your market share in the aviation sectors. So these are some of the examples. You need to study this uh, in detail. Which friends, this is very interesting. Let's have a look at. This is the buying behavior, the purchase criteria of different countries, which some of you might have experienced in your uh, professional life. What are the criteria every country uses to decide the buying of the chemical processes? Brazil, they believe in the regulatory compliance as a main criteria to buy any product. Canada, innovation. Canada believes more in new technology, new processes, and the innovative products. China, reliability. France, their focus emphasis is on the service. Germany, quality, And the sad part of this is India, we believe only the price. Price is our main criteria to buy the new products, new technology. So there is a sorry state for, I'm sorry to say, we Indians, this is what it is. Now, what are the various market dynamics for this industry to grow? The various market dynamics are the drivers, the drivers which drive your business, opportunities, the opportunity available, challenges, and the distance. These are the four the criteria on which business is grown. Market dynamics. What are the factors in market dynamics? Let us see that. Robust demand from automotive and EV sectors, which I am going to detail, slightly elaborate in subsequent slides. Semiconductor growth creating a demand. Worldwide, we all know, we read every day in the newspaper about the semiconductor industry and what is the focus, what is the progress. Emerging opportunity in the aerospace and the key growth drivers accelerating the PCB sector. These are the four key factors for particularly but more relevant to Indian market, Indian business. And these are the four factors which are drive the business and growth of surface finishing chemical in India. Of course, abroad also, but since abroad the manufacturing units are moving to Asia and India, so obviously this is more relevant to we Indians, our Indian market. Various opportunities, technological advancement in smart treatments. This is an opportunity for your growth of your business. Adoption of the nanotechnology. Some of you may be aware nanotechnology is it provides a very hard coatings, surface coatings, and that is going to call the shots in future nanotechnologies. Composition emerging as the second fast. Composites. This is another base material, lighter and good strength, mechanical strength, and some flexibility. So composites are going to be the base material for future, for the growth, and particularly in the automobile, aerospace, wind energy, and electronics. These are the industries which are going to use the composites. So we chemical manufacturers should be ready for the technology and the for composite base material. Growing adoption of lightweight aluminum alloys. Friends, as you may be knowing that because of the certain advantage of the aluminum as a base, some industries, particularly automobile industry, have started going for the anodizing processes. There's a shift from the steel to the aluminum wherever possible in the lighter weight and the same strength. Green technology. Green technology is another opportunity, but so far the price is the technology is little the prohibitive. So normally the industry are the reluctant to move to the green technology. They have some resistance. But in future, is a green technology that is going to take your business the long way. You can't cut short on the business in future. Market dynamics challenges. Challenges are the high cost of the technical hurdles adopting surface treatment chemicals, elevated production cost of the green technology. That's why I mentioned just now. The green technology is going to cost more, but it is going to be the future. If you don't adopt this, we will have the problem. What that problem is, I am going to discuss in the NDC column, nationally determined contribution, that every country has to have signed, and they are going to be reviewed by 2030. We fail, business fails, the country fails. These are strong words, but there's a fact. Use of low VOC, volatile organic component, low volatile organic component, and water-based coatings. Is a water-based, it is high time we go for the water-based coatings. I think we R&Ds worldwide should start working on this. Yeah, restraints, various restraints are there. That's why handcuff is shown here. Stringent compliance standard pose a barrier surface meeting our NDC level. This is what I was talking about, which I will elaborate in future. So nationally determined contribution, what it is, how it is going to restrain our business in future. Yes, friends, now I will touch upon for the Indian market, what is good for Indian market, how Indian market is expected to grow, and how bright the future is for Indian market. I am sure that the 7% growth of our economy in the surface finishing will catch up and will overtake another 7 to 10 years, overtake China. The growth rate that the GDP growth rate we are seeing, it is reached to 8.2% as against the 4.5% of China. I think the days are not far, could be 7 years or so. We are going to overtake the surface finishing business of China. Not strong words, but somewhat realistic. Friends, in India, I think some of my overseas friends must be knowing, India has produced 25 million cars in 2025 is a great achievement. And we are talking about the further growth of 52% in the next 5 to 7 years to come. The last slide, Maruti, Suzuki, Skoda, Volkswagen, and Hyundai together they have targeted 52% growth of automobile in the years to come. They have not mentioned the year, but I presume that it should be around 6 to 7 years. So that's the kind of growth we are seeing in India. Toyota to invest $11 billion next 3 to 5 years alone in South India somewhere. They are not mention the location. VinFast, European conglomerate, I would say, compared to size of the Vietnam market. VinFast is establishing the first EV manufacturing plant in Thoothukudi, Tamil Nadu. And overall existing manufacturing there I mentioned. Friends, it is the most of the automobile sector, the growth is going to be in South. So people from South should be very happy and proud. And the part of West, that is Gujarat. So that's the areas, South, Andhra, Tamil Nadu, and Telangana is the areas where the automobile sector is likely to grow, or the new plant are going to be established there, and the part of the Gujarat. So this is the very good opportunity for automobile sector in India. Now aerospace, Airbus Industries to invest $1 billion in Gujarat. This is another booming sector for India. Safran, a French aerospace firm, to provide full technology transfer to worth $7 billion to India. Full aircraft will be manufactured in India. That's why Mr. Macron is here in India. You might have seen yesterday, read in the civil, he was jogging, early morning jogging without the security in Bombay. Rolls-Royce and Bharat Forge, they are partnering for the manufacture of the advanced jet engine fan blades. HL, Dassault and Tata Advanced Systems to set up Rafale fuselage, the main body production facility in Hyderabad. These are some of the few important new projects that are coming up for India. Good opportunity for the Indian surface finishing industry. Semiconductor. Everybody is talking about semiconductor now. Der aaye, durust aaye. This should have started around 15 years back. But yes, thanks to the new government, this is the segment which is really going to grow. Alliance Group of Taiwan to invest 1,000 crore in India-Taiwan Industrial Park in Karnataka. Intel and Tata Electronics to make semiconductors and hardware locally. SCL Foxconn joint venture semiconductor in Jewar, UP. Tata Electronics partnership with Japan Rome to establish the chip testing and assembly facility in India. The Indian government is investing 76, this is very important. Indian government invests 76,000 crores under the Semicon India project to establish domestic semiconductor ecosystems. PCB, 45% growth they are expecting by the year 2029, 45% growth. This is the nationally determined contribution I was talking about. Friends, every country has signed the with the World Bank and the various international UN forums, not to allow the temperature to rise more than 1.5 degrees centigrade, any country. That is called Paris Agreement. If you fail to meet that, meet that, then perhaps the loan from the World Bank, ADB, and this may not be sanctioned. So it is important wherein we develop the technology, but go for green technology, because that is the only way to control the environment temperature and control the greenhouse gases which are important for us. Just to give you, these are the Paris Agreement and various bindings of each country. This, and let us not take it lightly. This is going to be serious. In 2030, there is going to review. If any country fails, perhaps they will not get the loan from the World Bank. Three examples, just three examples we will actually give you, share with you. China shut down to meet this NDC level. China shut down two large chrome plating plants. That's why a few years back there was a heavy shortage of chrome worldwide. This is one of the reasons. And you know that the methane is one of the gas that disturbs the greenhouse gases, the layer of gas that controls the body, the surface temperature of the earth. In New Zealand is basically the dairy producers. When the when the cows or buffaloes they burp, they generate the methane gas, and that disturbs the environment. And to save the meet the NDC level, they are going to charge the taxes on these the owners of this cows and buffaloes, so that they control the burping. How they burp, I do not know what rate they are. What rate they are going to, New Zealand going to charge the cattle's, I don't know, but they are working on the system. That shows the seriousness of this. Last, my dear, several Asian countries. Very example, last November, I was in Hong Kong in the IUSF International Union of Surface Finishing Conference. Because Nicolas Chang, the chairman of the ISF, he told me, we are shifting the many industries, polluting industries from China, from South Korea to Vietnam and Cambodia, because we don't want to disturb our NDC level. So that is the trend. There is a seriousness which I want to, as a technical people, as a beneficiary or the user, to impress upon that this is a serious matter. While we grow, there is industrial growth. While we grow, but this aspect has also to be looked into by we all. Otherwise, same thing is going to happen. What happened to Europe? Same happens in India. Then we move to South Asia. We move to Cambodia and the Vietnam. So let us not happen that. We be serious. Thank you very much. Thank you.
Thank you for the excellent presentation, sir. You have given a full view up to 2030.
Friends, we will take small break, 10 minutes tea break. आओ फटाफट लाओ
and Mr. Santosh Rane. Dr. Minu is a chief scientist at the Surface Engineering Division of CSIR National Aerospace Laboratory, Bengaluru. She has over 20 years of experience in research and development in area of electrode deposition coatings for wear resistance applications, thermal spray coatings for high temperature applications, and eco-friendly coatings and corrosion resistance applications. She has developed technologies like nickel cobalt electroforms as erosion protection strips for the rotor blades of ALH helicopters. Dr. Menu is a recipient of prestigious NM Sampat Awards from the Electrochemical Society of India. Please welcome Dr. Minu. And Mr. Other person, Mr. Santosh P. Rane. He is a BSc honoris degree from Mumbai University, diploma in business management from Mumbai University, technical sales executive at Grover Well from 1974 to 1978, founder of Rane Rao Reshamia Labs in Mumbai 1978. Please welcome Dr. Santosh Rane.
So, welcome everyone to this session after the tea break. We'll have the first talk on electrolysis plating poised for significant growth driven by innovation and expanding application by Dr. Haritosh Mishra from Grower and Vale. So it's my pleasure to introduce Dr. Haritosh. Dr. Haritosh has been working as an associate vice president R&D in Grover and Vale, India, Mumbai since 2017. He started his career in the field of electroplating in 2010 as a senior scientist in Enthone. He has worked on various diversification projects, electroplating zinc and zinc alloy, electroless nickel, EN composites, polyalloy plating, etc. He has completed his PhD from IIT Kanpur in 2008. He has worked as postdoc in Versailles University, France on photo thermoswitchable materials. He has published more than 20 scientific papers in reputed peer international journals. And he is also a recipient of a gold medal during his master's. May I now invite Dr. Haritosh Mishra to deliver his talk.
Thank you, madam, for your kind introduction. Namaskara, good morning. Welcome, everyone. So, I am going to talk, not a study slide. So, I am going to talk about the electroless nickel plating, bias for significant growth driven by innovation and expanding applications. So, I have divided my talk into the introduction, improvement, re-innovation of product, application in emerging technologies, latest development. I'll talk a little bit about the poly alloy electroless nickel system and EN composite coating, and then finally conclusion. So actually this electroless nickel is considered or not considered, it is an accidental discovery, because during the World War II, two gentlemen were trying to do the gun barrel plating with the nickel, and there were a lot of oxidation at the anode. So to prevent the anode, they have added reducing agent like hypophosphite. That hypophosphite resulted into the exceeding the Faraday's law, means the current and charge mass equivalent that is exceeded more than 100%. So there is something which is doing the oxidation work other than the current, and that is the hypophosphite. And even when the current was cut, the plating continued. That is proving that the electroless plating, means without current, plating of the nickel is taking place. So this accidental movement is considered as the eureka moment, because we have discovered something new. Before that, the plating is only the electroplating system. So this electroless plating is autocatalytic process. Autocatalytic is why? Because the surface which is being plated, that catalyze the further plating on the surface. That's why you cannot plate all the metals by through the electroless nickel process. The main important feature of this electroless plating is this is mostly very uniform coating, and this always form in the form of alloy. When you are using sodium hypophosphite, this is nickel phosphorus alloy, and when you use the boron containing reducing agent like sodium borohydride or dimethylaminoboron, then it is nickel boron alloy system, and both of them is having very special characteristic properties, and that's why it has wide application. So that is the wild initial when during the Second World War this electroless was discovered. That time there is very little knowledge about the procedure of the electroless plating system, and the bath was very unstable, and the coating was also very rough. You need a lot of post plating treatment to get the smooth plating, and then the quality of the plating, quality control was not there because the chemistry was not understood properly. The platers were mostly uneducated people, so they cannot maintain the bath. Characterization instruments were not so developed. So that is considered the wild initial days of the electroless plating. Then the people, the supplier and the platers work very hard to understand how to improve the existing electroless plating system. And then they developed some complexers. They understood the role of the complexer. Complexer can control the plating. Complexer can control the grain size of that. That is understood, and different kind of complexer is being used that time to produce better electroless nickel solution were clean. Development of the many means QA quality assurance equipment that can quantify the properties of the plating or the bath solution that discovered. Then come to the discovery of the ROHS compliance stabilizer. That is also very important. Path breaking move into that. So all these things lead to us today in present state of the electroless leak. So before going into details, I would like to just explain this electroless nickel plating mechanism little bit. Why you are talking mostly about the electroless nickel? Why not electroless zinc? Why not electroless chromium? Because there is a restriction. This mechanism, if you understand, then you can understand why we cannot plate all the metals by electroless method. Because this hydrogen generated through the reducing agent attached at the surface, activated surface, that is mostly MS or activated other surfaces like palladium containing activated surface, that absorb, and that is the reduction of the nickel to present into the metal or any other metals present in the solution. And that the layer form, that is nickel phosphorus layer, that is further autocatalyzing the process, and then the process continue and you can build a thickness. In other metal, when you make a, like example, for example, copper, if you do the plating, after a single layer, plating stops because copper is unable to catalyze the process. And similarly, other metals. So today's electroless nickel, we have electroless nickel developed up to certain extent, like we have co-deposition, where we can redefine the characteristic or property of the electroless nickel by introducing some kind of nano or micro particle. Like suppose we want to do the reduce the friction, we can introduce Teflon, we can introduce boron nitride particles of certain size and shape, so that we can manipulate the frictional property of the coating. Similarly, we can further modify the property of the electroless nickel by introducing third elements, mostly the metals, into the nickel phosphorus alloy, and that will form the alloy. That is not like a mixture, that is a alloy, means the third element also lose their identity and form an alloy. Then emerging technology like hydrogen fuel, 3D printing, POP, there you cannot have any other option than the electroless nickel. You need electroless nickel to make the surface conducting. And some objects which is very complicated shape and size, that there you need electroless nickel, because electroless nickel is driven by the solution phenomena. It is not by the current. So there is no accumulation of current anywhere. So by using this electroless nickel, you can get the uniform coating with uniform property. So what we have achieved till date, we have the high force electroless nickel which can pass 2000 hour NSST. Where I am talking about the bare electroless nickel, nickel phosphorus alloy can pass 2000 hour NSST. We have other coating where you can have top coat and then that can pass more than that. We have the electroless nickel low phos which can have as plated hardness more than 800 HV, which is very close to the hard pro. We can have lower or higher frictional depending on the particle. Like if you put PTFE, you can have the lower frictional coefficient, and if you put some cubical boron nitride, you can increase the frictional coefficient. It is suitable for the complex geometry component. Aesthetic means you have a wide range of appearance from matte, gray, mirror bright finish. And that's why it is in well positioned to replace the hazardous hard chrome also or cadmium. So by stating that, I am saying this, I am very optimistic about the future of ENP technology. Why? This is mostly the electroless nickel. We know that we are in the 4th or 5th generation electroless nickel, and where we have already talked about the composite coating, poly alloy system. So what is the next generation system? Where we are going? So now the age is, we are looking for the intelligent surface, where the surface can talk, surface can respond to the change in the environment. So how we are going into that 6th generation where we have poly-alloy ENP system. There you can introduce third element. You cannot plate some elements because I have already said the limitation of the electroless nickel, but along with the nickel or some other elements, you can do the plating of the third element also, because the catalysis process is completed by the nickel, phosphorus, and the other element will get code deposited. We are looking for the endless bath life, because there is the limitation, because nowadays the waste treatment is very big matter for any platers. So we are looking for endless bath life, like the electroplating. If we can generate some system where you can use the bath for longer time, new kind of EN composite coating. We are talking about the save the power. So we are looking for the low temperature process. We are looking for high plating speed, because that is also limitation of the electroless nickel, that the plating speed cannot be more than 20-25 micron per hour. So we're talking about some of the ternary alloy recently developed, and that has unique property. I'll talk little bit more about that at the end of the class. Like in nickel copper, if you introduce copper, copper is having antimicrobial properties. So you can have some utensil, something which where you can plate with the nickel copper and you have antimicrobial property. Nickel tin phosphorus, I was talking about the 2000 hour. If you introduce 10% tin in electroless nickel, you can have NSST more than 2000 hours. Similarly, nickel molybdenum plating, that is known, reported in the literature, it is catalyzing the electrolyze of the water, which is we are talking about the hydrogen fuel system. Nickel phosphorus boron, I just stated that now the as plated hardness of the electroless nickel can be more than 800 HV. This is the alloy system, nickel phosphorus 1 to 3% and boron less than 1%. You can achieve 800 plus HV hardness. Then we have a lot of nano and micro particles which can modify the electroless nickel property just by introducing 1 to 4%. Maximum you can introduce 4%. If you try to include more, then the peel-up will result into that. So like inbuilt lubricity, if you are going in a space, there is a wide change in the temperature, there any lubricant cannot work. So there you need the surface itself should be lubricant, and this kind of coating helps in maintaining the lubricity at different variant temperature by just introducing say hexagonal boron nitride, Teflon particle, or graphene or graphite, this kind of material, if you introduce 1 to 2%, that will be having very good lubricity. Shielding of EMI, electromagnetic DSN or radio impression frequency, that those things are also very important nowadays. And this is electroless nickel that can shield the electronics from these radiations. Then we can have for any memory chips, you need a certain magnetic property, that is ferromagnetic property. Here you can fine tune the property of the electroless nickel by introducing some kind of particle which is in ferromagnetic or some element which can have ferromagnetic coupling with the nickel. And then there is a age of hybrid plating. What is hybrid plating? When we talk about the hybrid plating, we are talking about the two different layers. We can have electroless two different, like you can use high phosphorus electroless nickel, and then you on top you can use the low phos or the recently what I said nickel phosphorus boron. You have very good corrosion resistance, and at the top you have very hard coating of the low phosphorus. So you are getting the both corrosion protection and wear resistance coating. Like electroless nickel silver on aluminum that is being used. Electroless nickel, zinc nickel in aerospace being used nowadays. Duplex, just I told about the electroless nickel in two. ENIG is very common semiconductors, and in the PCB they are being used that electroless nickel immersion gold, electroless nickel, electroless palladium on top of immersion gold, electroless copper and electroless nickel. I think two micron electroless copper and maybe one or less than 1 micron of electroless nickel is considered to be very good shielding effect. Connectors like high phosphorus electroless nickel, zinc nickel, black passivation, that is also being used in the aerospace technology. Like many things are there. Then what is the other point I am saying that we are optimistic about that? The emergence of hydrogen fuel car. So I'll talk more about this in the other. Then 3D printing. You know, the very complex, very precise structure you can get by the 3D printing. But that is mostly on the polymers, and you need some metallic surface on that, then you need sometimes of some kind of plating on that, and that is possible through the electroless nickel plating only. Recently we have also done the plating on the ceramics, that is also coming very quick, very fast into the field, because the ceramics you can make it conducting, and then you can have lot of different property, and ceramics has unique property, you know that is. So coming to the EV, some people are talking about the EV, and our government has also given some timeline to conversion of the 50% vehicle into the electrical vehicle. So there are many components which can be effectively plated with the electroless nickel. Like these kind of a structure, if you think of plating, the first it will come into the mind because of the geometry. Electroless nickel is the only suitable process to do the plating. Now, there is people are using liquid coolant for the cooling effect, because recently we have seen that there is a lot of fire and all these things because the heat dissipation is not taking place properly. In that case, you are using liquid inside, very tubular structure inside that, and the plating of the inside, it is only possible through the electroless nickel. So electroless nickel is going to be used hugely in EV. And there is connectors and other elements like plating on aluminum itself. You start with the only electroless nickel. Without electroless nickel, you cannot proceed. So in EV also we have huge demand of electroless nickel into the future. Like these kind of, if you see the inlet outlet, there you put the liquids, coolant liquids. Some of the coolant liquid used today are corrosive in nature also. So you cannot use bare tube structure to pass through. Then it will start corroding and one day it will start leaking. So in that case, if you do some plating inside, that is also possible through the electrolysis nickel. This structure I have already said about that. Then coming to the hydrogen fuel. Nowadays, people are talking about the hydrogen fuel. Maybe next 5 year or 10 year, or maybe in our life, we can see that you are having a car where you put water and start and go, because the whole system is here and that may be fitted into the car in place of engine and all these things. So why I am excited about as an electrolysis nickel scientist? Because here we have anode. I have already said that the sum of the LOI system is considered catalyzing the electrolysis of water. And there are a lot of academic interest in there also. Recently, I was in one of the conference. People were talking about how to generate the hydrogen gas. If we use the electricity, an equivalent amount of hydrogen, if we can generate also, that is also not going to save our planet. We have to do some chemical changes. Like in nature, you know that nature, in leaf, this carbon dioxide, water is being used and you produce the carbohydrates. That is the fuel for us or animals. Similarly, we can have some kind of catalysis effect where the chemical reaction is helping to generate the hydrogen. Like we started with the electrolysis nickel, where this electrolysis nickel accidentally discovered when the efficiency of the plating is more than 100%. If we can do something like that, that is possible only when our electrode, where this redox phenomena of the oxidation of water is taking place to generate the hydrogen gas, can catalyze the process. In biological system, we have that kind of system which is oxidizing the water and generating hydrogen. And from there only you are getting carbohydrates. So there you have very good scope of electrolysis nickel polyalloy. I'll be coming to that polyalloy at the end. Then hydrogen, you know, the lightest element. So that will generate the maximum pressure if you store it. So their storage tank can only be plated inside and outside through the electrolysis nickel plating. So there also I can see a lot of scope of electrolysis nickel plating. So what we offer as a global. So I'll be talking some of the recent product we have, like polyalloy. I talk about that. That is going to change the what we are plating today. Maybe in future we'll be having different kind of electrolysis nickel. Like we have nickel cobalt LOI system in 3 different variants. 21% means almost 20%, 50% or 80% cobalt you can introduce. And that is having different degree of ferromagnetic property that can be used in the semiconductor industry or memory chips. Similarly, we have nickel tungsten. There we can have control of the tungsten content into the LOI system. Then we have nickel tin phosphorus LOI system. There also you can have some control by the complexity agent of the content of the tin into the LOI system. Then nickel molybdenum LOI system. Each is having a specific property. If you want in details, I cannot go because of the restriction of the time. You can discuss me separately. So I'll just go through that. Then copper and nickel. If you have 20-25% copper, then it is having microbial, antimicrobial property that is reported into the literature. Then nickel boron, I have that. Then the quaternary alloy, that means 4 element you are introducing, and that is till now, it is reported in the literature, is giving the best efficiency of the hydrolysis of water. So similarly, we have composite coating, that is PTFE composite coating with nickel tin alloy, that is having more corrosion resistance property than the whatever we have right now. Similarly, we have nickel boron nitride, that is cubical and hexagonal. Both is having different property. If you introduce both, then you can impart the property of the both kind of particle into the same coating. That is also we have developed. Then we have very popular unit series of the electroless nickel, that is single component process in all variant. So with this, coming to the conclusion, the assessment that we are entering 6th generation of the electroless technology is supported by a shift from traditional protective coating to a highly functionalized intelligent coating. What I mean to say intelligent, if you get some cut, it auto heat. Can we do something? Can we introduce something into coating which can be triggered by the temperature change or pH change, and it migrate to the damaged area and can it heal? So with this, I am ending my talk, and I hope the future is very bright for them. Thank you very much.
Thank you, Dr. Haritosh, for giving us a very elaborate view on the electroless nickel coating and its recent use in EV as well as in hydrogen storage fuel tanks. Thank you. We have several questions for you. So we'll move on to the next presentation, which is on tin and silver plating on connectors and bus bars for signals and power delivery on the automotive, EV and data center applications by Mr. Rob Sketty and Mr. Andrea Weistin.
Okay. Hello. Yeah. Mr. Rob Shetty. Yes. Yeah. How do you spell Shetty? How do you pronounce it?
Shetty, just like
Shetty.
Indian Shetty, yeah.
Yeah, like Indian Shetty.
Yes.
So I will call you Shetty.
Yes.
Now you are with Technique.
Yes.
Thereafter, 40 years in the. This,
Right, and then he's that one.
okay, sorry.
US, that's mine.
Okay.
US.
Yeah. Yes. We will now ask Mr. Shetty. I will call him Shetty because it's a common name in India. So I will call you Shetty. He is VP of Technique USA, and last 25 years he was with Technique US, also in the industry for last 40 years. He has presented and published a lot of patents. And had many industrial presentations. You can start with.
Oh, okay. Test. Oh,
Yeah.
that's okay. Okay, thank you for joining our presentation today. We'll mostly be discussing tin and silver plating for connectors and bus bars, primarily for data center applications. And there's a brief introduction of the presentation. As you'll see, advanced electroplating technologies play a key role in manufacture of bus bars, which are critical for modern data centers. And primarily using tin and silver plating for the properties we're going to talk about. These really keep these the data centers running around the clock. So we're going to review some of the importance of electroplating technology in this growing field. So data centers is a big subject. It's in the news quite a bit. This shows the market projections for the next 10 years. So we can see in 2025, this is in the market size in US dollars. We're about 350 million US dollars, expected to grow to over 1.1 billion in the next 10 years. And what is the significance of that is the energy consumption. So International Energy Agency projects that the total electricity usage for all data centers worldwide will double in the next 5 years, reaching 945 terawatt hours. And this is mainly driven by these data center workloads. Each rack you see here can consume up to 500 kilowatts of electricity. And as for comparison, here's the electrical consumption of various countries. So Germany is about 500 terawatt hours per year. Japan is about 1,000. India is 1,700. The US is about 4,000. So the entire data center industry will consume about the same electricity consumption as the country of Japan, or about 1/4 of the US complete electricity consumption. So it's a tremendous amount of electrical power that's needs to be consumed and has to be transported from one place to another. And that's where electroplating comes in. The primary means of doing that is the electrical bus bar. So this shows the various types of bus bars that conduct current from one place to another. And here's just some basic definitions. Bus bar is a solid conductor, almost always copper or aluminum. Distributes large amounts of electrical current very efficiently. And cables are the other possible method, but compared to cables, bus bars could carry much higher current at a lower resistance and much better for mechanical strength and heat dissipation. And really, electrical bus bars are the backbone that make this AI data centers physically and economically possible. So now what does this mean in terms of the bus bar industry itself? So here's the estimated bus bar demand in millions of kilograms. Again, we can see it was about 80 million kilograms 2 years ago, projected to go over 200 million kilograms in the next 10 years. So tremendous growth for bus bars worldwide. And what does that mean for here in this country? In India, this shows the India bus bar systems market. Now it's a market value in millions of US dollars. It's projected to have about 21% compound annual growth rate over the next 10 years. So India is going to be a big market for these bus bars. How does electroplating enter this field? Primarily, two metals are used, as I mentioned, tin and silver. This chart shows the differences, but primarily tin is used where cost and corrosion resistance are critical. Silver is more of a premium finish, again, because of the precious metal content. It's going to be more costly. So for higher end applications. Other than silver and tin, the substrate materials vary generally between copper and aluminum. And the plating processes we can use are either electrolytic or immersion, electrolysis. There's also cyanide and non-cyanide chemistries. And then the types of equipment that can be used generally vary from manual rack plating to automated high-speed bar to bar. So we'll go into a little more detail on these in the next slides. So again, copper and aluminum are the two main materials. Copper is mainly used in data centers and AI infrastructure. Aluminum is mainly in building and power, facility power distribution and infrastructure. This shows the relative breakdown of copper and aluminum bus bars by volume. So we can see it's roughly split about 60% copper, 40% aluminum. And in India specifically, we can see a bit more aluminum is used than copper. Again, electroplating processes, they vary quite significantly between copper and aluminum, of course. Copper is a fully conductive metal. It can be directly electroplated. Pretty straightforward. Aluminum cannot be directly electroplated. As many of you know, it requires a special metallization process before electroplating. And zincate is the standard method used to metallize aluminum, but There's a unique method in bus bar plating where they apply immersion tin. I'll go into that in a little more detail. And for copper or conductive metals, we can just generally electroplate pure tin directly. That's what you. Okay. So again, tin plating is generally done from an acid electrolyte, pH less than 1. Typical plating thickness is 5 to 15 microns. Silver is the opposite. Generally, it's an alkaline solution, pH 11. Generally lower thickness, 2.5 to 5 microns. And the electrolytes for silver can be cyanide or non-cyanide. And the industry is generally starting to prefer non-cyanide electrolytes because of the toxicity of cyanide. Of course, it's one of the more dangerous chemicals for to be around for people. And a lot of countries are starting to restrict the use of cyanide. Another unique feature of silver is it must apply an anti-tarnish after plating. Again, the equipment can be used as either traditional rack plating, which has very low cost, but very low throughput, low productivity. It's subject to operator error. So we're seeing now a trend more towards specialized automated bar-to-bar plating equipment. They do offer higher throughput, fully automated processing, minimal error, but of course the cost is higher. Oh yeah, and the volume in the high-speed plating lines is much lower than in the rack line, which is advantageous. So here's some examples of a traditional manual rack bus bar plating line, pretty typical hoist line. The bars go from tank to tank. The show is an automated high-speed bar-to-bar plating line, generally plated horizontally on a conveyor system. And this shows, can you guys play the video? Can you play the video? Yeah, this is a high-speed bar-to-bar plating line that we've installed, operating at 30 meters per minute. So very high volume. These bars can be up 3 to 6 meters in length, going at 30 meters per minute. So very high-speed automated operation. And now I'll hand it over to my colleague to talk about more of the details of the electroplating chemistry.
Thank you, Rob. Does it work? Can you hear me? Okay. So concerning the process sequence that we have to put in place when plating the bus bars, if we're talking about copper bus bars, the process sequence is quite simple because we electroclean the parts, we silver plate, and then pass on the tarnish. That's for the silver. For the tin plate, electroclean, acid activation, and tin plate. On aluminum bus bar, there are some major differences if we do rack plating compared to a bar-to-bar plating, in a way that the process sequence is almost standard for the aluminum. So clean, etch, this matte, then immersion tin as described by Rob, bronze strike, and then tin plates. On the bar-to-bar, which works for both tin and silver, we can electroclean, etch, zincate, then we have a nickel strike, on top of which we can do tin or silver plating. We go down into details about tin. So here we have a hard cell panel, plated 2 amps, 3 minutes with a standard tin solution. Here we see how wide is the operating window for the bright tin. And down on the slide, we have the appearance of the bright tin bus bar. Actually, the market is demanding only, if not mainly, bright tin. A good thing about tin chemistries is basically that it's quite linear in the correlation among the between the plating rate, plating deposition rate, and the current density. Contact resistance. Here we see the graph of contact resistance of a tin plated busbar as it changed by increasing the normal force of the probe we used for the testing. We'll see later how it compared to the silver. So we keep in mind, let's say 10 for the first point over here, okay? 10, 6, 4, 2, then we go. So we can make a comparison later on with the silver. Tin is subjected to tin sludge formation, which are basically oxidation of tin bivalent to tin tetravalent, which generates sludge. There are available, we have available antioxidant additives, which are helpful to minimize this effect. As we talk a lot about green and eco products, also these antioxidant products are available in the eco version more than the traditional one. Let's shift to silver. Here we have a hard cell panel, same condition as tin. The appearance of a silver-plated busbar. Here we have the current density curve. I said, keep in mind this, the 10, 4, and it was 10, 6, 4. So we see that the curve is much lower, so the counter resistance of silver is much lower, and therefore the conductivity is better. Cyanide. I guess that okay. This image is quite self-explaining. Rob already mentioned about the toxicity of and how poisonous is the cyanide. If we think that we operate cyanide-based silver chemistry with about a total amount of 150 grams per liter cyanides, it means that 100-liter tanks has 15 kilograms of very little poison. So with just 100 liters. So the development of silane or cyanide-free silver is something key to meet the green demand, to minimize the risk for the operators and as well for the environment by running this kind of chemistry. So non-cyanide silver or silane silver, as we call, have been developed. This has a benefit. Silane silver has also a benefit in terms of process management. It is a drop-in replacement to cyanide-based chemistry, but the benefit is in cost reduction of wastewater treatment, or recovery of the silver on spent chemistries. That kind of, because you don't have to deal and to manage with toxic solutions, and you don't have to have a specific loop for the rinsing. So it is, I would say, in terms of process, is, I would say, user-friendly. Rob mentioned about the tarnishing of silver. So it is a natural reaction that basically occurred with hydrogen sulfide. And so it forms silver sulfide, which turn the silver surface black. If it was just about the appearance, we may probably deal with it. But if we look at the contact resistance curve, we see how much different it is for a silver plated bar as plated and after some time of storage. So we are losing the benefits of using silver for better conductivity if we do not apply any anti-tarnishing on top of it. So the post-treatment are key to preserve the functionality of the bus bars or the silver plating. There are two main families of anti-tarnishing: organothiols, which is good for surface corrosion, but it is not tolerant to high temperature exposure, and inorganic, which are good for high temperature exposure. Both, depending on the application, the optimal anti-tarnish has to be selected, but it is also possible to have the combination of the both. Both the organic and inorganic can perform better when applied electrolytically. Here we have a test done on 5 minutes plus 5 minutes, 5 minutes immersion time in 5% KS2 solution for a part protected with anti-tarnish and another one without anti-tarnish. You clearly see the difference and how beneficial is applying an anti-tarnish on top of a silver. So let's make some comparison among the cyanide-based silver versus the non-cyanide silver on copper bus bar, with and without post-treatment. As mentioned, the cyanide-based chemistry has a total amount more than 150 grams per liter cyanides. The siler silver, no cyanides, regular additives, I would say, almost operating the same pH range. So not much. Okay. In terms of testing the performances with or without post-treatment after aging. So we run the test using the steam aging test, which is 100% relative humidity at 100 C for 4 to 8 hours, which correspond 4 hours to 6 months natural aging and 8 hours to 12 months natural aging. We compare the S-plated 4 hours steam aging, 8 hours steam aging. These are the equipment used for the contact resistance test according to the ASTM norms, using the 300 grams load, which, if you remember earlier, that was given the lowest contact resistance in the graph. So we made a test in the worst condition. So here we have the data in milliohms for the contact resistance of bus bar with cyanide-based silver, Silas silver, and Silas silver plus antiton. Already here we see as plated that the cyanide-free perform better than the cyanide-based chemistry. And it keeps the same direction even after 4 hours, 8 hours steam aging. And here we see the major benefit of the anti-tarnish. Appearance, this is as plated. As we go to the next slides, you will see how it turned to be quite clear and evident how it is affecting the different performances of Silas base with or without anti-tarnish. It is against the cyanide-based chemistry. This is the 8 hours. So the previous one. This is the 4 hours. 8 hours. So, thumbs up. To conclude, contact resistance likely increase when aging. This is what's expected. Cyanide-based worse compared to the Silas-based silver. The appearance is of a cyanide-based silver is worse than cyanide-free silver after steam aging, 8-hour steam aging. So overall, Silas silver is performing better according to this testing compared to cyanide-based silver. And as I mentioned, it's a drop-in process which can be introduced without major modification of the existing equipment. This is just a resume of what already Rob mentioned at the beginning, how important it is. So thank you.
Come. Thank you, Mr. Andrews and Mr. Shetty. Excellent presentation of non-cyanide silver. Sorry. Yeah, excellent presentation about non-cyanide silver is the requirement over here in India.
So we'll move on to the next presentation, which is on role importance of anodizing and electrocoloring in today's fast evolving automotive, solar and architecture industrial demands by Mr. Hasmukh and Mr. Anil Chavan. Dedia. Let me introduce Mr. Hasmukh Dedia. He is first class chemistry graduate from Mumbai University with DMM from NMIMS University. His professional experience he started his career with Grover and Bale in 1988, and he was one of the very first employees of Arctech. Presently, he is working as a vice president, technical services with Arctech Surf and Chemicals Limited. His areas of interests include exploring the latest and upcoming technologies in the industrial coating. Over to you, Mr. Hasmukh.
Good afternoon. I know it's a very tough day for all of you. So I'll start a lecture basically in a different tone. Today, the opportunity given by MFI and ISF for this particular to speak about the newer technologies. When last 2 days, when I was just meeting the different clients, people, etc. Everybody was asking the main thing, Naya kya hai? What are the new things? And whenever the basically newer opportunities are spoken about, so in the group, we find 3 kind of subgroups. One, this new technology has come, like EV is there, AI technology. Basically, we are talking a lot. We are talking about the busbar and penetration of different, as my learned speakers have already spoken about. So there are 3 kind of subgroups I find. So I'll start my lecture on those nodes. And all the 3 kind of groups, there are some people, he said, yeah, penetration of the newer technology will come faster in India. The second group is always, somewhat saying, no, it will take time, EV, yes, penetration can come, but earlier the technology has to be supported by the charging station, it will take time. And the third group basically says, हमको क्या करना है, what we need to do, you tell us, sir, so that we can invest accordingly in the technology. So I can see the faces here, so you all are experienced people. So there are some areas where even all the first and second group, the third group basically is interested in knowing where are the actual and 100% growth area where they can find a minimum business loss. Am I right? Because we all are here, we come from the, all over India here, spending so much money to learn something, to hear something from this particular platform, to see where your business area is growing, and your growth area will be in next, coming time. You must be knowing before 10, 15, 20 years or 30 years, some 2 to 3 decades, we can see the especially architecture, your house windows and house doors. We can see lot of inside windows have been almost 100% replaced by now the aluminum windows. So architectural technology, etc., has taken over from this thing. And today, the use of aluminum comes to the third and important most area where 100% growth, where even the first group, there are some people who are susceptible or thinking, no, some pessimistic, some optimistic, both basically come to a conclusion that there are some areas where the growth will be without any doubts. So this use of aluminum in the existing industries, in the future industries, is the one area where I can see the growth will be without any doubt. So today, I am lucky to get this particular topic. There is a growth area without any doubt. Aluminum, as you already know, as a rapid industrial evolution demands advanced surface engineering. Aluminum is a key material across industry. Surface protection is a critical performance and for the longevity. Why aluminum needs surface engineering? Susceptible to corrosion in harsh environment, aesthetic and functional demands are increasing by day. I will just take about 2 minutes, but this is going to be the touching to each and everyone, if not directly, indirectly. Automotive industry is the biggest growth area for the aluminum because of the lightweight material, durability, wear resistance, aesthetic appeal, and EV compatibility. I was fortunate to talk to one of the two-wheeler giant just 1 hour back. I said, I have, mentioning this EV compatibility for the aluminum. He said, sir, don't worry, not only EV, but existing ICE engines, a lot of components are shifted from the existing material to aluminum, and that will also require the anodizing or different surface finishing. So these are the areas as a a coating expert or as a coating industrial is the people, we should know that these are the areas where the growth will be without any doubts. This was my basic points. This is a very big area, and down the line, if you go, some years, 5 years, 10 years, we can see the penetration of aluminum items, especially, either maybe chromatized, maybe powder coated, maybe paint coated, or anodized. But it will be available. The growth area is there. These are the different items. There can be, more items can be incorporated. This is items what we have found it: trims and roof rails, battery housing, interior components, structural aluminum parts, especially in automobiles. This is the one more area we all know. For the 6.7% or 8% GDP growth in India, India requires energy, India requires power, India requires a real energy. The existing sources of energies are depleting very fast, and the solar energy growth area will be without any doubt. In this particular, if you talk to 100 people, all 100 will agree that this area, without any, doubts or any difference of opinion, the growth area remains here. Now, this solar industry requires a lot of aluminum component, which is further going to be required a coating or aluminum anodizing or a surface finishing. Outdoor exposure, low maintenance, long operational life. Now, these are some items: panel frames, mounting structures, support profiles, and coastal and desert installations. Architectural industry is already using a lot of anodizing, and you must be aware of it. Aesthetic consistency and the demand basically from architecture industry for an anodizing is aesthetic consistency, weather and UV resistance, long service life, and low maintenance. Role in architectural applications: facades, curtain walls, windows, doors, railings, and panel. Beyond core industries, even in the household, if you go earlier, just 2-3 decades ago, all the kitchen profiles, kitchen doors, etc. Finally, basically now a lot of new aluminum anodized items are used. Even in your house renovation, you can see the use of aluminum is increasing day by day. Beyond core industry, if you will talk about aerospace, defense, medical devices, consumer electronics, use of aluminum is bound to go. So now today we'll talk little bit about anodizing. What is anodizing? Just for a basic principle, is nothing but an electrochemical process that forms porous oxide film from the base metal as an integral part of the metal using a DC current. How does anodize happen and why it is useful? Anodizing happens by creating an electrochemical reaction. It is an acidic electrolyte. The bath formulation basically will come in the next slide, which induces a form of a dense protective oxide layer on the surface of aluminum. This oxide layer can be dyed with water soluble dyes to get beautiful colors. Some electrocoloring process also we can use it. Anodizing, it improves the corrosion resistance, wear and abrasion resistance to make it suitable for the many other applications. This is a general anodizing process flow, which resembles, if not directly, somewhat basically through any base metal. We require a basically mechanical polish, degreasing, chemical brightening, either you want bright finish or matte finish, then alkaline etch, dismut, anodizing with dyeing and electrocoloring. Then this process, after anodizing, it has to be sealed. The surface has to be sealed after an electrocoloring. There are two kinds of sealings, hot and cold, and it goes for drying for that. General equipment required. It's not very costly, not very high tech, but easily available in India and even many parts of the world. Equipment contains polypropylene, fiberglass tanks. Cathodes contains aluminum or lead, mainly used now as a aluminum. Anode to cathode ratio we have given, agitation, racks, power requirement basically we have mentioned. Now this particular degreasing bath, very, very important step, to produce a light micro etch over the surface. Generally we use either acid base or we can use alkaline base depending on your requirement. It produces a light micro etch over the surface, avoid stains, fingerprints, light oxide of the aluminum. Alkaline based degreasing generally used for mild control etching, can be achieved at higher concentration and temperature, as well as removal of solids and oxides of aluminum. The purpose of etching, why etching is done, it roughens the surface to provide a matte finish. Alkaline caustic bath is generally used, eliminates the extrusion, dye, lines and light scratches. Desmutting, to remove the smut, activate surface, remove smut and surface oxides. It removes the thin layer of silicon, magnesium and copper. Generally, you all must be knowing we use aluminum alloys in the particular as a raw material, which needs to be colored or anodized. It removes metal bonds. We can collect. We have got full particular write-up for this thing. It contains mainly a sulfuric acid bath with temperature 18 to 20 degrees centigrade. Timing is given as per requirement, but generally a range of 10 to 45 minutes, so not very slow process. We require a voltage of 16 to 17, current density at 12 to 15 ampere per square feet. At 15 amps per square feet, we get almost 1 micron in 2 minutes. So 1 hour, 30 minutes, 30 micron. Structure consists of series of hexagonal cells. We'll just show you how it basically at different voltages, how the structure of anodized cells, what we get. Diagram can be, maybe helpful to some people. How the particular the anodized layer looks like. Very, very important. Maintenance, how to maintain. Aluminum cathodes have more advantages than the lead cathodes, as I told you. For n number of reasons, they are now replaced. The proportion of cathode to anode area is generally a 1:3. Unlike electroplating, it's 1:2. Bus bar which runs over the tank should be covered with a hood to avoid a corrosive nature of the bath. Regular cleaning of cathodes helps to keep cathodes active. Hydrogen gas evolved at a cathode. Spilling and spurting of sulfuric acid makes cathode more passive. Cathode becomes hard with the time and will not be a position to carry full current. So such cathode should be replaced, in new cathode bath. Temperature and current density control helps to get uniform thickness, uniform color. Periodical analysis of the bath is generally required to get the regular acid and aluminum metal content. We not mentioned 15 grams per liter aluminum, is maximum permissible. So if you work for 24/7, so every third month, bath is better to be, we can change or replace and reduce the aluminum content. The good control on aluminum bath is the key to achieve the good result. Now, this different kind of colorings are required by the industry. One is by dye, other is by the electrocoloring. Dyes are generally water-based, organic or inorganic dyes, have vast range of colors. Anodized parts are dipped in these dyes with varied timings depending upon the intensity of color needed. How it works on schematic diagram we have given. Also very popular method of, for the architectural design is electrocoloring. In your household, you must have observed with AC current, different metallic salts are used to get various shades of color, mainly, bronze to black. Metallic salts like tin, copper, nickel, cobalt are used. These colors are very uniform and aberration resistance. These are the different types of anodizing finish we get because of the absorptive dyes. Absorption of the either organic or inorganic molecules into the pores of coating by from 1 to 15 minutes. Vast range of colors can be achieved. These are the basically colors you must have seen wherever basically in your household, house. These are the colors used and different current density timing we can achieve this kind of finishes. Here we get this particular electrocoloring and we have to use 316 corrugated sheet of stainless steels. Now sealing is very, very important part because to seal the various oxide pores of the anodized layer so that the corrosion protection is provided from the external element. Mainly two kind of sealing are available. One is cold, another is hot. Cold is used mainly in, only in electrocoloring. For organic and inorganic dyes, we recommend hot sealing. Of course, hot sealing can be used in the both of way. Electrocoloring also we can use it. Maintenance of sealing bath. The pH value is a must to be checked frequently, mainly in 5.5 to 6. At high pH, metal will precipitate, and low pH, the anodic layer will get etched. High variation of metal and fluoride ion lead to a poor sealing quality. Regular analysis of sealing bath is recommended to get an optimum level result the best way from the sealing bath. Fresh seal layer is soft generally. This is a very, very important point. Fresh seal layer is soft when it is sealed with a cold sealing bath. So you need to have 24 to 72 hours. Basically, you have to keep it. Otherwise, it will get ruptured. with the help of rubber and gloves, and curing time needs to be given. So major problems areas basically, is a sealing area. How to test sealing? We are given some acid dissolution test, dye penetration test, salt sweat test. Now the requirement, the customers we are earlier basically was not that much, but now since the industry is increasing, industry is coming, so they'll come with the salt spread requirement, 1,000 hours, 1,500 hours, maybe 2,000 hours, maybe 2,500. So limit. So you'll have to be very particular about the salt spray and the customer's requirement. Performance summary. It passes through corrosion and wear resistance. Ultraviolet color, especially when the use for outer application, UV stability is required, and especially for the solar and etc., where you get very high temperature in the field, the thermal performance, thermal stability also basically checked. Aesthetic durability should not be affected. In the last couple of lectures, we were talking about ROHS and REACH compliance. Even some VOC basically factors we were talking. So this is now going to be the new normal. Whatever coating you go through, whether it meets ROHS or REACH compliance, whether it's affects the environment least way. Otherwise, this process will not be a sustainable for the longer term. So this technology basically can give you, ROHS compliant and REACH aligned finish. Future trends, as we have mentioned, growth of EVs and renewable energy. I can add one more. Even the ICE engine also is going to use this kind of coating. Smart and sustainable architecture, increased demand for eco-friendly finishes. Concluding, anodizing is a fascinating process that has many different applications and benefits. I hope I have covered the basic required thing for aluminum.
Thank you, Mr. Hasmukh, for the nice presentation. Our next talk is on waking up the importance of tin and tin alloy and silver impregnated graphite in achieving global ambitions in electrical and electronic industries by Mr. Ashok Nalwade from Grower and Vale. It's my pleasure to introduce Mr. Ashok Nalwade. He is General Manager R&D. He holds an MSc in Inorganic Chemistry from Mumbai University and an MBA in Marketing from Pune University, combining strong scientific knowledge with business and marketing expertise. He has 30 years of experience in R&D department, entailing basic research activity to develop various processes in the area of metal finishing. His special achievements are to develop some organic intermediates to be an additives to manufacture the specialized brighteners for electroplating of metals like zinc, nickel, copper, etc. He has developed various range of antique finished products for textile zipper fastener industries. He has also developed high-speed tin plating products for cable and wire industry and approved BAC cleaners for aircraft industry. His significant achievements are to develop eco-friendly processes. He has developed MSA-based tin and tin alloy alternates. He has developed silver graphite for EV vehicle coating, high performance composite material used for critical electrical and mechanical systems. He has also developed a non cyanide stripper for silver. Over to you, Mr. Ashok.
Thank you very much. Today I am presenting on tin alloy and silver graphite. In earlier presentation, we have much more learned about the tin and silver. In this topic, we have learned about the tin and tin alloy, how to replace the tin alloy, tin lead, and silver graphite. The topic cover is uses of tin and tin alloy, how the evolution takes place. Then what is a whisker and what are the factors affect the whisker in tin plating? How whisker suppressed by the lead and what are the tin lead free alternate? Then surface morphology, a tin lead versus tin alloy. How mitigate the lead free and soldability comparison study in tin lead and lead free solder bath. And silver graphite is the best solution for high energy consuming devices and EV charging connectors. All of you know that the tin and silver is the most valuable metal, and we can call a tin as a glue in a electronic assemblies. Here you can see that the global market, it is mostly used for the soldering purpose, more than the 50%. And its application is very wide. It can be used for a next generation lithium ion battery as an anode. It used as a protective coating on steel and copper. And nowadays it is mostly used in a semiconductor. The day by day, the uses of the tin is increases in electronic and electrical industry, mostly in the defense, space, and medical field. Just I would like to know, tell you about how the tin evolution takes place. You know, in the early age, in the historical phase, the tinning is nothing but the dipping process. They dip in a molten tin and it's deposited on the surface of the steel and copper. It's just like a protective coating because it's a less toxic. Is not toxicity is very therefore it is used in a food can. And in the early 20th century, there is a emerging of the acid tin plating. The acid tin plating is nothing but the sulfuric base and methyl sulfonic acid base. But the problem is in a tin plating is that tin found to be form a whisker formation. And this tin whisker formation, due to this tin whisker formation, uh, there is a chances of short circuit. Therefore, in the mid 20th century, when the electronic industry arises, that time this issues arises very high, whisker formation. And what happened that time? They introduced the lead with the tin. And to mitigate the whisker formation. Then in the modern area, the tin, all of you know that the lead is a toxic. Then it's further it is lead-free alloys as arises. That is tin copper, tin bismuth, and tin silver. This is some example of the tin whisker. There is a hair-like filaments come out. And what happened? It breached the gap between the two connectors. And it is a catastrophic, a short circuit is appear. And this is very, very dangerous. Once a short circuit is happen. how the whisker formation takes place. Normally, when the tin get deposited, that time with the temperature and volumetric changes in the deposit, that time what happens? The deposit is a tensile stress. Initially it is in a tensile stress. When the hours are after the day, this tensile stress converted into compressive stress. And this compressive stress is appear due to the formation of copper and tin intermetallic compound formation. You can see here at the layer of the substrate and this tin, it forms a intermetallic compound, that is copper 6 Sn pi. And what happens? This increases the compresses the stress and it ooze out, it come out to the surface of the tin. So what are the factors which affects the whisker formation? One is the plating chemistry. What type of the brightness we use in the plating chemistry? Second, the substrate, brass, copper, or alloy 42. Sometimes if it is a base is tin copper, there is a chances of whisker is very high. Then plating chemistry, plating process, that is current density, bath temperature, and bath agitation. Then the last and important is the deposit characteristics. Deposit characteristics is very, very important. That depends on the grain size, then the shape of the crystals, crystal orientations, deposit thickness, and tin oxide form. And the last one is the environment, that is temperature and the humidity of that. How the whisker takes place in tin surface. You know, the tin deposition normally is a columnar structure. And due to that, the intermetallic compound formation, it ooze out very easily. This whisker come out, the hair-like filament come out very easily. But when we introduce the lead in that, when we are adding the lead incorporating with the tin around 40 to 37%, what happens? This structure get changed. Columnar structure changes to coax substructure. And what happens? This compressive stress will not come out very easily to the surface. It get dissipated, it get dispersed, and it mitigate the formation of the whisker on the surface of the tin. Lead, all of you know that is a neurotoxin to the environment. It will affect to the all part of the body, kidney, liver, all part of the body. It will not hazard to the, it will affect to the environment also because it is a biodegradable. It's remain in the soil and it's contaminate the soil, plant, and aquatic animals. Then we must needs to think on what are the alternate for the tin lead. Before that, the European country, they make a directives. And what they suggest that the lead content in electrical and electronic, it's 2.1%. Even in the occupational exposure limit, they reduce from 0.15 milligram per meter cube to 0.03 milligram per meter cube. So what are the alternate? Tin bismuth, tin copper, and tin silver. In this presentation, I will explain which alloy is the best alloy to replace the tin lead. First one is a tin bismuth alloy process, in which we have taken tin metal 8 to 12 grams per liter, bismuth is around 1 to 2 grams per liter, acid concentrate 140 to 150 ml per liter. This is a MSA-based bath, methane sulfonic acid bath, and it's operate at temperature around 40 degrees centigrade. Cathode current density is 0.5 to 1 ampere per dm square. It gives a satin type finish, matte finish. and alloy percentage will get it around up to the 5%. It increases with the current density, you can see in the graphical representation, and with increase with the bismuth concentrations, it increases the deposition of the bismuth. Next one is a tin copper. This is also same methane sulfonic acid base. Here tin metal we take it at a higher side, 30 to 35 grams per liter. Copper metal 7 to 8 grams per liter. And acid concentrate we take it around 250 ml per liter. Its work at the room temperature, and cathode current density is 1.5 to 2.5. It gives finish like a gray whitish finish. And you can see in the graphical representation, the alloy percentage, it gives around 10 to 9%. And it remains same around 15.6 to 12.7% in 1.5 to 2 ampere per dm. With the copper concentration, it gives around 9 to 10% if you are increase the copper concentration. Then tin silver, tin metal is 15 to 25 grams per liter. Silver metal, we take it around 0.5 to 1 gram per liter. Acid concentrate 140 to 150 ml per liter. Cathode current density, we use 0.5 to 1.5. In graphical representation, we can see here, it gives around up to the 4% of the silver deposit with the current density. Here, once we increase the current density, the deposit decreases. With the silver metal concentration, it can be reached up to 6.9%. The surface morphology is the main role. Already I explained you how the tin lead, it changes the structure from columnar to equiax. So here we have comparison for the different structure. We have taken a tin which give the columnar structure, tin lead, equiax. You can see here very regular and compact. Tin copper is irregular, the size is bigger as compared to the tin bismuth and tin silver. Tin bismuth is a bimodal structure, and in case of the tin silver, it is very compact fine structure. We have done the IDEX. Tin is 100%, tin lead 65-35%. Tin copper here you can see a copper percentage is 9%, tin bismuth 4.7, and tin silver is 3.1. Whisker growth mitigation, we have done a test. We have put it in the humidity chamber as a thermal cycle test condition, high temperature 85 and low temperature minus 40 degrees centigrade for 1000 cycles. In this case, what happened? The tin is spontaneously, the whisker formation takes place. But in case of tin lead, tin silver and tin bismuth, there is no whisker growth formation as appear. Similarly, if you can see here, in case of tin copper, tin silver and tin bismuth, see here it forms intermetallic compounds like copper 6, SN5. What happened? They increase the stress, compressive stress, increase that, and there is a chances of the whisker. But in case of tin silver and tin bismuth, in case of tin silver, it forms a silver Ag3SN intermetallic compound. But here you can see there is a less level of compressive stress. This compressive stress is not to formation of the whisker in case of the tin silver. In case of tin bismuth, the bismuth melting point is very low. It's similar to tin. Therefore, there is no intermetallic compound form. And there at the boundary of this one, surface, substrate, and this area, it is remain in the pure phase structure. Therefore, there is no chances of whisker formation in tin bismuth. After that, we have studied the solubility test. In solubility test, we have tested the zero cross time test. We have here taken a tin lead based path, solder path, as well as lead free based solder path. Lead free solder path we have prepared 96.5, silver is 3 and copper is 0.5. Here you can see tin lead, it gives 0.6 second, and tin bismuth, it gives 0.8 second. The tin bismuth gives better results as compared to tin copper and tin silver. In lead free based solder, here we can see tin lead is 1.2. In a lead free solder, tin bismuth gives a better result as compared to the tin lead. So we can say that among these three alloy, the tin bismuth is a best solution for the tin lead. My next topic is silver graphite. You know, in EV vehicles and high energy devices, they require thermal conductivity, electrical conductivity, as well as lubrication. For lubrication, we have introduced a graphite. This is a cyanide-based electrolyte. We are adding a dispersant. Along with the dispersant, we added a graphite powder. We have done this component at the room temperature. Current density applies 1.1 to 2.5. Here the graphite deposition is 1 to 3%. You can see in this picture, the graphite get embedded along with the silver. So what are the advantage of the silver graphite as compared to the silver or hard silver? The most of the time in connectors, they use the hard silver. But what are the effect of the silver graphite? If you use in the connectors, we have done this test by SRV machine test. We are applying the load 9N and frequency 8 Hertz, amplitude 4 mm and test duration 300 seconds. Here you can see the coefficient of friction in silver graphite is 3 times less than the silver. And even though it is better than the hard silver. The another test we have done, that is wear rate test and contact resistance test. With comparison with the bright silver, silver graphite wear rate is very, very high as compared to the silver. In case of contact resistance, we are applying the load 10N, thickness is 10 micron. You can see in this representation, normally in silver plating, it gives a fluctuating and it is not stable with the wear time. In case of silver graphite, the contact resistance is very much stable. Therefore, silver graphite is the best solution to use in the EV vehicles and high energy devices. Here some of the applications I have given where we can use silver graphite like slip ring brush, spring brushes, in circuit breakers and switches, and high power charging. The advantage of this is low voltage drop in case of silver graphite. It is a self lubrication property, reduce the wear and frictions. Arc resistance maintain the stability under high electrical load. And summary, in case out of 3 alloy, tin bismuth is the best solution to replace the whisker free replacement for tin and tin lead compound in the lead free manufacturing. Tin lead plating will be the transfer to tin bismuth or tin silver in semiconductor industry, eliminate the lead from their product range as it is very toxic and can cause the industry's workers many long-term health problems. The friction coefficient of silver graphite is around 3 times lesser than the bright silver. Wear rate of the silver graphite coating is approximately 6 to 8% of the wear rate of pure silver coating. Contact resistance of silver graphite is very stable, showing high stability compared to the pure silver coating with respect to wear time. New demands for recent development technology such as AI, 5G, renewable energy required highly stable chemistry which comply with the ROHS and REACH regulations. Tin bismuth and tin silver is the best solution. Silver graphite is the best solution for high energy consuming devices EV charging connectors due to low coefficient of friction, less wear rate, and stable contact resistance. Thank you very much for your kind attention.
Thank you, Mr. Ashok Nalwade, for the very informative talk.
Arcing contact, na?
Yeah, that's it. Yeah. That's also not mentioned. Thank you. Nice, very
Thanks, sir. Very nice. Yeah, present with this one, see. Online analysis.
I have to reconfirm whether it's the same. So this. Daniel, na? Mr. Daniel. Daniel, right. Hello, Mr. Daniel, our next speaker. Mr. Daniel Premet currently holds the position of Vice President, Electronics and Industrial Solution of Aromex Group. Right? Nice. A specialty chemical and solution provider for PCB, surface finishing industry based in Bangkok, Thailand.
Good afternoon. Good afternoon. Can you hear me? Yeah, thank you.
His career in 1987 as a product manager in PCB manufacturing in the UK and then moved to Hong Kong. He worked in both Hong Kong and Singapore as regional sales product support for Alpha Metals. Daniel graduated in applied chemistry from Nottingham University, UK. He also holds a postgraduate diploma in management studies. Daniel lives in Pathum Thani, Thailand.
Okay, thank you. Thank you, everyone. So good afternoon. My name is Daniel. I'll try to keep this short and brief. I'm very happy to be back in India presenting to you again. I have to say that the first time I came to Bengaluru was in 1994. And that time I was living in Hong Kong, supporting mainly the business in Asia and China. There's been a tremendous shift of industry coming out of Europe, Western Europe and USA to Asia. And now I'm happy to see this is now moving out of China to Southeast Asia and to India. And there's huge, tremendous business opportunities for us all with this movement of industry. We saw earlier the movement of the automotive industry, the electronics PCB industry, the semiconductor industry, AI and server, etc. I'm here to introduce you a little bit about Oromex, what we do, how we're here to support you. We have within the Oromex group of companies a company called Integrated Solutions, Southeast Asia, and they're our equipment division that are helping to support our customers.
So what I would like to show you today is we talk about process control, process management, look about how this affects manufacturing, industrial operations, and it's the management of the process variables to ensure consistent, sufficient and reliable performance of a process is critical. What we've seen, I've seen over the years, has been a development of far more smarter and integrated solutions in the electroplating process so that we can really use advanced sensors, real-time analysis to control the baths, to control the plating technologies that we're using so we get consistent results, consistent plating quality, operation efficiency, lower costs, and avoid deviations in terms of quality. So running quickly through the presentation, I'll look at the process control, the developments of what's been happening to the systems, particularly what's happening now with the introduction of more AI and AI control systems. The overview of the type of design and why it's important of the design in the integrated process. The types of automatic analysis and dosing control that's available. The different applications. I mentioned a few, but there are numerous. And also some auxiliary systems that are used to improve productivity, efficiency, reduce costs, which I think are very important that we support our customers with the introduction of these technologies. Oramex as a company has been in existence for almost 60 years. We're based in Bangkok, but we have companies in Vietnam, Indonesia, China, Malaysia, and now I'm happy we have a business together with Galvanitech here in India. We have manufacturing in India, in Vietnam, and in Thailand. So we're producing our chemistry in these three locations. And we have a growing distribution network, mainly in Asia, but we're looking to expand this further. Currently, we're about 360 staff worldwide supporting businesses. We segment our business into industrial solutions and electronic solutions. We cover all the wide areas that are used in the general metal finishing business, from plating on plastics, decorative plating, copper, nickel, chrome plating, corrosion resistant zinc, zinc nickel, zinc alloys, even zinc plate plating, light metal technologies, which includes anodizing and pre-treatment for light metals, aluminium and magnesium, electroless nickel, functional chrome technologies that are used in different performance-related industries, precious metal plating, which is mainly used in the jewelry, but also used in functional applications, buffing compound technology, so all the pre-treatments, preparing of surfaces, and of course, cleaner technologies. The area where my most experience is actually in the electronics and the semiconductor, PCB and wafer industry. And we also are supplying in different chemical processes, whether using PTH or copper or tin plating, surface finishing, nickel gold, NEPIG, immersion tin, etc. Semiconductor and functional electronics, so connectors, lead frames, etc., this type of business. So we're a manufacturer of specialty chemistries, but in order to support our customers, we need to offer solutions to them. So service, support, but including equipment solutions. So our company here, the ISE, is a company that is supporting from the equipment side. When we look at the process control development, you will see that there's been various generations in existence. So certainly when I started working in the industry more than 40 years ago, it's very much a manual-based system with manual dosing. They're doing the manual titrations, making some additions. Then moving into second generation chemical dosing, online analysis, which has been present for many years already and is very mature. And then now we're moving into the fourth generation of AI smart control systems and smart factory systems. And when I see many new plants that are being built, the technology has been transferred, is going into this direction of smart systems. I think we're all aware of why we're doing this in terms of process control, so that we can keep within a very narrow process control range and improve our processes. So what is driving the change in this supply industry is related to the arrival of the digitalization. So in, Industry 4.0 is definitely focusing on intelligent manufacturing. So most of the control systems that are being introduced now can be linked into a smart factory design and a smart factory system. So it's called intelligent manufacturing. Of course, we're all looking for continuous improvement for quality. And this is essential that we do this so that we control between the different batches. Every flight bar that's coming off the line is coming off with the same quality, same reliability, and done in the most cost-efficient way. I think this is also an important point. Environmental and health and safety management is also important. We talk about, yes, REACH and REACH compliance regulations, but actually all tier ones, all OEMs are looking for all manufacturing companies to drive down their carbon footprint and have a roadmap to drive down their CO2 production or CO2 equivalent production and to reduce energy and reduce chemistry consumption. And by using these control systems and recycling systems, you can move towards in this direction for increasing your CO2 or reducing your CO2 footprint rather. And then rising labor costs and finding people, recruiting people. We do see that this shift of industry to Southeast Asia, India, actually means there's a lack of people with expertise and knowledge. And by automating many of these processes, you can help to overcome or mitigate those problems within finding the right people, training the right people. Of course, there is a cost factor, and the people with the specialist skills, their costs are going up exponentially at the moment. So why we think and why it's important to use the online analyzers? Obviously, in terms of economy, we do need to have multifaceted, multi-channels optimization of the design of the system. So we try to keep it standardized. We try to keep a very simple, efficient system, and we try to use components that are readily available. They're not made for an individual system. We need obviously a very reliable system with automatic calibration, different pre-treatment units. Sometimes you have to remove the gas, reduce the temperature for the solutions before you come in. We need to have fault alarms, error proofing, maintenance reminders. Again, this is all coming around to predictive technology using AI, so you can analyze and see when things need to be maintained or replaced. Of course, traceability, important when you're supplying into key electronics and automotive industries. And of course, the surface distribution needs to be very critical in terms of process capability analysis. Intelligence. So we need a self-diagnostic analyzer. We need remote technical support. There's pros and cons of this. If you're linked into the cloud, obviously that makes it accessible or potentially accessible for people to hack. So there are companies that really do not allow these systems to be put on external servers or into the cloud system to avoid this risk. And then self-standardization solution check, so self-calibration. So in the past, this third generation of dosing equipment, you need to go along and do all the calibration yourself. Now the latest generation, you can do this. And of course, automation is important. Automatic cleaning, automatic waste discharge, or automatic replenishment for the standard solutions for the water. Digitalization, I can go through this. Temperature, concentration, solution, conductivity, pH, etc., are all parameters that are collected and need to be collected and stored for your customers so you can demonstrate process capability. You need to have that traceability back. Typically, it's 5 years. You can view that, as I said, on your internal systems, and you can transfer this data by LAN or Wi-Fi. But you can also do this in the cloud, as I said, which is both, as I said, some positives, so you can access from anywhere. The negative being, as I said, with potentially everyone could hack that. There's lots of different techniques, analytical techniques that are used in these control systems. We've picked out 4 here. There are many more. I just want to demonstrate a few. One is using potentiometry, calorimetry, conductivity, and XRF. There are others. Pretty much you can analyze everything that you need to, that you're using in your working bath. Potentiometry, simple chloride analysis, where you're using 2 reference electrode, an indicator electrode. You're measuring the potential, or the analyzer is measuring the potential difference of the solution, and then on the basis of that result, sending a signal to the pumps to dose into the solution. You can use this also in light metal or anodizing technology, where you're analyzing using a base acids alkali base reaction with a neutralization based on a pH measurement. When you're reaching a certain pH measurement, then you're able to do the dosing of the different chemistry and analysis. You can use conductivity, a similar type of method. But again, you're looking at the linear relationship between the alkali and the acids in your working bath. And based on the readings, they will recommend, they'll give a signal to the dose, to dosing a certain amount of solution to maintain your process control. So the online analyzer base units, they can be, they're sort of modular. So based on the number of tanks and the number of different chemistry they're using, they are standardized to fit into the individual line. Where I like this, it's a compact unit. It's a fairly small footprint. Depending, as I said, the number of tanks, they can serve maybe 1 tank, or they can serve 3, or you can have 3 separate units. It already depends on your line configuration and setup, and we can help you that when you're designing your line and what you need for the system. Yeah, it's made up of several different boxes here. The analysis control center with the probe, the online analysis unit in here, and the different reagents and cleaning agents and autodosing for water stored in here. Important is accuracy. What I like about this system is even when you introduce a dilution factor, we all know, if you have a dilution factor, there's potentially more area for error, area for error in the reading of the analysis. But we can see here that even with a dilution factor down to 20%, we can still maintain a very accurate analysis. Analysis is one part of it. And what I like about this type of system is it using a so-called dashpot system. So instead of just dosing using a metered pump, you're dosing into a dashpot, and then it's dosing a measured amount, a fixed amount. So you cannot really overdose and you cannot really underdose in this. So I think it's not only related to the analysis, it's also in the setup for the dosing. Yeah, so we have, as I said, what we're aiming to achieve is a CPK value of over 1.6, or a less than 3% relative standard deviation. Once the initial dosing is set up based on maybe square foot, ampere hours, or on area, the system then analyzes and automatically adjusts the dosing based on the results. And then it continues to online real-time analysis to adjust the dosing so that we get a very small fluctuation of the chemical in the working bath. As I said, there's numerous applications for this type of technology. Palladium is one. We all know that all metal prices is increasing significantly, Everyone's trying to reduce the amount of metals, whether it be palladium, gold, silver, whatever you're using in your bath. And you need to try and control this at the lowest level possible to achieve the plating result that you need. So a palladium analyzer, in this case, it's one used in plating on plastics, where we're using colorimetry. As I said, it's a real-time analysis. We're able to analyze dosing based on 2 different replenishment systems. So the palladium itself, plus also the replenisher solution. Yeah, as I said, it's not just buying an online analyzer and installing it. It needs to be really designed for the process that you're running. And it's not only the analyzer itself. So in this case, we are using a condenser, obviously a sampling plump. We need to break down the foam before we go into the analyzer, because this is affecting the result. And then in the end, we will send the solution to the probe, which will send a signal to saying what is the concentration of the palladium, whether it's 10 ppm, 15 ppm, etc. And then it will dose based on the requirement of both the palladium and the replenisher. Electroless nickel, both alkali and acidic systems. This one is designed for a replenishment using 4 different replenisher systems. They can really be designed on what the requirement is for the line. Again, it can be used for both in electronics and also in the industrial solutions or general metal finishing here. Same features, same benefits, standard module unit. Quite efficient here. And as I said, you have along the bottom here, in this case, 4 different dosing solutions that you're replenishing. This is more of a description, but again, there's also other features that can be added in here with pH calibration, automatic cleaning, nitric acid passivation of the tanks. This is also important to check the pH after you clean the tank with nitric. Electroless nickel, standard self-solution check, probe, etc. So there's lots of things that could be added in. So what it's seen as being a relatively simple system is actually very sophisticated in terms of getting an accurate result. This is a schematic. The sampling, obviously you need to cool it down. Typically you're running 80 to 90 degrees temperature for your EN. You can't analyze, or if you precipitate in your pipes and in your analyzer, you need to cool this down first before you go through the system. Functional plating, well, basically you can have a system for whatever solution you're plating. There is a solution out there available. Nickel, chrome, acid zinc, alkaline zinc, acid zinc, alkaline zinc, nickel, etc. Even zinc iron is available. In electronics, yes, it's widely used in the PCB industry for this type of control, whether it be for PTH, whether it be for acid copper, whether it's for ENIG or immersion tin plating. In the connector semiconductor area, we use this in almost all the electrolytic plating processes: nickel, pre-plate, liquid plating, or the precious metal plating. When we approach customers, we're not only approaching to give them a chemical solution, a process solution, we want to offer a systems approach and a service approach. We try to be a customer-driven company. So we have a solution here. This is not something we develop ourselves. This is from our friends at Saga Mac. I'd say this has been very successfully installed in Southeast Asia. Customers very happy with this approach. It's a cyclone-based system. If you want to find more information, please approach us or approach our friends at Saga Mac here. We have a different system for flow back, washing back traditional filter systems. Again, this is improving the efficiency of the system, reducing costs. Nickel recovery. Again, we have a modular system for nickel recovery. We have a similar thing for copper. Obviously, as metals are continuing to increase, we have more environmental requirements. we need to recycle the metals as much as possible. So this is taking the rinse water, concentrating the rinse water, supplying the water back into the system, depending on the purity level you need. You may or may not need RO membranes on it, but and also returning the nickel back into the working bath. So you can take the drag out water, recycle it, and put it back into the working bath. It is a modular system, as I said. So depending on the amount of nickel you're processing, you may need more modules. In summary, very quickly, yes, the aim of these systems is to enhance process efficiency, optimize the parameters, introduce safety and improve safety for our workers, reduce costs, improve quality. There are advanced AI control systems available now. They can be integrated with all your digital technology you have, so smart factory systems, and they are compliant with all the regulatory requirements. And this is a very important going forward with your CO footprint reduction. And with that, I'd like to say thank you. Thank you for your time.
Thank you very much for the nice presentation. Not many people seem to be talking on the online analyzers. Yeah. So we'll come to the next presentation, which is on color anodizing, dye tank analysis, and troubleshooting for controlling shade variation by Mr. Adish Rathod from Oswal Udyog Private Limited.
Hello, Mr. Harish. Adish, come. Welcome. Yes. Yeah, Mr. Adish Rathod is Managing Director of Oswal Udyog India Private Limited, a pioneer in production of aluminum anodizing dyes in India and exporting Indian-made anodizing dyes to over 20 countries. He did his bachelor's in engineering from DJ Sanghvi College of Engineering, Mumbai, and MBA from Wellington Institute Management. Has been working with Oswal Udyog since 20 years as a second-generation businessman. Please start.
Thank you. Thank you, sir, for the introduction. And thank you, MFAI, for this opportunity to speak on this subject, which has been the focus of my career for last 20 years, coloring of aluminium and how to control the variation that we get. As the growth of anodizing in India is happening rapidly, lots of color anodizers have started color anodizing, changing their systems from conventional anodizing to automated lines, adding more and more color tank, and that has kept on adding the complexity of color variations. So we will observe what are the best conditions for color anodizing and how to control the variations. A little bit about our company. I represent Oswal Udyog India Private Limited. We are an ISO 9001-2015 certified company. We are a star-rated export house by Government of India, exporting to over 20 plus countries. We are a team of qualified chemists and colorists. Our factory is located in Vasai and one in Pithampur. Now, coming to the topic today, what type of anodizing is most preferable for color anodizing? So, type 2 anodizing is the one which is most preferred for color anodizing. When we look at type 1 anodizing, which is chromic acid, it has poor performance when it comes to coloring because the coating is very thin. There is not enough porosity for the color to get absorbed within the anodic film layer. And when we go to type 3 anodizing, which is a hard coat, the coating is very thick and dense. So in this also, the dye molecule cannot get trapped within the anodic film. So type 2 is the best for color anodizing and decorative coatings. This is a typical aluminum anodizing chart. Starts with pre-treatment, etching, desmutting, anodizing, coloring, and sealing. These are our different products and different systems for different tanks. A lot of speakers have spoken about anodizing and pre-treatment, so I will go to my topic for today, which is of anodizing, coloring. Now, type 2 anodizing. These are the best conditions for type 2 anodizing. These are standard conditions. H2SO4 content in the tank, that's the electrolyte of 18 to 20%, voltage of 15 to 17 volts, current density should be 1.5 ampere per dm square, temperature of 18 to 20 degrees Celsius, and a time of 15 to 45 minutes. Now, how do we, just a simple and quick formula to calculate the thickness based on Faraday's law is coating thickness in micron is 0.3 into current density in ampere per dm square into time in minutes. This will give you an approximate coating thickness. So if you want to do 20 microns at 1.5, just 45 minutes of anodizing will give you 20 microns of coating thickness. Then after anodizing, the next step comes is coloring. For coloring, our product range, almond dyes, which are the organic dyes, have become an industry standard now. We have a range of 32 unique dyes, which are most of them are single component dyes and have shown excellent performance and compatibility with different kinds and different grades of aluminium. These dyes are used in different applications for architectural, engineering, aerospace, defense, automobile, electronics, cosmetic packaging, etc. So this is a typical anodizing layer and oxide layer, and this is how the dye gets filled within the pores, within the oxide films. The aluminum oxide film is a very porous film, and when we do type 2 anodizing, which is between 15 to 25 microns, the film formation is very good and very suitable for color anodizing. So this is our color chart, about 32 colors. And now, when we do color anodizing, what is observed? Color variation. What's the problem? And why is it so critical? So customer rejection and rework cost is very high. Batch to batch inconsistency is the reason. What controls color shades? So first and the most important thing is the anodic film thickness. If the film thickness is inconsistent, there will be color variation. If in your previous batch, the coating thickness is higher and in the current batch, the coating thickness is lower, the color absorption will definitely be lower. So there will be color variation. And even many times it is observed that on one single object also, if it's a large object, there is going to be color variation. So that's why we said there has to be some kind of agitation within the anodizing tank itself. Next issue is the dye concentration. So a lot of dye users don't have a way of measuring the dye concentration. So it's very important to measure the dye concentration accurately, because if there is a change in dye concentration in the dye tank, there is going to be variation in the shade. Bath temperature. Now, bath temperature is also a very critical method. Many anodizing plants, they do dyeing at room temperature. Now, dyeing at room temperature causes a problem because in summer there will be a different room temperature and in winter the temperature will be different. So again, there will be a lot of variation between the batches. And even in a single day also, there is always a time variation. And next is the immersion time. If the line is automated, immersion time can be controlled. But in many manual lines, a lot of times the operator may not handle it with the correct time accuracy, and it can lead to variation in shade. pH, this is also a very critical parameter for dye tank control. Dyeing happens best if it's organic dye with a pH of 5.5 to 6.5. This is the best condition, 5.5 being the most optimal. Many times if there is a variation in pH, for example, if the pH goes above 7, so the rate of dyeing will be much slower. And if the pH goes below 5 or 4.5, then the dye starts getting insoluble. There will be precipitation, and again, the rate of dyeing will be slower. Next is the contamination. Now, what is this type of contamination? There are many types of contaminations. One is, the biggest contamination is the drag over of acids coming from the anodizing tank itself, or the tank is kept in an atmosphere which has dust, and there's dust getting into the tank, or because dye tank is operated at a pH of 5.5, a mild acidic condition. This is a very ambient condition, or a very a condition. This kind of condition has a very high growth of algae and uh, biocontaminants, what we call them. So that also needs to be corrected. And the most important thing is the alloy variation. If the base alloy, what we are doing the anodizing, that has variation, then of course the result will also have a lot of difference. So these are the control parameters what we need to look after. Dye tank chemistry, how can we control that? So optimal dye concentration control is the most important thing. Drag in contamination. So we have to have very good rinsing systems. Rinsing should be done properly so that the drag over acids are avoided. Bath aging effect. The bath age need to be monitored. Proper log sheet should be maintained. When was the dye tank made? When was the dosing or the replenishments or things have to be done. So this is a very important thing. And metal impurities impact. Many times a lot of dissolved aluminium and other metals also get dissolved in the dye. Some common causes of shade variation is uneven anodizing thickness. I already spoke about this. Improper rinsing will lead to uneven shading. So in improper rinsing, what happens is when the acids get carried over on the metal surface, when the dye tries to enter the dye pore, and if there is an acid trapped inside the aluminum oxide film, it will discolor that dye. So you will observe patchy appearance. Again, low dye concentration will lead to lighter shades if the dye concentration is not timely replenished. Lighter shade and not enough color depth. Alloy inconsistencies. And one more thing, a lot of times proper sealing is not done, and the sealing may not be compatible with the dye. It can lead to bleeding of the dye. When the batch is, after coloring, it's immersed in the sealing tank, there can be bleeding. So it's very important to check with your dye supplier and the sealing supplier that the dye and the sealing should be compatible. Now, the troubleshooting first is verify the thickness. Whenever you have the variation, most important is to first and foremost, you should verify the thickness using the thickness gauge. Once the thickness is established to be correct, then you should go to the next step is to check the dye concentration in your dye tank. If the concentration is okay, then review the temperature and the pH systems, the pH of the dye tank. If there is any temperature variation in the temperature, please check your heating systems and get the temperature collected. If there is an issue with the pH, there is a chance that the pH may have become more alkaline due to the water addition, or more acidic due to the acid drag over. So you will need to use the correct buffering systems. Connect with your supplier or with us to check what type of pH additives should be added to get the correct dye tank pH. Because some of the colors you have to use organic acids, for some you may have to use different type of acids. Avoid using very strong acids and very strong alkalis for correcting the pH. And also evaluate the sealing. Whether the sealing that you are using, sometimes the sealing can be causing the bleeding of the die, or the die may be bleeding more in the sealing. And sometimes, even a lot of times, if you're using nickel fluoride based systems, it can lead to a green tinge on the surface of the aluminium. So that needs to be checked. Now, how do we control the shade, or how is it checked? So the most importantly, we use the spectrophotometer to check the die, check the variation in the die. And most important are the LA and B values, LAB values. Now L stands for the lightness range. 0 is for black, 100 is for white. And here you can see is the LAB range, the LL range of the darker and the lighter. A is the green-red axis, greener, redder. B is the bluer, yellower, bluer, yellower. So when you do the analysis between the standard and the batch, you can get this kind of a chart with the LAB values. So here, I'll go to the next slide and come back to this slide. From LAB, you can calculate the delta E, which is the color difference. This is the formula for delta E. These days, very good softwares are available which can check the delta E for you. And how do we typically evaluate the delta E value? So delta E less than 1, there is always going to be some variation between batch to batch. But if the delta E is less than 1, that much variation is not a visible difference, and it is considered as imperceptible and no visible difference. So this is an approved lot. Delta E of 1 to 2 is a very small color variation and perceptible only to trained eyes. So this may be a case-to-case basis. You need to check with your customer whether this should be approved. Delta E of 2.2 to 3.5 is a small color difference, noticeable to most people. And 3.5 to 5 is medium, which is an obvious difference. And delta E of above 5 is a very large difference. It's a totally different shade. So LAB is calculated between standard and the batch. This is the difference of L, A, and B, gives you a delta E of 0.391. So this is less than 1. So this batch should be approved. So this is the shade testing for. So this is how the color difference delta E is evaluated. Preventative control strategy is that always have a standard operating control system for your die tanks, proper log sheets, control die top-up system. Whenever there is a top-up done, please keep a log of it and measure, and dummy panel comparisons. So these are some of the examples of color anodizing. Lot of beautiful shades and decorative anodizing is being done these days. Thank you. And I'm available at stall number B135 for any more queries, or if you want to have a detailed discussion on color anodizing. Thank you.
Thank you, Mr. Adish, for the nice talk.
ચેરપર્સન નથી ને ખાલી વાળો જતો કાકાને બોલાય દે કાકાનો જો
Johanna, what is it, sir? Working on a leave.
Hello. Now I am inviting Dr. R.J. Podolia as a chairperson. Kindly come on the stage. Dr. Podolia is distinguished scholar in industrial veteran with over 4 decades experience in organic chemistry and medical medicine. He holds a PhD in organic chemistry from Aerospace University, Baroda, where his research focuses on the synthesis of benzo pyroderivatives. Professionally, he has served as the CEO of the very top industries in 1990 and has been a regional expert for the Gujarat cleaner production center since 2008. Please welcome Dr. Vihalia.
બોલશો તમે બધા સરકાર ચાલુ છે ને હા બોલ પછી આ બીજે હા પેલા આજ બંને સાથે જ સૌ I like to call Mr. Vidyut Kumar Manna, Dr. Vidyut Kumar Manna and Mr. Subrata Sarkar, a profile of the precision on the zinc and zinc alloys, retrospect and the prospect. Please welcome Mr. Manna ji. Dr. Vidyut Kumar Manna is a doctorate in chemistry and has industrial research experience of the 32 years in various fields of the chemistry, including electroplating, aluminium, surface treatments, chemicals, organics, synthetics, emulsions, polymerizations, and the nanomaterials-based products. He has a publication of the one European patent and one US patent for his work on electrodepositions, zinc and iron coating for corrosion resistance. He is a present leading a team of the 20 to 30 scientists, chemists in the laboratory of the GTZ. Please welcome Dr. Manna ji. Can I start?
Good afternoon, everyone, and my sincere thanks to chairperson of this session. I will be presenting a profile of passivation on zinc and zinc alloy, retrospect and prospect. Main discussion will be development of passivation chemical beyond hexavalent. So this will be the content of my presentation. Why leave hexavalent chromium? Next is trichrome generation or gradual evolution, chronology of trivalent development, cobalt-free breakthrough. Fourth is mixed chromium composite. Fifth is pigmented passivation versus dye passivation. And sixth one is the chrom-free future passivation. So regulation that kill, I will be discussing on that kill hexavalent chromium. Key regulation is end of life vehicle, ban hexavalent chromium in automotive component, WUI, that is OS, electrical and equipment, electronic equipment, that is hexavalent chromium is also banned in that sector. The extraction of hazardous substance, that is ROS limit is less than 0.1% chromium, 6, and substance of very high concern candle list. It is also the extraction of chromium and cobalt. So, hexavalent chromium, health and safety impact. Extravalent chromium is very less TLV value, threshold limit value. So, it is difficult to maintain that in the working environment. Second is waste treatment is little bit complicated. And last is the health hazard issue. In hexavalent chromium, all the hazard symbol is applicable like oxidizing, corrosive, and even it is also all the 6 hazard symbol are applicable to hexavalent. That is even marine pollutant also. That's why hexavalent alternative is required. So what are the alternate to hexavalent? Primarily it is 4 type of mechanism and chemistry to replace hexavalent chromium. That is, first one is pH control precipitation, and pH control precipitation, the pH can regulate the film formation. This sector cover trivalent chromium, titanium zirconium based product, and cerium cerate based product. Number 2 is redox plus precipitation. Normally, the higher valency state of metal is highly soluble. Its lower valency is less soluble. That's why reduction is needed to enhance the precipitation. In this sector, molybdenate conversion coating, permanent conversion coating, and vanadium conversion coating come in this category. Third is the more or less organic coating coupling agent. It is based on silane and nanosilica based coating. It's formed a little bit chemical bond with the metal surface. And fourth, the ultimate one is barrier coating, corrosion protection by the forming a physical barrier on the metal surface. And it is also known as thin organic coating TOC. So this is the alternate of Chrome 6. Now my main focus will be trichrome based passivation and chrome-free passivation. And I will also discuss different variety of trichrome. Some are innovative, some are regular. The first substrate we use for acid zinc plated job and alkaline zinc plated job for doing passivation work. Test method, coating measurement is done by XRF following the ASTM D572 that will give chromium mg per meter square per side. We call it chromium coating thickness. Then for morphology study, same EDX for coating, elemental analysis of coating, and then salt spray. It is process is followed by ASTM B117 standard. Performance target is arbitrarily kept as greater than 120 hours, and the process flow is normal: cleaning, zinc plating, passivation, dyeing, and salt spray test. All experiment has been conducted in the laboratory of GTZ. Then how trivalent chromium has been developed chronologically with the 5 generation. First generation is consisting of hexavalent chromium hydrogen peroxide, but it was not totally chromium 6 free because hydrogen peroxide can oxidize and reduce hexavalent chromium. In alkali medium it can oxidize, but in acid medium it can reduce. So it is salt per hour is also less than 24 hours. Then comes to second generation, that is again oxidizing agent plus chromium 6. Oxidizing agent used was vanadate and cerate. That is also not free of excellent chromium totally because both vanadium and cerate can oxidize chromium 3 partly to chromium 6. Then comes to third generation, chromium 3 and organic acid. It is really chromium 6 free and giving enhanced sulfur up to 96 hours. Generation 4, cobalt salt is added to generation 3 and salt spray and different color was obtained. But self-filling quantities of excellent chromium is not in presence in general 4 category. Then generation 5, nanoparticle and other additive has been used to impart self-filling quantity similar to hexavalent chromium. Chromium 6 is now more or less new to present chromium plating trichrome passivation system, that is cobalt free. I will be discussing cobalt free in detail. So why cobalt free is required? Substance of very high concern candidate that cobalt is considered as potential carcinogen and mutagenic on long exposure. Addition issue, cobalt has some interference with the bonding site of the post-passivation paint and coat. That's why cobalt is not suitable for paint addition purpose. If after passivation there is a painting issue, chromium 6 reversion risks. Literature shows that there is a chance of formation of chromium 3 on chromium 6 on chromium 3 plated item if it is exposure long time in UV exposure and high temperature baking application. And there is also regulatory issue. Chromium is also going to banned by different regulatory body. And when there is a chance of higher formation of chromium 6 reversal in chrom 3 passivation, if that when the chances of reduction in chrom 6 reversion, so if the immersion time is short, then there is less chances. If pH is lower and lower operating temperature and lower baking temperature, this parameter will give lower chances to formation of chromium 6 in chrom 3 passivation layer. And what will enhance the reversions of chrom 6 in passivation, chrom 3 passivation layer? If excess addition of nitrate that can promote formation of hexavalent chromium and complexing agent type, basic acid can enhance the formation of chrom 6, but formic acid, monobasic acid like formic acid, acetic acid has less chances to formation of chrom 6 in chrom 3 coating. So we have done some experiment to check whether it is really formed chromium 6 in chrom 3 coating. What we have done, immediately we have done, we have testing, we have done immediately after coating, they tested by chromium 6 by pot test like diphenyl carbazide test. It will give the, it can detect chromium up to more than 2 ppm, long exposure to UV light. There is no presence of chromium 6 in the coating or all last type, low cobalt containing passivation, high cobalt containing passivation and cobalt free passivation. Heat treatment, both at heat treatment at 200 degree and both at 1 hour and 4 hours, there is no presence of hexavalent chromium, and higher temperature, application temperature up to 60 degree, there is no presence of chromium found. Maybe conversion of chromium is very little amount. It needs instrumental analysis, XPS or XCA, to detect chromium if it's formed at all. Now that is cobalt free matches with cobalt rich after heat treatment. This type 2 is cobalt rich passivation. For blue passivation, it is giving 216 sols per hour. After heat treatment, it is giving the similar result. Type 4, it is just simply remove chromium from comb based or comb rich passivation, no extra addition to compensate the cobalt. In normal, sulfur is coming with comb rich passivation, but after heat treatment, the sulfur drastically reduced to 72 hours. And for comb 6, it is cobalt free, but some additive is added to compensate the role of cobalt, and salt spray after heat treatment has improved a lot from 72 to 144 hours. Similarly, the similar trend is followed in yellow passivation or iridescent passivation without type 2, that is removing cobalt from cobalt enriched passivation, giving salt spray hour at normal temperature, it is 216, but after heat treatment, it is drastically reduced to 48 hours only. But when type 6, when some compensatory additive is used, the salt spray has increased from 48 to 144 hours. So it can be concluded that cobalt-free passivation can be equal to cobalt-enriched passivation with some additive, and heat treatment also more or less gives similar result, similar to cobalt-enriched passivation. Now, thickness, mainly the coating weight is the factor which governs corrosion, not the type of color or cobalt paint. So I will be discussing on regular cobalt-enriched passivation. Type 1, type 3 and type 5, each experiment is done on acid zinc plated item. In blue passivation, all are coming, the passivation layer is coming at nanometer range, that is 7 to 8. And salt spray and thickness is more or less, salt spray for acid plated zinc is little less. For type 1 is cobalt enriched, type 3 is also cobalt free, type 5 is cobalt free with compensatory additive. Similarly, for alkaline zinc passivation, type 2, that is cobalt enriched passivation, and type 4 cobalt free, simply cobalt is removed from the cobalt enriched passivation, and type 6 is additive, cobalt free and compensatory additive added. So for blue, the coating thickness is around 7 to 8 nanometer, and for yellow it is 24 to 25 nanometer, and salt spray is at without heat treatment, salt spray is matching with cobalt enriched passivation. So this is the same and EDX study to know the morphology of 3 type of coating, 3 type of cobalt enriched, cobalt free and cobalt free with compensatory additive. Morphology is more or less similar, there is no such changes. And elemental analysis by EDX showing that chromium percentage is more or less equal, as in around 0.3%. This indicates that coating thickness and other parameters of the passivation layer is closely resembling for 3 types: cobalt rich, cobalt free and cobalt free plus additive. Similar experiment is done on yellow iridescent passivation, that is type 2 is cobalt enriched yellow, type 4 is cobalt free yellow without any additives, type 6 is cobalt free with additives. Here the chromium is also layer thickness is similar because chromium content in the passivation layer is 0.6 to 0.7 range, and SSD is also similar, 216, and thickness is also 24 to 25. So it can be said that cobalt free can be equal or equivalent with cobalt-rich passivation in terms of performance and appearance. So this is the one of the innovative concept. One bath, two purposes means passivation and top coating in a single operating bath. What will be the benefit? In single conventional process, it is 7-stage process, and for this mixed passivation composite, it is 5-stage process. And benefit is the ranging water consumption. It will be around 30% savings of ranging water. So this is the benefit. Reduce process sequence complexity, lower chromium leaching. If it passivation layer is boiled in hot water, then for conventional passivation process, there will be leaching of chromium in boiled water, and after leaching test, if salt spray is done, there will be reduction of salt spray. But for this composite passivation, there will be no leaching of color, low leaching of chromium in the boiled water solution, and there will be no salt spray reduction after boiling test. So this is the result for tie blend passivation conventional method, acid zinc alkalizing. Blue is giving 96 and alkalizing is 168 salt per hour. For mixed composite, it is giving 168 for acid zinc. So increase of salt spray is from 96 to 168. Similarly, in alkaline zinc, it is 168 to 288. Same logic is applicable to irradiation passivation. I am not going to details of this because time is limited. But if I summarize the result, for alkaline zinc blue passivation, there is a salt spray increase of about 71%. I am trying to correlate with this chromium content of the passivation layer. That increase is around uh, 81%. So it is closely matching. So salt spray is proportional to the chromium coating weight. For irradiation alkaline, the salt spray increase is 18%, but chromium coating weight increase is about 59%. It is not so matching. But it can be concluded that mixed composite delivers superior resistivity and higher coating weight, indicating better coverage and film integrity. Here I can mention one thing, that higher coating weights will not give that higher consumption data, because as this process is, there is no range, and that which chromium is coming from the no range process, because most of the chromium is washed away during ranging process. So that we can take the benefit of that in mixed composite passivation. Now this is another innovative idea too. Pigment in the dye bath. Generally passivation dye is used for decorative purpose. Blue and yellow dye is used in dye blend passivation to get intense color. But dye is water soluble, so if you heat it to boiling water, the addition is not that much. It will remove the dye. And but pigment is water insoluble. If you add in the passivation bath, it will give some passivation coating, which is totally insoluble in boiling water. So the experimental result is like this: blue dye giving salt spray hour of 148 hours. Color, if it is the coated item is boiled in water, the color comes in solution, and salt spray after boiling, it is reduced to 96 from 144 hours. But for blue pigment passivation, the salt spray hour is 168, and there is no color observation in boiling water test. And salt spray after boiling water test is also same. There is no change of salt spray hour. It was 68 to 68. Same logic is applicable to yellow pigment. There is no color for yellow pigment in the solution, as well as no change in salt spray hour after boiling water test. So pigmented passivation will be beneficial for dye-based passivation on stability ground as well as color detention ground. Now the zero comb free, I will be discussing about comb free passivation. So zero comb means no regulatory risks. Why COM-free is required? Because it is the ultimate goal. REACH aims to eliminate all chromium from form due to ongoing health and environmental concern. Health issue will be beneficial. Chromium 6, there is no risk of reversion of chromium 6 as the coating is totally free of chrom. So, if you consider the safety symbol for equivalent chromium, all 6 safety symbol are applicable. For trivalent, it is 2 and COM-free is also 2. So, this is the basis of COM-free, zirconium, titanium and molybdenum. And advantage, I have already discussed, all regulatory compliance is COM-free. So, this is our laboratory result. For COM-free blue, it is 48 hours salt spray, and for COM-free yellow, 72 hours. Our target is 120. It is basically on the based on inorganic chemistry. If we apply top coat or we can composite coat, then salt spray can be achieved to 120 hours. So this is the total chromium cobalt-free trivalent is already in operation in plant level. Mixed chrom is not operated. It will be launching soon, and this is the benefits. Yes. And this is the summary from the presentation. Cobalt-free trichrom is in regular use in plant level. Mixed composite will be launching soon. Pigmented and lens commodity, and COM-free we have to work in some aspect. So thank you.
Hello. Now I welcome Karthik Jain. He will talk on electrical vehicles and hydrogen generations. This is time is green hydrogen generation through plating processes.
Mr. Karthik Jain has earned master degree in electrochemical chemistry from a Oregon Center of Electrochemistry, University of Oregon, USA, where he has researched materials for different batteries technology, electrolytes for water electrolysis and electroplating. Karthik gained industry's experience while working as a scientist at D. Nora in United States. Please welcome Mr. Karthik Jain.
Through electroplating processes, we are relieving hydrogen into the atmosphere. So this lecture will deliver you how hydrogen will collect from the electroplating processes and can convert to electrical vehicles.
Hi everyone. So I'm representing Precious Electrochem. We are a manufacturer of electroplating salts, additives, and brighteners for over 3 decades now. And the focus of my presentation today is mostly on surface finishing requirements for electric vehicles and how we as electroplaters have a very crucial role to play in that. For that, I'll focus on a special and a unique technology for dye-free acid coppers that we provide to the industry. Secondly, in the second segment, I'll talk about corrosion resistance for green hydrogen components. In that, I'll focus majorly on, again, a unique product to us, that is an electroless nickel chrome technology, a simultaneous deposition of nickel and chrome and phosphorus as an alloy in the same bath. So a brief introduction about us. We've been in this industry for more than 3 decades now. We have around 35 distributors in India and we export to around 20 countries. I'll briefly talk about what all products we make and the infrastructure that we have. So for products, we start from surface degreasers that are pretty regular for this industry. We have additives and brighteners for almost all electroplating applications. We have passivations, some of which are highly unique and offer high corrosion resistance, high white rust, and red rust capabilities. Top coats, electrophoretic crackers, metal strippers, solutions for plating on plastics. Again, we offer a unique product to the industry that is a nanotechnology based palladium activator that offers more than 15% savings for our customers in activation costs for plastics. Recently, we've shifted our focus towards energy transition technologies in that we are looking at oxidation resistant coatings for titanium and majorly for PEM electrolysis as well as for alkaline electrolysis in the equipments. And I'm also doing a side project on developing very unique batteries for the industry. So a brief introduction about me. I earned a master's degree in electrochemistry and electrochemical technologies from the University of Oregon in the USA, where I focus majorly on battery technologies, electrocatalysts for water electrolysis, and a bit on electrodeposition. The outline of the presentation is such that I'll focus initially on surface finishing requirements for EVs. So there are 4 major purposes that are solved that are used for electric vehicles. Now, the first and foremost is the battery functionality. When I talk about battery functionality, I mean that these coatings have a strong influence on the electrochemical reactions that take place inside a battery. So if we talk about lithium-ion batteries, then there's immense requirements for current collectors that are made of copper and aluminum foils. Anti-tarnish for these copper foils is extremely important in that we offer a proprietary product called CU100. It's the need and the demand for corrosion protection is going to increase in EVs as well. These are typically regular products like fasteners and brackets that utilize high SST chromate passivations on zinc as well as zinc alloy compositions. We offer a very unique single part trivalent alkaline zinc passivation in trivalent state that offers more than 192 hours white rust and can increase with a top coat and over 240 hours of red rust. That is an OEM approved product and we are marketing it very rapidly in the industry. Our trivalent iridescent passivation is again a very regular product and a very advanced product that offers a very unique shade to trivalent iridescent coatings. Then we have alkaline zinc nickel platings that offer very high gloss, a very uniform alloy composition of nickel between 12 to 15% all throughout from HCD to MCD to LCD. For shock absorber rods, we offer hard chrome plating solutions. Uniqueness comes from the fact that we are able to deposit at 80 to 100 amps per decimeter square that allows more than 50 microns of deposit in just 1 hour. We recently set up more than 20 2,000 liter, 4 tanks of 22,000 liters each in the Middle East, and we are able to meet all the requirements of our customers. Next, with the rise of EVs, of course, there's going to be a rise in need for coatings that offer high electrical conductivity. So these are primarily plated with copper, tin, silver to maintain the current flow. Now, here we have a unique product as an electrolytic anti-tarnish that is chrome-free and maintains the electrical conductivity and prevents oxidation of silver and copper. To start with, for the electrical conductivity part, we have cyanide-free alkaline copper plating solution. Then we offer a dye-free acid copper plating solution that offers very fast plating. I'll talk more about it in the later slide. We have cyanide-free silver plating chemicals for electricals. It's still in the nascent stage, and I'll talk briefly about it in the end of my presentation. Like I said, we offer a chrome-free conductive anti-tarnish for silver and gold, and regular gold plating chemistries. With the rise of EVs and globalization, we're moving towards more aesthetically pleasing interiors, logos, and rims, and all of that, all of those things in an EV. So we're proud to announce a very economical and a very advanced nanotechnology-based palladium activator that has the capability to offer more than 15% savings to our customers in activation costs. Now, the advantage comes from the fact that we use ultra fine particles, nanoparticles in the solution, and it offers a very thin film that is enough for further electroless nickel coatings, thereby offering major cost reductions. We have the ability to run at only 12 ppm in the bath, whereas other companies recommend 20 to 25 ppm in the bath. So that results in higher drag out losses, whereas in our case, the drag out losses will be minimized, and the rejections are also very minimum. Moving on, we have a typical dye-based acid copper system, a semi-bright system that offers more than 50% cost reductions because of the consumption being very low, and a very uniform potential difference of around 150 millivolts. Now, majorly focusing on acid copper in this segment, I'd like to talk about the unique technology for dye-free acid coppers that we provide to the world. For acid copper, the basics are that it acts as an undercoat, excellent undercoat on various decorative articles, plating on plastics, sanitary ware. And recently, our attention has, we're focusing more on printed circuit boards and acid copper chemistries for printed circuit boards. It enhances the nickel specularity for sanitary ware and all of that. And the bath typically consists of 30 to 50 milliliters per liter of sulfuric acid, copper metal as 50 to 60 grams per liter, and chloride ions. Now, chloride ions in an acid copper bath play a very crucial role, that they play around with suppressors that are high molecular compounds, and levelers and brighteners in order to offer the most supreme finish. Now, levelers play a very important role in any acid copper bath, and these are basically they hold positive charges and are attracted towards the cathode and deposit preferentially on protrusions and edges, thereby reducing the copper deposit at these points and ensuring a very uniform deposit. Now, the challenges that we face with dye-based systems, pitting is one of the most talked about challenge in any acid copper plating bath. It is basically tiny molecular dot formation that is primarily because of breakdown of dyes. It's aesthetically unpleasing and offers a high rejection rate. Now, regular carbon treatments are required in any acid copper plating, because in order to remove these unprocessed or breakdown parts or side products of the dye components, there's sludge formation on the anodes that needs to be regularly cleaned. And dye-based baths typically have a very limited current holding capacity, and they're typically run at only 30 to 35 amps per square feet. There are concerns for ETP with carbon-packed sludge needs to be thrown away and needs to be treated in ETP, which causes challenges. And it's also difficult to balance the chemistry in case part A, part B, or the makeup is added in excess quantities by mistake. Now, what exactly is the dye? Dye is basically a quaternary structure that consists of two parts. One is the active key ingredient that gets consumed in offering high leveling, whereas there's a side product that has no role to play in electroplating and remains floating in the bath and is the major concern, major cause of pitting. So our approach, we decided to think out of the box, and our major goal was to eliminate using the dyes and the quaternary amines. So in order to completely eliminate the use of these ammonium dyes, we took an approach to incorporate organic molecules that could act as fillers. And these organics also allow for very high brightness and a very light pinkish deposit. We market the product in the name of Cuprashine 2060 that comes in 4 parts. The makeup being the most essential part, and a micro leveler that offers leveling in grooves and offers a very uniform mirror-like finish, LCD for improving the throwing power and the covering power, and a very special wetting agent that acts as a booster, for greater bath control. To talk about the success that we've got with this product, we've majorly marketed this product for industries like electroforming and earthing rods, where there's a heavy micron deposition. So we've successfully reduced the production time by more than half. We can work on current densities at more than 100 amps per square feet. That offers very fast plating, and for a real life example, one of our customers was plating for at least 24 hours to get an electroform piece, whereas using our chemistry, they were able to bring down the time to only 8 hours. It offers a very uniform and high thickness at LCD, and majorly with the elimination of dyes, we were able to have a very clean environment for our acid copper baths. Next up, plating on plastics. Again, like I mentioned several times, that pitting is one of the most important factors for plating on plastics, and we were completely able to eliminate any pitting that could come from the brighteners in an acid copper plating tank. Next up, focusing on printed circuit boards, we were able to market this product for printed circuit boards, and we've been exporting this product for this application. The presence of sulfonates and polyethers and levelers allow great micro wire filling potential. There are non-dye-based levelers that include primary, secondary, and tertiary amines. And these again carry positive charges, absorb preferentially to the protrusions and edges, and overall offer a very smooth coating for printed circuit boards, which is essentially very important. Moving on to segment 2, where I'll talk about electrolyzer components and how we as electroplaters have a key role to play in that. For PEM electrolysis, that is for proton exchange membrane electrolysis, that uses pure DM water. When there's an oxidation potential applied to the anode, the titanium tends to oxidize and become non-conductive. Now, the titanium only acts as a current collector and has a very thin film of iridium oxide. So it's very important to make sure that we utilize the iridium, and the failure is not caused by the titanium layer, but by it's essentially we can consume all of the iridium that we have on the anode side. So we offer a technology that offers a very nanometer scale porous coatings for titanium that is based on platinum. So we offer platinum plating solutions for titanium. Like I mentioned, for PEM electrolysis, now moving on to alkaline water electrolysis, which primarily runs on 6 molar KOH, highly corrosive. So it's very important to design solutions that can protect steel, mild steel from corroding. So we offer electroless plating solutions, nickel sulfamate baths, and a very unique product in that we offer an industry first and the world's only electroless nickel chrome solution. Now, the advantages of this product is that there's a simultaneous deposition of nickel, chromium, and phosphorus as an alloy. The chrome, the most important factor, chrome is present in trivalent state, so it's fully RoHS compliant. It does not contain any heavy metal like lead or cadmium. And for the same thickness, we were able to achieve a salt spray life of more than 1.4 times as compared to the same thickness of a traditional ENP process. The hardness of this plating as it is comes around 800 to 850 Vickers, which can further be increased to around 950 Vickers by proper heat treatment. Now, talking about intricated articles and application of this kind of a product. So, for intricated articles, one of our customers had a hollow tube that he wanted to plate with chrome, and utilizing an auxiliary anode in that case was nearly impossible. So, we suggested transition to an electroless process where we were also able to get chrome inside as an alloy with nickel. Problems with chrome tank, I mean, I'm sure all of us are familiar with hexavalent chromium and how hazardous it can be. And it's probably not the best way to electroplate on human health. I mean, it has several issues with human health, and we're moving towards greener technologies. So electroless nickel chrome can potentially be a strong replacement to any hexavalent chrome containing coating. That's majorly all about the major topics that I had to share, and a little sneak peek into our development for cyanide-free silver brighteners. You know, we are actively researching cyanide-free silver brighteners, complexing agents that are very advanced and offer bath longevity and uniform deposition throughout. Of course, getting a very bright deposit in cyanide-free processes is still a far-fetched goal, but we're working towards it, and we plan to market the product in the name of Cyanagon, which is relatable to the technology that we have to offer. So that's all. That's all I have to say today. And if you have any questions, feel free to drop by at our stall. Yeah, looking forward to any discussions. Wow,
Very good afternoon, ladies and gentlemen. I have the rare privilege of introducing a very eminent scientist in our field of surface finishing, Dr. Anand Kumar Sharma, whom I personally know since more than 25 years. He has an illustrious career uh, in research, in working on government panels, in working with industry, in working with global associations. I'll just read a few of them to give you an idea of our next speaker. At the moment, he is an advisor to the Defense Research Development Organization and the chairpersons for the screening committee for projects and for people, and for the assessment board at DRDO. He contributes a monthly report from India to the German magazine of Galvanotechnik. This German magazine was founded in 1903, and I'm very proud that Dr. Sharma fills in every month between 10 and 15 pages, highlighting new technologies, highlighting what is happening in India. And he's a consultant in the field of surface engineering. And now in this ecosystem of startups for drones, for aerospace applications, he is an advisor to startup companies, trying to guide them what they should be careful about, where they should focus on, such things. He held this highest position in the scientific hierarchy in the organization of Indian Space Research Organization, and many of his research work have found application in the satellites, in the launching pads of our space programs, whether it was Chandrayaan or whether it is anything else, especially related to for developing coatings which can survive the high temperature barriers when these equipments or rockets come back from space. I mean, it's a remarkable field in which he has contributed very significantly. He is a member of the advisory committee of the World Association of Nuclear Operators. And now that we are going in for smaller and smaller nuclear operators, his role will become very more significant because we are looking for power generation now with smaller reactors, and it's a project which is being seriously considered by many countries across the world. Although some countries are allergic to nuclear power generation. Um, he did his PhD from Delhi University in Chemical Sciences in 1984, 2 years before me, I would say. And he has many students, a very big group of students who did their PhDs and masters under him and who occupy various positions in industry and in the research areas in India. He has got many awards and recognitions, and I will stop at that here and request Dr. Sharma to take over. Dr. Sharma requests that he will be giving the lecture from where he is sitting due to some constraints. Kindly pay attention to the lecture, and we look forward to Dr. Sharma's presentation.
Hello. So now it will start with Rohit Narayan Srivastava. Now he will be speaking on surface finishing opportunities and sustainability solutions for the EVs. Now the short biodata of Rohit Narayan Srivastava. He is Business Development Manager, Sustainable Energy Field at Autotech. He is having 13 years experience in clear energy sector. He has done postgraduate diploma in international business from Indian Institute of Foreign Trades.
So, good afternoon, and I believe everyone has joined the session after lunch. So maybe I'll keep it more interesting. Okay. I'll be talking about surface finishing opportunities and sustainable solutions for electric vehicles. But before then, that I want to start with a short introduction of mine. So I come from a background of solar energy. So I come from clean energy segment and supporting MKS Atotech in it means driving into the clean energy sector basically. So I start with a short story. Okay. So in 2011, when I joined clean energy, it means like solar energy, hardly India was manufacturing anything on solar. Okay. There was nothing here. So, and today, India has a total ecosystem of manufacturing solar panels, I say, is of around 30-35 gigawatt. And in last 2 years, India has added around maybe 6 gigawatt of cell manufacturing from scratch. So what actually driven it to that is the complete ecosystem that is built around it. And I believe surface finishing is one of that. Okay, that is one part of it. And we generally talk, when we talk about the clean energy, whether it is in terms of hydrogen, it is in terms of electric vehicles, or whether it is solar. So one thing that is always talked about is cost and sustainability and the technology. So technology has came to India, so the manufacturing is happening. In 2011, the cost of a solar panel used to be 80 rupees per watt. Okay, and today it is how much? It is around 15 to 20 rupees per watt, not more than that. What has driven the cost down? It is the complete ecosystem that has been built around and the economies of scale through which the industry is going through. So I'll not take much time on what is my background, but I wanted to give a short story that yes, if we talk about EVs and if we talk about hydrogen in general, okay, yes, the cost, the technology will definitely come down to India. Maybe it may take few years, but it will grow exponentially. So we have the hope there, and this is where it means like even MKS Atotech is working towards. So we go ahead. So MKS Atotech, being a global technology leader, has 3 divisions: vacuum solution division, photonics, and material solution division. In vacuum solution division, I'll just give you a one-liner. There, they are manufacturers of subsystems for semiconductor manufacturing. In photonic solution division, the defense lenses, lasers, photonic solutions they manufacture. And I'll be more talking about material solution division, that is MKS Atotech. Okay, and what are their solutions in electric vehicle segment? Yep. So little bit older numbers, but still relevant. Okay, so I just wanted to show this slide to put some relevance on, like, we invest too much on our R&D and investments. You can see like 271 millions with 1900 engineers and 3200 patents worldwide. Yeah. We go ahead. Which are the industries we are serving? It is automotive, a smartphone, heavy machinery, construction, everywhere the surface finishing is very important, right? And that is where we are serving, and we'll be talking more about the energy segments. So directly jumping to the topic. So in EV battery modules, what do we offer? So in what battery module, you can see a battery module here, right? And we have solutions for cell management, battery cells, housing, battery junction boxes, fasteners, and battery management system. So everywhere we have some solutions which add up to their reliability and efficiencies. Now we start with battery housing. Okay. So battery housings, when we talk about, in general, the battery housings today, what we see in the market are of either steel or of aluminum, right? Steel and aluminum are there, but there are some problems that are with these components if they are not surface finished, or you can say coated. So there are different type of abuses that these components go through. It is like external abuses like electrical, thermal, or mechanical abuses. Maybe it can be penetration, crash, vibration. It goes through many terrains basically. And if we talk about internal abuses, it is like internal short circuiting is there. There may be some hydrofluoric acid that is manufactured inside the cell, and the cell soiling is happening because of corrosion. So these problems are there. So we have few solutions to that. We add up some solutions there. So on the steel side, if we talk about, we have some pretreatment solutions, cleaning solutions, and zinc nickel plating, which provides better corrosion resistance and provides a better adhesion to the subsequent layers like E-coat, or it may be powder coating, or it may be a PVC coating, basically. So basically, the battery packs, basically, they require, what do it requires, basically? It requires abrasion resistance, it requires corrosion resistance, a bit better dielectric strength, resistance to the dielectric it requires, and a thermal conductivity. So all the layers add to these properties. On the aluminum side, we have better pretreatment solutions, better pretreatment solutions, cleaning solutions, which again provides a better adhesion and other properties for subsequent layers, which I talked about. Yeah. If we go and talk about bus bars, when we talk about bus bar, there are few facts. Bus bars are generally made up of silver, copper, or aluminum. They are flat in nature because surface to volume ratio has to be higher so that the thermal dissipation should be much. Okay, so that heating should be lesser in normal language, right? And even they are laminated for lesser of the inductive properties. And always there is a skin effect through which the current flows, right? So skin effect is something like the current flows through the periphery of the surface itself. It doesn't go inside the conductor. Now, these are the facts about the bus bars. Now, exactly what does a bus bar requires on the surface functionality? It requires thermal conductivity and electrical conductivity. Definitely the contact resistance. It requires corrosion resistance and wear resistance, basically, because vehicles go through a lot of vibrations. Yeah. We have few solutions for that. We have few pretreatment solutions, bright and matte tin solutions. We have copper solutions for this. We have some solutions on nickel phosphorus, silver, gold, and some surface protection solutions. We have that is post-treatment solutions. Coming to the battery cells, on the cell side, there are a few of the components we have listed on the cell side is like connectors, bus bars, PCBs, anode lead types, cathode current collector, and anode current collector. We have talked about the bus bars. Let us come to the anode lead tab. The anode lead tab is something which is which will be conducting the electricity, as well as it requires some corrosion inhibition. So for that, we have some electroless nickel and tin plating there. When you talk about the cathode and anode current collectors, these are generally made of aluminum or copper, right? And there is a lot of active material like lithium and graphite goes on that. It is very much important that the addition between these active material and the electrode should be very much better, right? Unless if it is not, there will be a problem of corrosion, there will be battery swelling, there will be some hydrofluoric acid formation will be there between these two layers. So we have aluminum treatment solutions and coating solutions, copper tarnishing solutions. We have solutions where we can add our additives into the electrode deposition method of manufacturing the copper foils, basically, so that with the thinner foils, you can go ahead with higher strengths. Yeah. Now, cooling channels. When I talk about the cooling channels are actually very narrow. It is a channel which is like in some millimeters narrow width, and there is water-based or glycol-based solutions are filled in that so that it can absorb the heat that is going into the batteries, right? And these are very much corrosive in nature. When it is corrosive in nature, the corrosion may create some clogging inside, right, which can be a problem. And it can cause some leaks, which can lead to heating of the battery and then later to the failure of the batteries. So we have some mid phosphorus or high phosphorus nickel solutions, which provides good corrosion protection, uniform thickness, full coverage, basically, yeah. So these are a few of the processes that we have like the family of Nike MHP, soak cleaners, electro cleaners we have copper edge like Uniclean 697 that we offer in the market. Yeah. So I have covered very quickly the EV part. Now coming just for one slide, the introduction part on green hydrogen, right? So on the green hydrogen supply chain, the surface finishing solution is very much required on the complete generation, the storage and transport and uses part. Okay, if you talk about the generation is happening, through electrolyzers. And there are two types of technologies which are very much famous. One is your alkaline as a technology, AEL, and another is proton technology, that is PEM. It's clear. And AEL and PEM, in both of them, there are two types of surface finishes that are very much required to add. The first one is corrosion resistance, and second is basically the higher catalytic activity, right? So we are providing some surface finishing solutions which can have a better performance against corrosion, right? Basically in AEL, it is 6 molar KOH against that. And on the PM side, it is basically platinum and other solutions. So we have surface finishing solutions for that. On the storage side, it is the tanks and pipes through which hydrogen is flowing, through which alkaline solutions are flowing. So a lot of hydrogen embitterment and corrosion issues can happen. So it requires definitely coating there. So we have some solutions there. On the use size, definitely fuel cells for that we have coated. Yeah. So that's it very quickly. I've covered everything, not going in the depth of the matter. Yeah. Thank you.
Thank you, Rohit Narayan Srivastava. Actually, he has covered in a nutshell everything, because otherwise this topic is quite vast. So that way we must thank him. Now it is open for any discussion. If any one or two questions are there, people can ask.
Speak about the speak so that they're
Yeah, next will be. The next speaker, the next speaker is Nabarun Mehta, again from Autotech India. He will be speaking on alternative to hexavalent hard chromium plating and low temperature electroless nickel processes. His topic is also really of good technical interest. Now his short biodata. He is from MKS Autotech. He is having 15 years expertise in the surface finishing industry. He is BTech in chemical engineering and currently heading the wear resistance coatings product portfolio and technology advisor for the new energy fields. With that, you can now initiate your task.
Thank you. Thank you so much for the introduction, sir. So, as mentioned, I'm heading the wear resistant coatings for MKS Adotech. And I really would like to thank MFAI for giving us the opportunity to share a certain few new things that we have come up in the field of wear resistant coatings, which primarily includes functional chrome or hard chrome as we commonly know it, and electroless nickel. So, I mean, hard chrome is being done from 1920s, right? And it gained popularity more so during the World Wars. But the technology has not moved a lot. In 1980s, of course, we came up with the HEAF process, which drastically changed the whole game from being very less efficient to a little better efficiency. And there was not a lot of work that was being done for about good 30, 40 years. We've again done some work on it in recent past because we understand that it is quite dangerous to be using chromic acid. So we would like to minimize it and optimize the productivity as well, and also take it to the next level of being hexavalent free. And the other part of my topic is going to be electroless nickel, which is again the basic problem with the whole process is that it runs at very high temperatures, right? 85 to 90 degrees Celsius is anywhere which is common. And we've made an attempt to reduce this temperature to considerably lesser. I'll take you through more details as we proceed. Right, so I've already given you an overview of what we are going to be going through. Let's jump into the topic. So HEAF HMC. HEAF 25 is a name that is very prominent in the market for, say, the last 40 years or so. But there's a development that we have done in the form of HMC. HMC basically stands for high micro crack. Now, what happens typically is that as and when we keep increasing the current density, the crack count keeps dropping. Now, we need to increase the current density for sure to be able to have better productivity. But then we are actually compromising on the quality of the product being produced in terms of reducing the crack count and hence directly impacting its corrosion resistance. So you can see over here, as and when the current density keeps increasing, the drop becomes more and more drastic. So here in the HMC comes into play, which is basically a high micro crack version. What it does is that it is able to maintain the crack density at a certain level while we keep varying the current densities. Whereas any other process would drastically keep dropping from, you can see 30 to 70 amps per dm square. There's a huge drop. And this hampers our productivity. So we cannot keep plating at 30 amps per dm square, right? We need to go for higher current densities to be able to have good productivity coming out of the same line. So what this process actually allows you to do is with the existing setup, you can have a better, an increased productivity, say up till nothing less than 30 to 40%. Of course, certain changes need to be made in terms of the busbar capacity, the rectifier capacity and things like that, which are doable things even with the existing setup. This is to give you a schematic view of how different the crack density looks like at 60 amps per dm square and 90 amps per dm square. You can see with the improved version, it is able to maintain it at a higher level. Now, what it automatically does is it impacts the corrosion resistance of the parts. We have seen a drastic improvement in the number of rods being plated and the number of NSSRs that it can pass with at even operating at higher current densities as well. From property, deposit property and the efficiency point of view, it does show a little better efficiency because typical processes generally tend to drop a little after certain current densities. But then again, this is able to maintain that. And if not the same, maybe a little better than the other processes. And we're comparing HEAF 25 over here as a standard. In terms of hardness, we again get the same thing, which is generally desired, says somewhere between 950 to 1050 Vickers. And the tableware results are also almost in the same range, maybe a little better. From an appearance and adhesion point of view, chrome plating remains chrome plating, right? We are just changing the additive system. It's a twin additive system, so it really does not impact the adhesion or roughness in any manner. So, in a nutshell, what we can say is that the HEAF HMC is able to give you a higher crack count. It is production proven for sure. And because of the higher crack count, we are getting much better corrosion resistance with the existing process and also able to enhance the productivity of the entire line. So now moving on to a little more interesting topic of trivalent hard chrome. I'm very proud to be saying that Aerotech has been one of the first people who have been able to establish a workable solution of trivalent for hard chrome plating. And we have 40 odd installations of this globally already and working with a few OEMs in India to get this thing running in the country as well. From an appearance and other deposit parameters, we are able to achieve what the chrome, the typical hard chrome deposit expects us to do. And we can build up high thicknesses as well. There is complex job structures can be done with it. The hardness can be achieved, and the adhesion, of course, is promoted with certain underlays. So the major challenges that we have with this process, I would not say negatives, but challenges that we faced with the first generation of this process was that it has micro cracks. I was previously talking about micro cracks. This process has macro cracks. So to be able to give you good corrosion resistance, we had to introduce an underlayer of nickel. But then again, what this did was that it gives you much better corrosion life now, which was not the case with only hard chrome or hexavalent plated parts. Yes, in the bargain, what happened that the process sequence, which was typically much shorter in case of hexavalent chrome, it became longer. And it is now including a few more steps. So we are typically cleaning it with the degreasers and the anodic stuff. There's an etching step that we have additionally involved in it because, of course, chromic acid etching cannot be done, but we need to promote adhesion onto the surface. So there's a chromic acid free etching that has been implemented for this, followed by nickel plating, as I mentioned earlier, and then it can go directly into the trivalent hard chrome, which is the blue chrome. So it, as I mentioned, it fulfills all the requirements that hard chrome has currently from the market today. It's stable and offers a good long bath life, which was again a challenge at earlier times. It is now being able to give better corrosion resistance as compared to hex chrome plated parts. And of course, as I mentioned, in the bargain, we had to compromise on things and have a longer process sequence, so to say.
right? And as I began the talk with, we already have 40 plus of such installations across the world. And very happy to say that we have some of these parts running in the industry, in industrial conditions such as mining and automotive for the last 3 years. And we've had very good results with the same. Now, moving on to a little more interesting topic of reducing the temperature of electrolytic nickel. As I mentioned, 85 to 90 degrees is typically what we were looking at always, and most likely 90 hi hota tha, right? And so we've made an attempt to bring it down till 75 degrees. That's why the process name is known as NICAM MP75. Now let's have a look at the energy savings and the carbon footprint reduction that this process has to offer. One part of it was, of course, getting this thing done. So heat up cost itself in achieving that additional 15 degrees of Celsius, 15 degrees Celsius, we spent 20% more power. Similarly, when we have idle time, so if a plant is say not running for 24 hours and we leave it and then come back and start up again, the temperature drops still a certain level, and then we have to bring it up to that level again, right? So in that, we're observing almost 28% lesser, because the temperature drop throughout the night would be say around 40 to 45 degrees Celsius, right? We're not bringing it back to 2025. Last but not the least, the energy that is required to maintain the bath at 90 degrees Celsius. This is the bigger chunk. This accounts for almost 30% of additional power consumption. What these things automatically resonate into is an overall carbon footprint reduction. And you will be surprised to know that the total carbon footprint reduction that this process has to offer against traditional electrolytic nickel processes is close to 35%. So I think this is the way to go forward in the world, and there's a lot of talk about net zero and carbon footprint reduction, and this is our small attempt to take the world a step further. Right, but then of course there were challenges associated around it. We've all known that the alkaline electrolytic nickel process, which is typically done for say plating on aluminium or and any other plastic surfaces, they do not give you a very hard you cannot build up a lot of thickness with those coatings. So it does not solve any functional purposes. Now what we saw is that when we mix up only the nickel and the hypo part of it, at 50 to 60 degrees Celsius, it just starts plating on its own. So it's not going to typically choose a job and then plate over it. It's just going to plate everywhere. So after a certain point of time, you will have no nickel left. It's just plating over the tanks, the wall, tank walls, the heaters and stuff like that. Of course, when we started development, what we found is that the deposition rate was good, or somewhere satisfactory to where we wanted it to be. But then again, the phosphorus content was way too low. So we decided to make it the most commonly used one right now, the first stage, which is mid phosphorus. Mid phosphorus accounts for almost 65 to 70% of the entire electrolytic nickel being used across the globe. Some of the process features, it is key to understand that when we are talking about the deposition rate, it's already on a slower note, right? And we cannot compromise it further. So we did have to compromise a little bit. So at the beginning, we are getting a good 16 to 18 microns per hour. But after the third MTO, we see a little bit of a dip when it dips to around, say, 15 or so, 15 to 16. And by the sixth MTO, we are looking at somewhere around 13 to 14 microns per hour. With this, of course, what we are having to do is that adjust the temperature a little bit. Earlier, the range used to be 85 to 90 degrees or maybe 91 degrees Celsius. Now it is we are taking it from 75 to 76 to a maximum of 77 degrees Celsius. As I've already mentioned, phosphorus content is something that we were looking at to maintain it between 5 to 6. And this is what we have found that till 7 to 8 MTOs of bath life, it can consistently give you that 5 to 6 percentage of phosphorus. Some of the coating properties, it has to match with the existing mid phosphorus requirements, right?
I've already talked about the deposition rate. Yes, it is ROHS, WEEE, and ELV compliant. It gives you the same requirement of hardness. Of course, after heat treatment, it can be escalated to the same one. The stresses are maintained between compressed to neutral, and it gives you a good corrosion resistance as well, which is typically expected of 96 hours from mid-phosphorus coated part. Now, from the benefits perspective, if we see just in terms of an EN technology, yes, ROHS compliance was the first thing that we have done, say about 10 to 12 years back. The second part of it would be to reduce the temperature, which is again resulting into carbon footprint benefits as well as energy savings. And also what we are doing is using lesser water. Lesser water in the sense of evaporation losses, right? When we are operating at a lower temperature, obviously lesser water is getting evaporated. So that's how the lesser water comes into picture. And this is the same thing that comes as an economical benefit as well, wherein the energy is much lesser and as well the water consumption. Because DM water is not that cheap, huh? Let's be honest. Right. So a deposit parameter point of view, it gives you a consistent rate of phosphorus content as well as self-regulated and can be operated at low bath loadings as well. It is a little semi-bright. We're not typically looking at a very, very bright deposit from this process. But then again, that should be fine for functional coatings. Functionality is the thing. Aesthetics is not so much of a concern over here, right? With that, I come to an end of my presentation. Thank you. Any questions?
Yeah. Okay, I think there is no question because you have presented very well, and your work is actually very good industrial and practical importance. If you real sense you see for industry is requiring those kind of things. So really congratulations for doing this kind of work. The next speaker is Pinakin Patel, who will be speaking on anodizing innovation of electrolytic coloring. His short biodata, he is the president of Technotron LLC. By the qualification, he is the chemical engineer B and ME. He has done. He is head of Sandoz North America patents on interference coloring and nickel seal. Okay.
Yeah, jump right there.
Good afternoon, everybody. Thank you very much for coming to the presentation. I'll talk about some innovative technologies for electrolytically coloring aluminum. It's the most desirable method to color because of its durability. So the first thing is, why are you able to electrolytically color? Is because the anodic coating has a barrier layer. It's between the metal and the oxide. There's a small layer, and that layer is a capacitor. So when you apply an alternating current to a capacitor, it rectifies it. When it rectifies it, it charges it negatively. So any positive ions will deposit in the coating, and they cause light to scatter and produce different colors. Here's an example of, that's the metal, that's the oxide layer. So this layer in between, that's the barrier layer. So in this presentation, we'll talk about electrolytic color, interference coloring, and then combination coloring. When you apply an alternating current, you deposit metal in the coating. So light comes up, some of it reflects, some of it refracts, then reflects from the base, then again refracts. So now light is broken up. When you break it up, it produces color. A little bit of history. The technology for electrolytic color was developed by a Japanese scientist called Asada. In those days, the method of coloring for architectural used a special alloy and a special organic acid. Very difficult to control and all. So he developed a process that did not depend on alloys, and you could produce any color. One of the major aluminum company, Allcan, was not in the architectural business. They thought this would be a good opportunity. So they bought the rights and they developed it to a much higher level using different kinds of metals, nickel, copper, cobalt, tin. They didn't do tin. And in the process, for some reason, this industry doesn't like to pay royalty. So how do you make money in a business where you no longer pay royalty? They unfortunately forgot to patent tin. So a German company developed the tin electrolytic coloring process. And today, by far, 90% of the market in the world is controlled by the tin electrolytic coloring. Okay. The advantage of the tin process compared to the nickel and cobalt was it's a very acidic process. You use 20 grams per liter sulfuric. So you get a lot of throwing power. Unlike most plating processes, the throwing power is quite good. However, it's not as good as anodizing. Anodizing is done at 160 to 200 grams per liter. So when you do electrolytic color tin, you have to reduce your load size 30 or 40%. So that was kind of a disadvantage. Another disadvantage is you cannot use titanium tooling. It has to be all aluminum tooling. So to do the electrolytic color, we have to have a AC waveform, alternating current waveform. It's very important to have a perfect sine wave. A lot of companies in the Western world try to make cheaper power supplies by using SCRs. And when they did that, they produced a alternating current that was not symmetric and perfect, and they had all kinds of problems with that. So it's very important, if you're doing electrolytic color, it must be a perfect sine wave. Reason I bring that up is, this is how you make a perfect sine wave. If you do with SCRs, you don't get a perfect sine wave. You can do chopping and all, but this will not produce good consistent color. Here's another example of, so typically you use a primary circuit if you ever seen AC power units, you have auto transformer. The carbon brushes go up and down, and depending on what voltage you want, this produces a perfect sine wave. Here, they're using SCRs. SCR is like a gate. They open it selectively to get the voltage you want. But SCRs are inherently inefficient. So you get a distortion in the waveform because of that. So it's very important you use the perfect sine wave. Then, over the years, the biggest disadvantage of tin was not being able to color as much as you could anodize. So then there was new technology developed using special chemistry and using a direct current prior to the AC, and that made the throwing power dramatically better. So I'll show you some of that. So here's an example of how a waveform should be. Here's an example of a bad waveform. That's not good. It's AC, but it's not perfect. So this will give you bad results, it'll give you good results. There is a technology today, it's probably about a year old, year or 2 years old. It's a technology that's been used in pulse, but in anodizing, it's only about a year or 2 years old, where you're able to make the AC wave form perfect sine wave. Here you can see equal positive, equal negative. But with this technology, you can actually make a perfect sine wave and change the amplitude of the power supply. So in this case, you have more positive, less negative. If you're trying to do a champagne color, electrolytic color, you get that color in 10, 15 seconds. Very hard to control the color. With this technology, you can take 5 minutes to control. So all the lighter colors are much easier to control with this technology today. Here's an example of, if you're doing clear anodizing, you can extrude hollow profiles, you can put them all together, they'll all anodize. When you do electrolytic color, you have to break it down, you have to leave a gap. Typically, they leave a gap if this is, let's say, 2 inches. They have to leave 3 to 4 inches before they can put the next part. You can see with the newer technology, you can color exactly like this. And I'll show you some, here's an example of smaller profiles. And this is the range you get from bronze, which is the most popular color. Everybody pretty much uses electrolytic bronze. So we developed a hull cell to test throwing power and anodizing. A hull cell is very commonly used in the plating industry, but since anodizing is such a efficient process, or the coloring is also, we had to kind of come up with a modified process. So what we did is we took a tank that is 20 inches, 6 inches high, 6 inches wide. We anodize this piece that is 16 inches long and 2 inches wide. We anodize it so it's perfectly symmetric coating. And then we go into the coloring step with only a connection on this side. So what will happen is this will be darker. As you go further away, it should get lighter. So here is what a normal tin electrolyte would do. Somebody buying tin and stabilizer, you'll see it's dark there and gets lighter up here. To that, we add special chemistry, just chemistry change. And you can see we made it quite a bit better. However, we're still not very good here. Quite a bit better, but not as good as perfect. So then to this technology, we added the DC-AC step. And you can see much better from here to here, but still not very good. To our technology, we added DC-AC and it's perfectly uniform. So what this means in production, we did some delta E's to show that the variation is this far apart on the L value. And as you start doing DC-AC, you can bring it down to almost perfect. The delta L for a normal AC is 18.7. With the electrolytic color, with just the liquid addition, we brought it down from 18, the variation from that end to that end, down to 10. And then, of course, the full DC-AC brought down to 5.4. And most of the time, human eye cannot see more than 3 or 4 in a dark black color. 4, you will not see a variation of 4. You cannot perceive it with your eye. So with that said, the other important thing in electrolytic coloring is the connection from the power supply to the tank. Whenever you apply alternating current, you create a magnetic field. And I don't know how critical it is in the lower amp supply, but in America, we have customers that have 15,000 amp AC units. And if you do a bus bar connection, you will never get more than 8,000 amps from the unit. It creates a huge magnetic field. The catwalk will vibrate. So you have to connect with cable. Most people don't do that. Because the thinking is, bus bar, which is everybody does. But if you're doing electrolytic color, if you do cable connection, and the cable has to be equal length, positive and negative has to be the same length and intertwined. So you take cable from one terminal, the other terminal, you drive, same way you do that. So it's very important. So impedance, I'm talking about bus bar. And the further the power supply is from the tank, the larger the impedance. And then also the frequency. In America, we have 60 hertz. Here we have 50 hertz. So the higher frequency even aggravates the problem more. All these are very important when you start doing some of the interference that I'm talking about. Now we're talking about very, very tight control on color. So if you don't have if you have bus bars, you won't be able to do that technology very well. So what is the effect of impedance? You get uneven color, you get black colors take a long time, and the black color is not really deep. So here's what we did. I created the impedance effect. This would be a standard process, the same throwing power I showed you, and this is the one with impedance. You can see what a difference in the uniformity versus an impedance. You never even got a dark color. Whereas here, standard process got much better color. I didn't go dark on this just to show the variation. This is a best example. So we did a black part with a normal process, and in 10 minutes, we got such a good black color. With the other process, we did 10 minutes, then we kept on increasing the time. Even at 25 minutes, this color is not as dark as this. So that is the effect on impedance. What does this mean in production? If you're able to do DC-AC, most electrolytic coloring processes have a center cathode. You have to expose both sides. This is one of our customers that is doing, he does hinges for doors. And he's got, oops. So he's got these door hinges. If you look at the side profile, I've got 1, 2, 3, 4. I'm coloring 4 rows across, all uniform, which is not normally possible in electrolytic color. So that's the advantage of the right technology with the DC. This is another customer of mine that is doing sunroof tracks. So very big complex parts. He's racked them so that if you look at this part, there's one part here, there's one part on the back side of it. You can see the side here. There's one part on the front side and one part back side. No central electrodes in the color tank or anodizing tank. So in this case, his coating thickness up here is about 22 microns. And the back side of this is about 15 microns. That much coating variation, still the color is perfect. So that's the advantage. You can push with the DC process, you can push your capacity significantly. There are other methods to color. If you use copper, for instance, you get a range of burgundy to black colors. You can use silver to get these kind of colors. Now we'll talk about interference coloring. The most common method is using phosphoric acid to modify the pore and then depositing nickel in the coating to get different colors. So what you do is you anodize and you make a cone. Then the phosphoric acid makes a big pore. So when you do phosphoric, as everybody knows, anodizing is bottom up. You always anodize from bottom up. So when you do 30 minutes anodizing, minute 30 is on the bottom. So after you go into phosphoric acid, you make a big pore. You make a big pore. Then you deposit the metal in there. The distance between here to the top, that determines the color. So if it's 430 Armstrong, you get blue. Now you can see in a structure like this, there's only so much you can do. So you get some decent blue grays, green grays with this technology. But this can be taken further. This is the range of colors you get with that first technology I showed you. Now we'll show you this process. Here you anodize, you do the phosphoric acid, you deposit the metal, stabilize the metal, and then re-anodize. Now here, the distance between here and here determines the color you will get. Now you can get a whole palette of colors by this technology. You'll see that. That's the range of colors you get. That's the whole range of colors. It starts here and goes here. And then these colors on the far 5, they're dichroic. So if you look at it this way, it looks yellow. This way, it'll look green. And the reason you're able to do that is if the distance, if you look at a part like the distance in this direction is shorter than in that direction, the color looks different. So it's called dichroic colors you get with that. The problem with those processes is To do that, you need 4 or 5 tanks. So it's never really taken off. It's not common for an anodizer to put 5 tanks in a line. It's not practical, and it generally doesn't get done. But the technology is available. Right? So we are always trying to find more practical ways to get more colors. So here's some other methods I'll show you using interference coloring, but in a more practical way. With this, what I'm doing is, remember I showed you the waveform, you get a perfect sine wave. If I offset the waveform, so if I have one more negative volt than the positive, I get this range in a tin bath. I don't need a new bath. I need a special electrolyte. In that, you modify the coating, then you go straight to your bronze bath. So with only one extra tank, and that additive you can put in an aerosolizing tank and do it also in an aerosolizing tank. However, when you do that, you're occupying your aerosolizing tank, which is not doing other work. So typically, people will put one tank and do this process. By doing it, just having a 1 volt offset, I get this color. If I do a 2 volt offset, I get these colors. If I do a 3 volt offset, I get these colors. Now, there are 2 other technologies. I can actually modify the pore in the coloring bath also if I want to. But this requires a special color bath, obviously. And then the overdye. One of the challenges we have as anodizers for architecture is we cannot compete with the paint. The paint is offering 20 colors because they just have a spray. We cannot offer 20 colors. We have to put 20 tanks. So we always try to find ways to make more color from an existing setup, so this is one way to do that. There are some dyes that are very light fast, and you can combine them with, you do a bronze, and then you put a blue on top of that. That's the color by itself. This is the color after you put on top of that. This is the color after you change the bronze, you get this color. Same thing with the green. So there are technologies out there to broaden the range of colors and still offer a whole palette, if you may. So in summary, electrolytic coloring gives anodizer an excellent I've done a paper on this. There is no organic chemistry. They can talk about the best fluoropolymers for paints and all. They do not hold up like anodizing. 1. 2, the carbon footprint on anodizing is 20% that of any other high performance coating. The life expectancy of anodizing is 100 years. They're just redoing the library in Oxford University. The windows were 80 years old. They're still good. They're going to leave them on. The Sears Tower in America is 50 years old. You can look at the building, it's still the same today. There's no painted building today that goes beyond 20 years. So the anodizing has a phenomenal carbon footprint. Architects like it. It has a rich appearance. What architects don't like is we are not able to give them light colors because we are not very good at uniformity on that. We are not giving them very uniform colors generally, and we certainly don't give them a lot of colors. So those are the disadvantages. We're trying to see if we can leverage that to the anodizing advantage for the anodizing. Thank you. Very good. Any questions?
Yeah, thank you very much, Mr. Patel. It was very nice talk, really. Only one small thing I wanted to ask, actually. One small thing I wanted to ask. If you compare it, means all color may not be possible, and sometimes the color consistency is actually is the problem with the electrolytic coloring.
Sure.
So if you compare with inorganic coloring, say some selective color only, because there you cannot get all kind of shape.
Right.
States that I agree.
Right.
If you compare these two, say your gray color or black color, what difference you find in these two? Simple tipping.
Sure. So the lighter colors, you go through the spectrum so quickly that your window is very small to catch the color. And so people are not able to do that very easily. In fact, the champagne, you have to go 10 or 12 volts. The other disadvantage is it's an acidic bath. So when you come out, you check it and all the acid will also take away the color. So there are some of these little complexities that make it more difficult to do that. but you can do that now with the newer technology. Yes.
So please.
Hello. Now we are felicitating Dr. Anand Sharma. Now we break for a tea break for 10 minutes.
Over the course of his destinations career, he has been associated with some of the most prominent organizations in the field. His professional journey has been shaped by engagement with the global and the Indian organizations, Groverwell, Autotech, Magin and Ronak Industries, having represented them in the various techno-commercial profiles, strategies, planning, leaderships, etc. Across this platform, he has worked at the intersections of the chemistry, engineering, and the marketing. Please welcome Mr. Kaushal Kinaraji. Yeah.
Good evening, everyone. I would like to invite the first speaker today, Mr. Tori Yangshika from Dipsol Chemical, Japan. He has worked in Dipsol for 23 years and is the Chief Engineer Technology for R&D Division. He is developing brighteners of zinc passivations, and today's presentation is on silver color passivations for zinc and nickel alloys. Welcome to start yourself.
Hello, everyone. My name is Tor Yoshinaga from Dipsol. Thank you all for being here. Today, I would like to present a silver colored trivalent chrome passivation for the nickel that does not require any top coat treatment. The nickel plating has been attention in recent times. Why? Due to environmental requirement and the need for high corrosion resistance for surface treatment on automotive parts. Zinc plating has limited performance for high spec standards, but the nickel plating is able to achieve the high spec standards for automotive parts. In the past, the nickel plating mainly used low nickel alloy plating with 6 to 8% nickel together with hexavalent chromate. In the 2000s, hexavalent chromate was phased out and replaced with trivalent chrome passivation. In that time, there was issue what corrosion resistance decreased with low nickel alloy, thin nickel plating, and trivalent chrome passivation combination. Then we found out high nickel alloy thin nickel plating, such as 13 to 17%, is able to achieve corrosion resistance with trivalent chrome passivation. As a result, high nickel alloy thin nickel plating has been attention since then. Thin nickel plating has much better corrosion resistance than zinc plating and any other zinc alloy plating. Especially high nickel alloy zinc nickel plating shows the best corrosion resistance. Next, we compare the corrosion performance of high nickel and low nickel plating without any post-treatment. Because there is no post-treatment, white rust appears early for both. But high nickel plating does not show red rust even after over 1,000 hours of third spray testing. The nickel plating is widely used for engine parts, so corrosion resistance under high temperature is important. Hexavalent chromate is not very resistant to heat and loses corrosion protection, while trivalent chrome participation provides excellent heat and corrosion resistance. In recent years, with the phase out of hexavalent chromate, trivalent chrome participation have become the standard. There has been a trend to use a premium-looking silver finish for automotive suspension components. Most of these achieve their silver color by applying a colored trivalent chrome participation followed by a top coat. The top coat offers the advantage of enhanced corrosion resistance, but it also comes with drawbacks such as uneven coating and higher costs. Our product IZ264S achieves a silver finish solely with a conversion coating without the need for top coat. These are the third spray test results for IZ264S. The trivalent chrome participation is thinner than existing product, so the corrosion resistance is a bit lower, but it is still sufficient. If more corrosion resistance is needed, a low concentration top coat can be used. We also have cobalt-free silver version. It has enough corrosion resistance, but the coating contains silica. When using a top coat on existing trivalent chrome participation, the top coat may not fully cover the surface, and the blue color underneath can sometimes be visible. For this reason, a high concentration top coat is needed. Cobalt-free trivalent chrome participation contains silica, so the finish appears a little darker. Here is a table of processing condition for different silver colored finishes. IG264S can give a silver color by itself, but if you want extra corrosion protection with a top coat, a low concentration top coat is enough. In addition to corrosion resistance, surface treatment can sometimes discolor in high temperature and high humidity conditions. When developing IZ264S, we tested it under constant temperature and humidity and took steps to make sure it can handle such environments. Finally, here are the main features of IZ264S. It offers high corrosion resistance as a zinc nickel alloy plating. You can get a silver finish without a top coat. And if you use a top coat for extra protection, a low concentration is enough. Plus, it won't discolor even in hot and humid environments. We believe IZ264S will help improve both performance and appearance in many applications, and it could be a game changer for existing zinc applications. Thank you for listening.
रोल अभी आ गया रोल आ गया तो पहले उसको बोला तो उसको सेल्फ इंट्रोडक्शन करने का बोल अरे होगा ना उसको बनाया होगा उसको लेके आओ वी शुड कम प्रिपेयर्ड
Good evening. To continue the session, we have Mr. Raghavendra. Oh, Mr.
ये नहीं
Raghavendra is Raghavendra Srivastava.
अरे वो ही बिंदु से प्रोसेस पता ही नहीं रहा
अरे नाम तो मैंने सही बोला Raghavendra
नाम सही
Srivastava.
बोला बोलिए
Yeah, Mr. Raghavendra Srivastava. Is he here now? Okay. Then you can start, proceed, and I don't have your write-up, so you can give your self-introduction.
Good afternoon, everybody, and I'm thankful towards you for keeping patience and listening to a lot of presentations. First, I will give my introduction. Myself, Raghavendra Srivastava. I'm working with Greer and Well India Limited. I'm actually working in research and development. I am looking after the phosphating portfolio. And previous to this, I have experience with Henkel, Nihon Parkerizing, Kansai Nerolac, Asian Paints. So total, I have a 23-year experience. So today, the topic which I am going to cover is basically zirconium nano-based coating. So as the world is changing and the demand is coming towards the sustainability, low sludge, reduce consumption, low cost. So nowadays where the paint is happening, like on cars, two-wheelers, household items, anywhere the paint is happening, we are currently using zinc phosphate and trications we are using. But this zirconium nano coating is a solution to zinc phosphate, and slowly, whole world is changing towards the nano zirconium coating. In Europe and America, world has already changed, but in India the process is slow. But slowly, the world is changing. So I will give you some introductory glimpse of this technology today in my presentation. So this is my topic. The zirconium coating is basically replacing the conventional zinc phosphate that is currently running with paint technology. So this is basically guiding principles to develop this technology, innovation, customer requirements, problem resolutions, and cost-effective solutions. So this is about the little introduction of the thin film conversion coating of zirconium. So you see here below the paint, there is a nanometer scale protected layers of zirconium coating, and it works at room temperature, and thickness is around 50 nanometer to 150 nanometers, so very less. And it also offers the excellent paint adhesions, and it's eco-friendly and negligible sludge, and it has no heavy metals. And basically, it's a inorganic ceramic-based zirconium interlock-based coating. And this interlock provides the adhesion and corrosion prevention to substrate through the life cycle of product. So here is also a little bit introduction, like two-wheeler, you see there is a substrate MS body, and over this, this coatings work as a barrier. You can see here from blue, this blue shade it is shown here, and above is E-coat. ED coat the two-wheeler industry is doing. And these are the basically, we have developed the two technology to make it cheaper and make it more efficient. So there are the Surfix Eco 105 technology, and this is 106 and 107. The basic differences between the base chemistries, it is only inorganic compound, and another chemistry has the interlock hybrid. That is organic functional group and inorganic functional group that make it more efficient and more good from the other chemistry. And film tech is basically metal oxide layer in Surfix Eco 105, but in 106 and Eco 107, there is a covalently bonded interlock film is formed and network is formed that prevents the corrosion and permits the oxygen to enter the substrate. And the thickness is around 20 to 100 nanometer, and here is only 5 to 50 nanometer in 106 and 107. The paint adhesion is good in 105, but it is very excellent and equivalent to zinc phosphate coating in 106 and 107. And application both works at room temperature. And this Eco 105 is basically developed for the items we are keeping inside the house, and there is no exposure to outside. So by keeping in mind, we have make it simple and cheaper and best. So this is basically an introduction how this zirconium layer is formed over the substrate. You can see here what we do, we actually made an equilibrium in bath. So basically pH we keep 3.5 to 5, and when we keep this pH, zirconium ions hydrolyze and it reacts with metal surfactant, and it makes a zirconium oxide thin layer that I clearly mentioned, 30 nanometer. And you can see here how the hydrolysis of zirconium complex is happening and how the conversion reaction is happening. You see this metal oxygen zirconium oxygen metal bond is formed and it creates a layer. You can see here, I have shown the substrate. The first figure is basically substrate. It is a SAM image magnification 1500. So you see there is no coating, but in zinc phosphate you will see these grain size crystals like this. But in Surfix Eco, you will not able to see the grain size crystals. So it is totally different from the zinc phosphate if we go on morphology. And this we have taken a 10,000 magnification, taken an image from SAM. So zinc phosphate looks like this, like a plating stones and plateaus are you can see here. And but in zirconium coating is a very thin layer, 30 nanometer, and it is a amorphous coating. So such kind of structure is not here, and very uniform and amorphous coating is formed in zirconium. And it is also easy to run this coating. If some operator is running the line, they can identify what kind of coating weight is coming and how the process is running just by looking over the coated substrate. But in case of zinc phosphate is very difficult. You have to measure the coating weight, and that process require around 30 minutes and 40 minutes to confirm the quality of process. But here in zirconium coating, it is easy to identify by color that how much coating weight you are running, and it makes it easy to operate. This is basically, we have shown the difference. What is the difference? The left hand side is zinc phosphate coating and right hand side is Surfix Eco. So here coating structure is basically phospholite and hoplite is formed over the zinc surface, but here is only nano. It's a very small molecule, zirconium hydroxide is formed over the surface. That's why we call it nano coating. Nowadays, people are moving towards the nanotechnology. Why we should use the bigger molecule if the smaller molecule can work better, like this. Coating thickness, it is a micron, 1 to 3 micron coating comes over the substrate, but it comes in nanometer, 30 nanometer coating is coming. And the good thing is it is acid resistant. It dissolves only in HF, but zinc phosphate dissolves in acids. That makes superior from the zinc phosphate, this nano coating. And it is also alkali resistant. Zinc phosphate dissolves in alkaline if you heat it at 80 degree, but it does not dissolve in alkaline. So these two properties make it better from the zinc phosphate. These are the overall benefit if somebody say why I should move. So there are the totally 6 benefits which customer can draw. The first one is there is no heavy metal, nickel, manganese free. There is no phosphate, and it can also run on multi-metal. You can run on GI sheet, you can run on aluminum sheet, you can run on MS sheet on single line. Single line you can run 3 substrate, there is no issue. And corrosion resistance is superior from the zinc phosphate, and reduce uses, only 3% bath is made, and coating weight is also less, only 30 milligram per liter, 40 milligram per liter. In comparison of zinc phosphate, that is coming around 2.53 gram per liter. So 10 times less coating weight, 10 times less uses. And space is also very less space is required, that I will show you. So one can save the space by removing one tank, so it does not require the activation. And sludge is very less, negligible sludge. Only 1/10 of zinc phosphate. Zinc phosphate has a sludge problem. Every time we have to filter it, every time we have to clean it. So there is a little bit cumbersome process, but here is no sludge, negligible sludge. So that way it is easy to operate. It is also nitrate free, phosphoric free, and manganese free. Here you can see the difference, how you can save the space. The above process, we have shown the existing pre-treatment zinc phosphate. This is the process basically. First it degreasing, then water rinse, and we have to give surface conditioning. We are running the paint line, and then zinc phosphate, and then water rinse. But in nano coating, this surface conditioning is not required. So this one tank removal happens, and you can save the lot of space, and that way this coating is better, as it require only 4 tank process. This is basically this is also benefit to use the chemicals in zinc phosphate. The 4 chemicals is required. Surface conditioning is required. pH adjuster is required. And for zinc surface coating, for zinc phosphate coating, you have to use accelerator. You have to measure the accelerator. Without accelerator, coating will not come. But in surface eco, only pH adjustment is required. You can run the coating by adjusting the pH only. No other chemical is required. Legally is also, it is compliant to all the laws. If we talk about the control parameter, if we are running the zinc phosphate line, there are 6 control parameters that we have to maintain, and it is also seems to be a little bit difficult process for operators and industry. But in nano, only 3 parameters you need to maintain. The one is concentration, you need to check how much is the zircon ion concentration. Another is pH, you need to determine how is the pH. And third thing is coating deposition, how the coating is coming. So that can be checked by visually. So from 6 to only 3 parameters, that way it makes the easy to handle. And also we can also move to automation. If we calculate the area, we can also automate the process, by which automatically pH will do a pH adjustment will happen, and line will run smoothly without any involvement. This you can see the corrosion performance. We have compared with zinc phosphate 240 hours. It is basically ED code. You can see left hand side. After 240 hours, if we compare, the creepage has come 1.8 mm and 1.6 mm, but in surface eco creepage is coming 1 mm and 1.2 mm. So it's a clear sign this coating is far better in terms of corrosion prevention if we compare with zinc phosphate. So we have a lot of reasons to change to this coating for paint, for people those are using paints. This is tested on solvent paint. Here also you can see in zinc phosphate, the creepage has achieved 2 mm, that is too big, and in surface eco nano coating, there is only 0.7 mm. It again shows this with also solvent paint film, it shows the superior performance. This is a tuple plot. Basically, tuple plot we draw to determine the corrosion performance of the coating through electrolytic cell. So here is the reading you can see here. The reading corrosion rate is 222 micrometer per year. And here when we applied our Eco 105, the corrosion is 25 micrometer per year. So it is 10 times reduced. But when we apply 10, 106 and 107, it is coming 9.65 micrometer per year. So this is a technique that accelerated corrosion through electrolytic cell. You can determine the performance of your coating, and you can validate the coating with paint. These are our product, 3 technology we have launched, giving more than 1000 hour SSD. And this Eco 105 is giving around 700 hour SSD. And it works on all metals, and concentration is very low, about 2 to 3% you can run. that shows its uses is highly reduced. And this is the look, how coating looks. It looks like a golden color. Anybody can identify. Runs at room temperature. Time is also required very less, 2 to 3 minutes, and concentration is also very less, 3%. This was all from my side. Thank you. Thank you very much.
Yeah, to continue this session, I would like to invite Mr. Ravi Kumar. He is a graduate in chemical engineering and started his career as a research chemist in TI group of companies. His experience is more than 40 years in the metal finishing industry, and presently he is a vice president in Artex Surfing Chemicals. May I request Mr. Ravi Kumar? कहाँ है रवि कुमार जी? आगे. अच्छा, let me receive him all. Oh yeah, good. Welcome. Namaste.
At present, I am with Artex Surfing Chemicals Limited, working as Vice President, looking after Southern region. Today, I will present high-speed alkaline zinc and also alkaline zinc nickel. Alkaline zinc, it's not new. It's nearly 25 years, more than 25 years. It has been working in India itself. But recently, it's going on. We have been updating the chemistry on various reasons. Now this speed, we need alkaline zinc itself. We know that compared to acid zinc, it's around 60 to 65% efficiency. But with this process, we can, our area of working is wider, and we can also increase the speed of the thickness. This is alkaline, yeah. So why we need alkaline high speed? Because we get higher throughput. Cost, because we are increasing the higher throughput, cost is reduced. Process efficiency also increased, and the plating operation also is very highly competitive. High speed alkaline zinc process. See, we can run this process with NaOH as well as KOH. Both the things we can run comfortably. Because earlier some process will not work with KOH, some process will not work with NaOH. This can be used for both the things. Because you know that KOH has some advantages in certain cases. Faster deposition rate up to 20% higher speed. Excellent distribution and throwing power. Ductility, you keep even 20-25 micron thickness. Ductility, even after assembly also we have checked. It gives very good ductility. There is no damage to the plated surface. Works at wider current density, 1 to 5 amps per square decimeter. Earlier process, we were not reaching even more than 3 amps dm square. Now we can comfortably work at 5 amps dm square, so that you get a speed also. So next point, we can work from 6 gram up to 22 metal per liter. See, there are certain parts, certain requirements. We have to work at 6 gram only. And now the same property we can achieve by working at higher concentration up to 22 gram per liter. So your plating time reduces nearly 40 to 50%, achieving all the properties. So even the different type like sheet metal, fasteners, nuts, smallest screws. For example, smallest screw you can, if you plate at 6 gram, it will take lot of time. But the same screw you work at 22 gram, your plating time is reduced. This chemistry helps you in achieving all the complete coverage, all the properties, everything. That is why its advantages and the economy also we are able to achieve. These are the concentrations, zinc metal. This is a standard concentration, but what I told you to 6 to 22 gram is our wider, practically we are working. Additive, carrier additive 10 gram, brightener 1, purifier, then conditioner for new bath makeup, as well as when you add water, extra water, caustic soda you add, like that. It works around 25 degree. You can work even up to 30, 35 degree without compromising on the low current throw, etc. Current density, it is ideal current density is mentioned, but we can work up to 5 amps per dm square comfortably. Cathode current, cathode anode ratio also is mentioned. This is the anode. What we are. This is the anode in the regeneration tank as well as plating tank. You have mesh like this. This while working, you get a lot of oxygen gassing at the anode surface, so that it gets escaped easily. So current flow is better. This is the thickness distribution. You can compare conventional as well as high speed. Conventional you get maximum 2.8, same time same current. Here we get 3.4 micron. You can see 1.5 times higher deposit we are getting. The same thing we are comparing in the fastener, high speed as well as regular. You can see again the thickness rate of increase. One important thing with this process, all type of trivalent preservations can be done. Trivalent, clear, iridescent, yellow, black can be done. We can meet salt spray hours, white rust 300 hours, red rust up to 600 hours. And one more important thing, with selective passivations, there are certain passivations which can, with which we can meet top coat also. COF value, especially fasteners with a thread. Now customers demand particular specific COF value. From 0.09 to 0.24 we can achieve. We give generally 0.12 to 0.14. Now it's more important now because we are assembling steel as well as aluminum. Both we are assembling. So steel and aluminum also should not get damaged because of the. So when you control the COF value, so we tighten the surfaces and no damage for the surface. Now we come, those zinc is over. Now we come to alkaline zinc nickel. So alkaline zinc nickel is demanded more and more because of the it can withstand the higher temperature tolerance, high salt spray, corrosion resistance. Then mostly this recent zinc nickel we work at a 12 to 16% nickel composition. So it gives the maximum advantage of corrosion resistance, thermal resistance, etc. So further, there is a continuous improvement is going on in the complexing agents. So you get uniform nickel distribution. There is no irregularity in the nickel distribution. So types of zinc nickel, it's a history actually. Earlier it was second generation, now presently third generation. Earlier second generation efficiency was 65, now it is 95% faster, so more uniform. So the same current second generation, if you work at higher current, actually 4 to 6 amps per dm square you have to work. Second generation you cannot work at 4 to 6. People were working at 2 amps per dm square like that. So that all have been covered now. We are comfortably working at 4. So thickness distribution also uniform in the third generation. So another comparison. Second generation, it was not stable. Now the third generation is bath is more stable at different little flexible to temperature, current difference like that. So earlier it was 2 amps per dm square. Now it is up to 6 amps dm square. We can work almost same comparison points are there. Earlier, when you second generation, when you work at more than 2 amps per dm square, it will burn porosity. So salt spray you will not get. Even in the post dip activation also it will turn blackish. Now all this has been rectified. Third generation gives a proper coating. Again, advantages of present third generation zinc nickel system: excellent corrosion protection. It's very smooth. Also, we get bright like very bright acid zinc or semi bright nickel like that. We get very bright finish in the thing. High thermal tolerance. Hardness also is better. Zinc hardness was around 550 to 100 vickers, whereas zinc nickel it will give more than 150 vickers. So it is better. Low tensile stress of zinc nickel, minimal hydrogen de-embrittlement, because when the deposit starts, first the nuclei deposit is nickel, unlike plain zinc. So straight away the nickel deposits, hydrogen evolution is reduced. So hydrogen de-embrittlement also little bit controlled, is better than zinc. Good passivation. This process, third generation, has a good passivation acceptance. We can give bright blue, gray, black, even light iridescent also we can give. Zinc nickel coating prevents galvanic corrosion of aluminum parts, which I will explain in the next slides. Next slide is coming. With zinc nickel, we were able to easily replace cadmium. Earlier, cadmium plating was done mainly because of the high corrosion resistance, heat resistance. All those things have been replaced with zinc nickel, alkaline zinc nickel, sir. Compared to acid zinc nickel, it's economical slightly because of mainly on account of uniform thickness. Field of applications. Zinc nickel is demanded in automotive industry, aerospace, hot zone application, that is engine, car engine, automotive engine parts, all instead of zinc we would do zinc nickel. It can withstand because higher tolerance to temperature. Electrical electronic industry, same reasons. Farming applications also, because tensile stress of zinc nickel is less, so you can easily bend. There is no it not crack or anything like that. Pre-paint due to higher corrosion resistance, the whole car body is pre-paint coating has been we can do with zinc nickel, and also fasteners and hardware. So this is one important actually you can note down. This whole wheel is aluminum alloy. Earlier they used to tighten with zinc plated fasteners. See, this zinc, it will induce galvanic corrosion on aluminum. Not only the fastener, even the zinc surrounding zinc also used to corrode. White rust will now the same zinc plating you replace with zinc nickel. So zinc nickel is lesser electronegative, so reactivity is less. It protects the surrounding aluminum also better than the zinc plating. So nowadays you can see in the automotive more and more aluminum parts are used. So I feel this zinc nickel will be highly useful for this application. A thickness distribution 1.5 from high current to low current, 1.5 to 1 ratio, 12 to 15% nickel alloy. Hardness, as I told you earlier, pure zinc is 100 wickets, alkaline zinc nickel is 450 to 500 wickets. So it's more hard, durability is more, everything is there. White rust, corrosion resistance also. White rust is 250 to 400 hours, zinc nickel. With different passivation, 201 clear passivation, 250 iridescent, even black also 250 hours. Our another trivalent passivation with nanoparticles and all, up to 400 hours, white rust. So it increases your red rust up to 2000 hours for 8 to 10 microns. This is the parameters of our zinc nickel bath. Operating conditions, this also. So nickel instead of zinc will be coming from the regeneration tank. We don't put in the plating bath. So zinc will be controlled from regeneration path. Nickel anode only will be kept in the plating path. Nickel anode does not dissolve in the in the plating process. So, I explained, regeneration. The area of zinc anode, the zinc we put in the regeneration should be based on the amperage we apply, 0.3 in the total amperage. Suppose in a plating bath we give 1000 amps, the zinc anode area should be 0.3, 300 square decimeter. Yeah. So the regeneration tank should be around 20 to 25% of the bath, real bath. So it can match with the consumption of the zinc by the process. So it will maintain the within the spec. This is the impurities limit. Iron 100 up to 100 ppm, copper, lead, sodium carbonate also 6 to 60 gram per liter. Sodium carbonate increases, it will reduce the efficiency. Some gray formation also will be there. So once it crosses 60, you have to proportionately dilute. Some people are 20% weekly or monthly, they maintain this. Trivalent passivation, I told you already, even clear.
All knows that there are many different fields of applications for this technology. Today, my point for my presentation is only two things. The one thing is the cost-saving matter of energy saving, and another thing is for the environmental protection. As we all know that those kind of organizations like EPA, CARB is also the rule from the USA, and EU directives. Those of organization or rules strictly want to control the VOC emission to the air. So many of countries are controlling that kind of VOC emissions and want to guide the people to use more eco-friendly products. Actually, in this field, we can choose two options of zinc-free coatings. Many know that the zinc-free coating technology started more than 50, almost 60 years ago. So until now, we have been used two choices. First one is the solvent-based zinc-free coating. And the second option is the water-based zinc-free coating. These two technologies are good enough to protect the irons. They are all good technologies. However, both technology have one weak point. The light one is the solvent-based zinc-free coating. It has been a best choice for us till now, as it can be cured at a little bit lower temperature compared to water-based. You can see here the water-based coatings ask for about 340 degree temperature to cure the paint. However, the solvent-based only ask for less than 250 degree Celsius temperature. So solvent-based have more strong point for the cost saving, energy savings. However, water-based, we can say, surely can say, as it is water, the eco-friendly. However, need more energy. So our company focused on to solve this issue by making a water-based paint which can be cured at almost same or lower temperature of the solvent-based zinc-free coatings. So we spent more than 5-6 years to develop our new products, and we are now already supplying to the market in Korea and some other countries. So we made the water-based paint which can be cured at 250 degree temperature. Surely it is chrome-free and PFOS-free also. Easily say we have a table. Here the black bar, here the table says the brioche content in the solvent-based paint. And in the middle, our geocode system have about 10% of brioches inside. And other conventional water-based paint, 10 to 20% around. So how geocode technology is developed, we made lower the brioche emission. And also we got energy saving. And as well as we achieved 1,000 hours of SST target, which everybody uses as a standard. So here I wish to briefly explain to you how we made the energy saving low temperature curing water-based paint. The key point, our technology was our own synthesized epoxy silicon oligomer based binders. Conventionally, in general, the other water-based paint may use the silicon monomer technology and a similar one. However, by making our own binder system like epoxy silicon oligomer, we were able to make our paint to be cured at a lower temperature and more faster. So this is a little detailed chemical expressions. This is the table which shows that blue is our product. So ours can be cured a little faster and a little lower temperature than others in the market. So we just checked this energy saving effect and reduction of CO2 gas emission to give you a simple idea. By lowering the temperature to the level of a solvent-based paint, we just saved about 27% of energy. That means the 140,000 pine trees, which can offset the occurred CO2 gas. It is same as like this. It's just for sample of the SST test results. Yes. So as these days, the car OEMs, as we are in Korea based, we sometimes do the co-work with the Korea car maker Hyundai and Kia company. Actually, there was a request and need for the brake disc applications. Some customers made a complaint that why there is a noise from my car brake systems. Is there any good solution? So Hyundai R&D Center wanted to check the deformation possibility of the brake discs. So with the brake disc manufacturer and Hyundai Automobile and some chemical providers like us, check the possibility of deformation of the brake disc, which is painted and cured at about high temperature, curing like the 340, 50. So they checked what difference can we find when we use a little high temperature curing and low temperature curing of paint. So they checked those two paints and did the run out test of the brake discs. And finally, they checked by using a little low temperature curing, we can reduce about 53% of that run-on issues from the disks, from current, and with low temperature curing. So recently, the Hyundai Motors and Kia Motors are focusing on making EV battery module casing. They use the float reel screws as it need to come into the battery module casing. So it has very high tensile strength. So that high tensile strength should be remained after the coating. So they choose the low temperature curing water-based zinc-free coating, and it still works, and they are using it. So this is the almost final. So I just wanted to show you with this this one once again. We gave the those energy saving and eco-friendly with our product. Okay, so I have one more thing to tell you. We are now promoting one more new item. So we made a room temperature curing zinc-free coating. As sometimes some big size of parts which you cannot use the oven for the paint curing or baking, or there is some big size fasteners or something which already assembled on the vessels. In the case, you need a special anti-corrosion paint which can be cured at room temperature. Normally, those kind of paints are being cured by the baking systems. However, this one, we call it zero-coat empty system. You can cure these paints at room temperature at a low room temperature only. So we made this paint to be used by a spray can. So you spray the paint on the target parts, and after 10 minutes, the paint will be dried, started to dry. So you don't need to deassemble a big part on the vessel or those things, or any good part can be easily applied. However, we try to maintain the same minimum 1,000 hours of SST request from the market here. These are just comparison of using this room temperature curing paint. Yeah. So that's all what I want to say today. So I wish you enjoyed my simple presentation today. Thank you.
Thank you. Kevin, stay here. Just wait. To continue this session, next speaker, we have Mr. Yosuke Yamahuchi, who is currently the Assistant Manager in charge of sales of plating chemicals and anti-rust agents at Daiwa Fine Chemicals, a manufacturer and selling of surface treatment chemicals based in Japan. He is a seasoned plating chemical engineer who has more than 12 years of experience in chemical industry. Mr. graduated from master's program in applied science at University of Hyogo in Japan and joined Daiwa Fine in 2013. After joining Daiwa Chemicals, Mr. Yamaguchi was involved in development of plating solutions such as non-cyanide silver plating for 10 years and now in charge of technical sales in Southeast Asian region. He has also obtained corrosion control specialist from Japan Association of Corrosion Control and has an extensive knowledge about the metal rusting and all. Welcome, welcome. Oh yeah. Oh. I would also like to invite Mr. Chauhan, Sanjeev Chauhan here, along with Mr. Yashomi to deliver this keynote address. And of course, this is a different subject than the three previous subjects we have heard so far. I think it's die casting. Yeah. Okay, please start. Thank you.
Thank you very much. The kind introduction. It's a great honor to be here today. And I'm truly grateful for opportunity to speak at ISF. Today, I'd like to introduce non-cyanide copper plating and non-cyanide silver plating solution as environment-friendly chemistry. I would like to introduce our company. Our company is established in year 1963. Approximately 200 employees. Sales are 38 billion Japan yen. This is our company network. Headquarters is located in Kobe City in Japan. At our laboratory, we are developing and researching, manufacturing our own products. Metal finishing product, anti-corrosion chemicals, and UV absorbers are manufactured in Aka's factory. Daiwa Special is one of our group companies and produce mainly acid copper brighteners. As overseas base, we have subsidiaries in Taiwan and Thailand. Daiwa Fine Chemicals Taiwan manufactures tin plating chemicals for semiconductors. Daiwa Fine Chemicals Thailand is mainly a distribution point for plating chemicals and corrosion inhibitors for Southeast Asia markets. Our main products are divided into three items: plating chemicals, corrosion inhibitors, ultra absorbers. Today, I'd like to introduce the detail of plating chemicals, about non-cyanide silver plating and non-cyanide copper plating chemicals. I'll talk about cyanide bus. Many plating bus used for industrial sectors contain cyanide compounds even now. This also applies to silver plating and copper plating. Because this extremely
makes stable complex with a variety of metals, and it can be formed uniform plating film. However, cyanide has strong toxicity, so it's causing many problems on health and safety at work. Also on wastewater treatment. Furthermore, strict control is necessary for wastewater. An unexpected leakage can occur by a human error or a natural disaster like an earthquake. It causes serious effects on human health as well as an environment pollution for a long period of time. Even now, many kinds of cyanide-free baths have been studied. However, non-cyanide silver plating and non-cyanide copper plating baths was difficult on bath control at initial period, and film properties such as throwing power, deposit ability are not as good as cyanide baths. However, we succeed non-cyanide copper and non-cyanide silver plating for industrial scale. It's impossible to obtain from conventional cyanide-free baths. I'll introduce a non-cyanide copper plating process. This process is possible direct plating on aluminum and thin die casting. This is a lineup of non-cyanide copper plating. There are two types, neutral and alkaline type. The neutral type is strike copper plating on thin die casting. The alkaline type is thick copper plating on iron, brass, and aluminum. The appearance of alkaline copper plating depends on the substrate, but can range from matte to slightly glossy. This is strike copper plating solution, dyeing copper PSRSD. Dyeing copper PSRSD consists of two chemicals. The base chemical is dyeing copper Lg3 and the copper salt. Copper salt is sulfite pentahydrolate. Potassium hydroxide is required to adjust the pH. The bath temperature is 45 degrees. We recommend lithium oxide anodes, but carbon anode is also fine. This is copper plating, a thick copper plating, NC100. To make up the NC100 bath, simply add water to the base chemical NC100Mu. The anode uses an oxygen-free copper plate. This is an example of the non-cyanide copper plating process on thin die casting. This is test to check the replaceability.
when a zinc plate is immersed in a copper plating solution. In the cyanide plating solution, copper is immediately replaced on the zinc plate, whereas with PSR-SZ, there is almost no replacement even after immersion for 5 minutes. These are the results of testing the adhesion of copper plating on zinc die casting. It can be seen that good adhesion was obtained in all tests. Next, I would like to introduce the non-cyanide silver plating solution. This lineup is acid type. Acid type is our unique non-cyanide silver plating solution. It's impossible to obtain from cyanide baths. Strike silver for preventing replace plating. The appearance of matte, semi-bright, bright are lined up. High-speed plating is possible at matte and semi-bright plating. For one example of acid type, we can point out dry film resistance. Cyanide bath doesn't have this property because cyanide bath is strong alkaline. Deposits silver plating out of resist pattern by swelling resist pattern substrate. On the other hand, pattern plating is possible because our cyanide free is acid type. As another acid type property, direct plating is possible on stainless steel. This figure shows an excellent adhesion to stainless steel compared with cyanide bath by checking bending tests and heat resistance tests. Stainless steel easily forms an oxide film in alkaline conditions. Our slide silver plating is acidic, so it's possible to plate in a way that prevents the formation of oxide film on the stainless steel. For the next, I would like to introduce alkaline type. Alkaline type has matte bath and bright bath. These have good throwing power equal to cyanide type. They can be plated by barrel plating. Dine silver BPL gives matte appearance. Dine silver HKR gives bright appearance. These show Vickers hardness from various kinds of our non-cyanide silver plating bases. You can see the same or spherical hardness to cyanide baths can be obtained from non-cyanide silver plating bases. Our products have adapted in various fields, such as heavy electronics parts, machine parts, and decorative field.
This is one of application examples. Our quality has accepted a wide range of industrial fields. Regarding acid type, it's accepted because it's possible direct plating to stainless steel, dry film pattern plating. It's impossible to obtain by cyanide bath. Alkaline bath has increasing recently as a conversion from cyanide bath type. Mud type used by barrel plating because of good covering power. Bright type has adapted for heavy electrical busbar and others. This is an example of silver plating process. Please perform the appropriate pretreatment depending on the material. For example, silver plating can be done directly on nickel or copper plating. Finally, I introduce the anti-tarnish agent for silver. Generally, silver is easy to sulfurize. For example, silver can react with hydrogen sulfide and generate silver sulfide, then discard to brackish appearance. It's a point of disadvantage. It also affects surface functions such as soldability and electrical contact resistance. Neodyne silver series are anti-tarnish agent for silver. To relieve from these troubles, simply immerse the materials in the solution and anti-rust coating will form. Neodyne silver is general purpose product. It can be used at room temperature. Neodyne silver S1 is the best selling product on this series. It forms a water repellent film and is more effective at preventing discoloration than Neodyne silver. Neodyne silver alpha is the most effective anti-tarnish product in this series. Diofine Chemicals Group has developed various kinds of plating solutions, starting with non-cyanide silver, with pursuing environmental and human products and technology. For the future, we will continue developing attractive and unique products to contribute further progress of surface finishing technology. Finally, we are exhibiting at ISF 2026 in collaboration with Galvanotech. If you have any questions in India, please contact them. Thank you very much for your kind attention.
Thank you, Yoshima. बैठे तो हैं सामने दिया नहीं है उन्होंने दिया नहीं है Yeah, we have the last session and last speaker as of today. I would like to invite on stage Dr. K. Vishwanatha Aithal and his subject Evolving Requirements of Electroplating in Electronics, Semiconductor and PCB. Mr. Aithal is a well-known manufacturer of electroplating plants and some of the technologies he has developed for specialized electroplating processes. So welcome, Mr. Aithal. अच्छा अच्छा बड़ा लेट बहुत लेट किया है इन्होंने मिस्टर Yes, Mr. Aithal. मैं कह रहा था कंप्यूटर से कब आया देना नहीं था ओ तो ये ले अरे Please have a patience for 5 minutes. It's taking a little more time to, अरे welcome, sir. Welcome, sir. Please, all yours.
Hello. Good evening. Because it is the end of the day, I think it is a very small gathering we have. And I also thought of changing the subject, what you have been indicated here, because as I went through the different speakers today, I found that subject what I have selected in the beginning about the evolving technology for in electroplating for semiconductor and PCB and other things. The many chemical suppliers have already spoken about this. So it may be repeating the same thing if I continue that one. So I just thought of changing a little bit about the automation or something like making the suitable equipment for electroplating. So just to give an introduction of my company, we are VPS Technology India Private Limited, a 35 years old company in Bangalore. We started with cleaning. In fact, we have our experience in the electroplating with the multinational companies, chemicals on electronic plating or decorative plating for the precision about gold and silver and like that, rhodium and other things. So after that, we started with a cleaning technology to replace the freon or trichloroethylene. So this is what our we started our industry on the cleaning technology. Then being having the experience for about more than 40 years in the electroplating field for the printed circuit board, we entered into the manufacturing of the equipment for cleaning as well as electroplating. So we now supply the specialized electroplating equipments all over the world. So that's why I thought we, instead of taking this one, we thought of taking the new subject of equipments. So the earlier equipments we used, in fact, we were the first people to import the automated electroplating line in the field of printed circuit board during the years of 1980s, 81, 82, like that. So then afterward, we are now started exporting the same machines to same countries like UK or USA also. So that is about, we all just made a presentation just to indicate that what are all the type of machines we are building. So there is just an idea about type of electroplating line we are doing with the controls, with including the SCADA and everything in that. So this is about the market of the electroplating equipments. Still, I can see many electroplating equipments have been imported from Europe or China or Thailand, even Korea. So we can see the at present global market is divided by these people. So we thought of developing the new type of equipment. So this how our machines started coming to the market, and we have been making different type of machines. And we developed some special machines where we need very ultra pure atmosphere or controlled atmosphere and other things. These completely sealed machines, and where flame proof and other things are also considered. So which is not there here in the specification, but I can only explain about it. And we further developed the one more equipment in India, which is otherwise was imported, is the horizontal plating of the piston rods using the hard chrome plating with the horizontal plating. This is a line which we developed in India and working in India, and we are trying to improvise it and supply it for the Indian market. This, at present, people used to have dig a long hole of 6 meters and do the chrome plating, and we have developed this horizontal plating equipment. It is being used in India. These were some semiconductor components. We have the plating equipments. And we take all these things of total fabrication, PLC logic, SCADA and MES data and everything has been included in our plating systems. Another semiconductor machine. Okay. This is our team. This is some of our equipment for the aerospace component. These are all NADCAP approved equipments. This is a special equipment which we built in India and installed in China for a special process that is for ultra pure cleaning of for PVD, CVD coating. So this is one of the video I just played, and Not necessary. Okay, that is second one. So now, okay, this is normally many people have played this type of video regarding the plating of the semiconductor and things. Next slide. Okay. I think we have already discussed about this because I saw the other lecturers, this one, lecturers subjects which should have been covered in this. And I was also a little busy and just came inside after some meeting. So this I can say how we can build the traditional plating to high-tech plating. Why this matters in India? Okay, this is the thing now. We are going to electronics. So everybody talks about this. So that's why I selected this subject. But because of the time, shortage of time, plus the end of the day, I thought I will limit it for as less as possible. PCB technology, it is okay. I was involved before 1990s. After that, I was not much in the PCB field, but still something behind me, the original subject of about 30 years in that line. So these are all the things which has already saw somebody has put in his speech also. About the copper plating, just now we heard also about the copper plating. Semiconductor packaging opportunity, I have done very little work in this, so cannot speak much, but still I am working on the cleaning of the wafers. We are developing a special cleaning equipment for wafer cleaning, getting the structures on that, and we are going in a big way for cleaning of wafers and the other necessary equipment after the coating, stripping of the coating machines, and I think it is a new market. We have got it, so we are expanding in that. Even in all this field, we are having a quite good challenges, and we have about 10, 15 engineers developing the new machines and giving the good machines for as an import substitute for from either Thailand or Taiwan or Korea. And it's actually EVs. We have also made some special battery strip plating for the EV vehicles or the railway battery vehicles. So this is one of the equipment evaluation. We are thinking about it. So this is what we have to say, many different pulse plating and clean room environment. That's what I have shown in some of the video photos earlier. We make the machine itself in class 100, 1000. So at present, we are doing some machines for semiconductor field where the wafers are cleaned and packed in class 100, 1000 atmosphere, humidity control and other things, and all. Not even oxygen is used, oxygen, not even air is used for drying. We have to use neutral gas like that. So those type of machines we are doing for the semiconductor industry or semiconductor equipment manufacturers. Okay, this is all comes under the plating. Already somebody has spoken about the zero discharge, green and everything. So this is the roadmap for metal finishers. Many people are expanding. Wherever I go, every time I get a new requirement In fact, we are working for some Japanese companies nowadays for special surface treatment. Just to take the manganese phosphating, they want a very special machine. So somehow we are able to do that one and get the order and then supply it. So everybody looks for something special, not a normal thing. For the equipment manufacturers in India, there is a very vast scope. We are being a small company of 85 people, having a handful of orders. So there is very good scope for the people to expand and do the new plating system. Okay, measuring equipments and other things, everybody knows about it. Yeah. And this is the brief end of the day. I thought of leaving you also go home early. So I hope I just taken few minutes of yours to come here and make a presentation. I didn't want to miss it, even though in my busy schedule I just ran down to here. So I hope it is interesting to you. And if any information is required, you can contact us, VPS Technology India Private Limited. We are about 20 kilometers away from this place in the same road. So we are having about 3 sheds. If you want to know about our company, I can run a slideshow. Is it okay, or is it okay to place the things in the seminar here? I have not touched it because I do not want to put the company advertisement in this.
Thank you, Mr. Aithal.
Yes.
Friends, we will meet tomorrow at around 9:20. Please enjoy your day. Thank you very much.
आज भेजा को बताया